registrar, principal, vice principal, deans, heads of various departments, faculty members, all the delegates, renowned speakers, and students who have joined today to be a part of this conference. AMET is India's first maritime deemed to be university for maritime related education, training, and research. It is the only university from India to be a member of International Association of Maritime Universities.
Hannah, thank you so much. Just wanted to check the audio. So audio is good and let you know when you are supposed to start. Thank you, Hannah. Aaron, sir?
Yes, ma'am.
Yes, sir.
Let us wait for the speakers to join. Okay, let us wait.
We will, stop the slide now.
Yeah, sure.
Yeah. We will wait for Dean ma'am's instructions, sir, before we start.
The guests are joining. Okay, let us wait for 5 more minutes.
Thank you, sir. Thank you, ma'am. Principal, sir, was the audio clear?
Yes, yes, madam. Audio was very clear.
Okay, sir. Thank you.
Thank you.
Sir, audible are sir? Audible, sir?
Yeah, audio is clear, sir.
So please listen to me. Sir, system manager, sir.
Sir, madam.
Please add Vice Chancellor as the panelist. Make it fast. Yes, sir is there. Welcome, sir.
Good morning, sir. Good morning, sir.
Good morning,
Good morning,
sir.
sir.
Hello, madam.
Yes, sir. Good morning, sir.
Morning, sir. Morning, sir. Good morning, principal, sir.
Yes, sir.
Good morning, sir.
Yes, sir. Yes, system manager. Vice Chancellor is available. Our other guest, Dr. Dinesh Babu, sir, is available. Welcome, Dinesh Babu, sir. And our chief guest has to join, Dr. Paneer Selvam, sir. He is joining within a minute. Let us wait for him.
Yes.
Good morning, everyone.
Good morning.
Good morning, sir.
Good morning, sir. Good morning,
Morning,
sir.
sir.
Hello.
Yes.
Hello.
Yes, sir. Good morning. Who is it?
Welcome, sir. Paneer Selvam, sir. Dr. Paneer Selvam, sir. Welcome, sir.
Yes, sir. Welcome, sir. Welcome, sir.
Thank you. Thank you.
Good morning, sir. Welcome, sir.
Just 1 minute. I'll just make some adjustment for my camera.
System
Yes.
manager,
Hello, madam.
please add Dr. Sanjay Bhavnani. He is available as the attendee
Sanjay Bhavani.
panelist.
So, good morning. Good morning, everyone.
Yes, sir. Good morning, sir. Good morning,
Am I-
sir.
Good morning, sir. Good morning.
Am I audible and
Yes.
video
You're very
is
much audible, sir.
clear? Thank you. Thank you.
Yes, sir.
Excuse me, someone, ma'am, someone can please add Ashok sir to the panelist.
System manager, sir. You please add Sanjay Bhavnani sir as the panelist.
Ma'am, I have added, ma'am.
But he is not available. Yes, sir.
Sir is in, ma'am.
Yeah. Good morning, Dr. Sanjay Bhavnani sir. Shall we start?
Yes, hello, good morning. Can you hear me?
Good morning, sir. Good morning, sir.
Good morning. Are you able to hear me?
Yes, sir. We are able to hear you, sir.
Thank you very much. Wonderful to be here today morning.
Thank
Just
you,
something
sir.
wrong with my camera. Just give me a couple of minutes.
No problem.
I'll be on the screen very shortly.
Yes, sir. Thank you, sir. Thank you.
Thank you very much.
Dr. Sangeeta, you please start.
Yes, ma'am. Thank you, ma'am.
Good morning to one and all present here. I welcome you all on behalf of Department of Marine Engineering and Ahmed deemed to be University to the International Conference on Disruptive Technologies in Maritime Sector, Industry 4.0, which aims in providing a premier interdisciplinary platform for seafarers, scientists, academic experts, industry peers, research fellows, and students to share the latest research and information on recent innovations, practical challenges encountered, and solutions adopted in the field of recent technologies in maritime industries. I bid a very warm welcome to the honorable members of the management, Vice Chancellor, Pro Vice Chancellor, Registrar, Principal, Vice Principal, Deans, heads of various departments, faculty members, all the delegates, renowned speakers, and students who have joined today to be a part of this conference. AMET is India's first maritime deemed to be university for maritime-related education, training, and research. It is the only university from India to be a member of International Association of Maritime Universities.
Tamil is not just a language, but a civilization. It is love. Within it evolved the noblest of ethical and moral values. Ever seeking knowledge informs valor and strength through the light of knowledge. To honor such a Dravidian language, now we will have a recitation of the state anthem, Tamil Taival.
நீராறும் கடலுடுத்த நிலமடந்தை கெழிலொழுகும் சீராறும் மதனமென திகழ்வரத கண்டமிதில் தெக்கணமும் அதில் சிறந்த திராவிடனல் திருநாடும் தக்க சிறு திரை முதலும் தரித்தனரும் திலகமுமே அத்திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழனங்கே தமிழனங்கே உன் சீரிழமை திறம்பியந்து செய்ய மறந்து வாழ்த்துதுமே வாழ்த்துதுமே வாழ்த்துதுமே.
Thank you. May I now invite the conference chair, Dr. T. Sasilata, Dean Academics, Ahmed University, to deliver the welcome address. Ma'am, please.
Thank you, ma'am. Very good morning to all the dignitaries and participants present here. The Department of Marine Engineering, Academy of Maritime Education and Training is organizing a 2 days international conference on disruptive technologies in maritime sector, Industry 4.0. I am extremely happy to be part of this international virtual conference. I am extremely glad to welcome our Honorable Vice Chancellor, Colonel Dr. G. Trivasagam, Registrar, Dr. M. Jayaprakash Vel, Principal, Chief Engineer Professor Bhupati Bhaskaran, Director Professor K.R. Chidambaram, Vice Principal Captain Karthik, Deans and heads of departments, faculty members, all the delegates, and renowned speakers and students for the 2 days international conference on disruptive technologies in the maritime sector, Industry 4.0. I am much honored to welcome all the guest speakers and the keynote speakers for the technical sessions. I take immense pleasure in welcoming our chief guest, Dr. Panneerselvam Ramasamy, Principal Director of MSME Technology Development Center, Agra. At this juncture, I am happy to inform that our university is recognized as the host institute for business incubation by MSME New Delhi right from 2019 onwards. On behalf of our university and the conference organizing committee, I welcome Dr. Panneerselvam, sir. Welcome, sir. Thank you for your august presence. I feel honored to welcome our chief guest, Chief Engineer Dr. Sanjay Bhavnani, Director and Chief Operating Officer, MMS Maritime India Private Limited, and Chairperson, FOSMA Mumbai, India. We are very happy to welcome you, sir. Welcome, sir. I welcome the guest of honor.
Harish, sir,
Sir, sir.
please look into it.
Network stuck ஆயிருக்கு. வருவாங்க. Sir, some Wi-Fi error, sir. Ma'am will join in few seconds.
Okay. Sangeeta, madam.
Yes.
Yes, madam. Can you see? I mean, call up and see what's the situation.
Yes.
We can go to the next step maybe.
Yes, sure.
Yeah.
Professor Suresh, sir.
Ma'am, join பண்றாங்க.
Yeah. Okay, madam is joining.
Okay, ma'am. ஹரிஷ் சார், மேடம் பேனலிஸ்ட் ஆட் பண்ண சொல்றாங்க. ஹரிஷ் சார். System admin, please add Dean ma'am as a panelist.
Sir, I welcome everyone present here. Welcome you
Yeah.
all.
Yeah.
I'm unable to join. Welcome you all. Please proceed.
Thank you, ma'am.
Nothing beats a team player. In a workplace, an ability to work well with others is an indicator of success. He has served in the maritime industries for 30 years. During his tenure, he has served at various positions and served at the responsibility of a chief engineer in LPG/G gas carriers, oil bulk ore carriers, steam turbines, dove tankers, and so on. It is a matter of great pleasure and honor to welcome Professor Bhupati Bhaskaran, Principal DGS Courses, Amite University, to address the gathering. Sir, please.
Yes. Good morning to one and all. I hope I'm audible and video is also clear. It gives me great pleasure to extend you a very warm welcome on behalf of Department of Marine Engineering, which clubs all of us for the international level virtual conference on disruptive technologies in maritime sector industry 4.0. Amite is India's first deemed to be university in maritime education. The Department of Marine Engineering was established with an aim to facilitate and promote maritime studies with training to produce a remarkable engineering officer by imparting skills required to operate and maintain missionaries in modern ships of merchant marine fleet. The International Conference on Disruptive Technologies in Maritime Sector Industry 4.0 is providing a premier interdisciplinary platform for seafarers. The main word is interdisciplinary platform for seafarers, scientists, academic experts, industrial peers, research fellows, and students to share their latest research and information on recent innovations, practical challenges encountered, and solutions adopted in the field of recent technology in maritime industries. Further, advances in multiple fields of science and engineering will be promoted through quality research. The conference will provide network opportunity for global collaborations, develop suitable solutions for diverse applications and modern technology, and help in providing solutions for sustainable developments. All submitted papers will be reviewed by double-blind peer review process to maintain high quality publications in Scopus level journals. ICDT-MS 2021 consists of variety of thrust areas such as track 1, smart technologies, track 2, intelligent logistic material and production, track 3, industrial automation, track 4, renewable energy systems on board ships, track 5, methodology and weather forecasting, track 6, marine pollution. Now I would like to welcome our Chancellor Sir, Vice Chancellor, Dean Academics for the inaugural function. I also extend my warm welcome to Dr. Pannirselvam Ramamurthy Sir, Principal Director of Micro, Small and Medium Entrepreneurs Technology Development Center, Uttar Pradesh. Also, I am glad to invite Dr. Sanjay Pavani, Director of Chief Operational Officer, MMS Maritime Private Limited, Mumbai. I am also very much delighted to invite Dr. Era, Professor, Department of Information Technology, Ghana Maritime University, Poland. Now, I hand over the mic to the organizers. Thank you.
Thank you, sir.
He is a person of academic and administrative eminence who brings with him his dynamic experience of 5 decades in higher education. He strongly feels that theories must be integrated with practice. He is a strong supporter who believes that the university should provide maritime education, training, and consultancy based on the local and global business. May I now take the privilege to invite our Honorable Vice Chancellor, Colonel Dr. G. Thiruvasagam, to deliver his presidential address. Sir, please.
Good morning to every one of you. Am I
Good
audible?
morning. Yes, sir, you're audible, sir. Good morning.
Yeah. I'm extremely sorry. Just I was traveling. Due to urgency, I was supposed to go out. And luckily, I completed my work. I returned home. And thank you very much for allowing me to include now and asked me to make my presidential address.
We welcome you, sir.
Yes, sir. Beloved and respected Professor Pubadi Bhaskaran, the principal of Amity University, respected Dr. Sasilada, Dean, Academic and Curriculum Development of our university. Of course, the Chief Coordinator and Organizer of this conference as well. I'm sorry, we have a lot of experts from outside Tamil Nadu and outside India as well. And already we are late. So please allow me to just give my respect like most respect and revered resource persons from different organizations, institutions, India and outside India, learned colleagues of Ahmed University, above all, respected participants of the conference. Indeed, I am happy this conference is able to attract almost 270 participants. Indeed, it's the first time a conference of this nature has this number of participants. Shows how much strain and pain taken by the organizers in organizing this conference in a bigger way and invited really appropriate and suitable resource person to be a part of this conference, for which I would like to register my sincere appreciation and thanks to Dr. Sasilada, Professor Pubadi Bhaskaran and their team for having made this program very useful, purposeful. Of course, it's going to be successful as well. The title taken for this conference, I can say very well, it's a timely one also. Especially disruptive technologies are nowadays debatable. One sector of people, of both industries, academicians, they feel it's not that much good enough for the industries and for the inventions as well. But another major section of the people are telling, all because of disruptive technologies only, we are able to think about it differently and new things are coming out. Yes. For an example, we have been getting our product from the nearby Annachi Kadai or from a supermarket. Or sometimes we travel for a long distance from Adayar to some other place of northern part of Vadasarabakam. Nowadays, thanks to technology, we are ordering online. Next day morning, Amazon or Flipkart, someone delivered without any strain and pain we are getting. So this is the technology. This technology, of course, the traders and associations of traders, they are vehemently opposed because it spoils their business. Whereas the consumers who are very much cost conscious, are very much time conscious, they very much welcome it. So this is an example only I am telling. Likewise, anything is possible through our internet, through even our mobile phone as well. So these are all various practical aspects we come across. Then come to maritime sector. And maritime sector, it is a traditional, yeah, well-established industry, and everyone know without maritime industry you can't live. Especially, we cannot live during the COVID pandemic situation. You know pretty well, 2 months ago, or take it as 1 month ago, there was no air transportation, there was no rail transportation, even there was no road transportation. But there was a strong need of transportation of goods and services, even medicines meant for corona treatment, even equipments meant for corona treatment. All because of the whatever corona comes, whatever waves comes, something is sailing in the sea. It is nothing but shipping, shipping, shipping. Shipping industry is the main backbone. Shipping industry is the Taraga Mantra for all the requirement of the individual and establishment, even for the countries as well. Such a way, shipping industry is very, very, very vital in all the seasons, in all throughout the world as well. As Maritime University, we can be very proud. Why? For this renowned industry, we are the major participants. In the sense, we have contributed almost 15,000 manpower to the global shipping industry. Most of them are sailing either in the capacity of a chief engineers or in the capacity of a captains. So our own products, you can very well find at least 3 or 4 Ametians sailing in different parts of the world in renowned shipping companies. So we can take the pride. I can pass on the proud and the prideness to our principal, Professor Bhumadi Bhaskaran, who is the leader and prepared those products and sent to the shipping companies. Okay, fine. What way Industry 410 in the shipping industry? Very simple, sir. Now, all the ships the ship of those days are slowly getting converted into electronically operated ships. That's the reason in academic side also, there is a new opening. So far, we have been running a program meant for marine engineering and nautical science. To meet out the latest requirement of shipping industry and shipping construction, we have introduced a program called ETO, Electronic Technical Officers. That also Amet University is providing. So we can very well say that we are always far ahead in fulfilling the requirement of the shipping industry. Likewise, one more invention. It is in the process. Of course, it is already succeeded in the name of autonomous shipping ships, autonomous shipping as well. The days are not far away. We need not have any crew in the ship. Will be operated from the offshore, okay, and it is going to be totally automatic and not manually supported, but of course supported technology as well. These are all so many things of benefit we are getting out of the disruptive technologies. I am very much confident today the deliberations, participations would be very much useful, and the deliberation will be taken place with the participation of all the resource persons and the faculty members of other universities. I am very much confident again and again the purpose of the conference will be very much useful and purposeful. With these words of introductory remarks, I am very glad and convey once again my sincere compliments and thanks to the organizers of the program. Wish you all best of luck. Thank you very much indeed.
Thank you, sir. Thank you, sir.
Thank you, sir.
I take immense pleasure in introducing the veteran of micro, small, and medium enterprises, Dr. Panneerselvam Ramaswamy, Principal Director, MSME Technology Development Center, Agra, to the gathering. His organizational experience extends to a span of 32 years. His strategic thinking, planning, and execution has turned Agra Center into one of the most success-oriented centers. He is a good administrator with a proven track record of conducting skill development programs under the Ministry of MSME. He has organized many specific training programs for women empowerment, and more than 100 women entrepreneurs were trained. May I now request Sir to deliver his inaugural address. Sir, please.
Good morning to everyone. Am I audible?
Yes,
Am
sir,
I
you are
audible?
very much audible, sir. You are very much audible, sir.
So thank you very much. I am very glad to be part of this conference because during my early stage, I was very much interested. I have to take the career in the marine field, but somehow all we know that when chances are more, and that too when you get a government job, so everything is secondary, becomes secondary. So after around 25 years or so, I am again with the subject. So thank you very much for the organizers for inviting me for this wonderful conference. See, recently I was part of a team which was set by the ministry, a ministerial task force for promoting Industry 4.0 among MSME sectors. So I had an opportunity to study a lot of things about the Industry 4.0. Particularly this maritime was missing. Maritime, we don't do much work, the MSME sector, except no few service industries. So it's a good opportunity for me to learn. So I have gone through the prospectus. It has been well organized, covering almost all the aspects of the technologies. So I will not go into details of the technology, but I can confidently say that the topic given for this conference, disruptive technologies in maritime, is very apt. It's definitely going to have a lot of disruptions, lot of disturbance in the manufacturing sector, in the operation sector, in the service sector, and maybe more to the education sector, even the competency assessment field. It's going to have a lot of disturbance. So entire things to maybe in a course of time we have to relook and redo everything. Maybe the educations, the curriculum, and then training, maybe the assessment, competency assessment done by MOT. So everywhere we are going to have a lot of disturbance because of the disruptive technologies. So this is going to be a smart technology. See, for a manufacturing, it's going to be a smart manufacturing, operations, smart operations. So, and service, smart service. So everywhere it's going to be smart, and accordingly, more technologies like artificial intelligence and robotics and Internet of Things, big data analytics. So all these combinations of technologies, latest technologies, going to play a big role and bringing the changes in the maritime, and it's going to definitely have a big disturbance in the present way of working and present life of the marine people. So definitely this conference going to be very useful to rethink our future and realign our working style, realign our life in the maritime. So it is a very hot topic and the need of the hour. I really appreciate the organizers and also thank for the opportunities. I take this opportunity to wish the conference all the success. All the success. It's going to be a very useful and successful one, because I gone through the entire the brochures, and there are the experts from outside, and who are well versed with the technologies going to be part of the conference and share their knowledge. And definitely these participants will have a good takeaway from this, and it's going to be useful. And on our part, MSME ministry, and whatever the support that you need from our side, we are with you, and I assure you all the supports and guidance from our side and all the times. So I wish once again all the best for the participants and the organizers. Thank you very much. Thank
Thank
you.
you, sir. Thank you, sir. Thank you for your welcoming, speech, sir.
Thank you, sir. That was indeed a very motivational and energetic inaugural address, which gives us a lot of inspiration and hope that this conference will be a wonderful success. Thank you, sir.
Thank you, sir.
Reading maketh a full man, conference a ready man, and writing an exact man, says a proverb. True to this statement, the scientific contribution from a vast number of faculty members, research scholars, students from various educational institutions, researchers have been compiled. This conference focuses on the thrust areas such as integrated logistics materials and production, meteorology and weather forecasting, smart technology, renewable energy system in onboard ship, industry automation, marine pollution. We have received around 186 papers. The scrutiny committee have shortlisted about 103 papers. So the team feels extremely proud to release the conference proceeding of the International Conference on Disruptive Technologies in Maritime Sector Industry 4.0.
I am deeply honored in introducing the chief guest of the day, Dr. Sanjay Bhavnani, Director and Chief Operating Officer, MMS Maritime India Private Limited, and Chairperson, FOSMA Mumbai, India. He is a senior and a strategic leader with rich hands-on experience within the marine industry for over 3 decades. He has been involved in heading one group company for several years and closely involved in expanding its operations steadily over the years. The company is closely involved in the operation of a tanker fleet comprising of oil, chemical, and gas tankers chartered to oil majors and maintained to best industry standards. May I now request sir to deliver his chief guest address.
Welcome, sir.
Yes, good morning. Can you hear
Good
me?
morning.
Thank you. Thank you very much. I think it is indeed a matter of honor and pleasure for me to be here today. And I would like to thank Amit for extending this warm invitation to me. Let me start off. I would like to convey my thanks to the management of Amit, to the Vice Chancellor, Colonel Dr. G. Piruvasagam, also to the other dignitaries of Amit, Mr. Bhupati Bhaskaran, Dr. Sasilata, Mr. Anand Tripathi, and all other dignitaries at Amit who have been involved in the organizing and conduct of this conference. It's indeed a pleasure to meet all the other dignitaries also here as well, especially Dr. Paneer Selvam. It was a very motivating talk from him, and I think it's going to resonate with all of us for a very, very long time. I feel honored and privileged to have been asked to deliver the chief guest address at the occasion of the international conference based on the theme Disruptive Technologies in the Maritime Sector, organized by the Department of Marine Engineering of this excellent institution. I have great admiration for the emphasis the Institute places on maritime academy or maritime education, emphasizing on lifelong learning and development, on positive engagement with the community, developing leadership skills, and these are the qualities which will positively impact the students while they are going to engage with the communities, with their country, and with the world at large. It is customary on occasions such as this for speakers to say that they are honored to have been invited. In my case, it is no mere platitude. So when I say it's an honor to be here, I really mean it. AMET is one of the most established institutes within the country, with a host of achievements, and not surprisingly, very well recognized and acclaimed within the maritime industry. Some of the adjectives which I've heard about it are as follows: awesome, great team that made things happen, fun-loving, overachievers, motivators, different from diverse backgrounds but gelled brilliantly as a team, and of course, to top it all, innovators. This conference being held virtually is just another step in this direction. This is an opportunity to apply. Of course, this is now a talk which goes to the students and to the other, to the junior members of a community. And I want to take this opportunity to address them, to share with them some of the experiences which I've had in my life, with the hope that it will be of some use and benefit to them for the future. It's an opportunity to apply what you have learned, to demonstrate it, and to learn from each others who are present here. It's an opportunity for you to build on these strengths which you are being given at this institute. I'm confident that your future in the real world is really secure. Many business leaders strive to build such qualities with mixed success. I really hope that in the future I can claim to have been the chief guest at an event where there were future leaders of the maritime industry today. I have absolutely no doubt that all the students here present will positively impact thousands of lives over the course of their careers. I have full confidence in their talent, their determination, and the quality of the education that they are receiving and will continue to receive. Nevertheless, I cannot resist the temptation to offer the students and cadets a few snippets of wisdom. These are the qualities which they can possibly demonstrate, the actions which they can take, and the attitudes which they can adopt that I strongly believe will maximize their success as leaders in the years to come. So please indulge me as I share a few recommendations born out of my own learning. It's not enough to simply try and get by in life. That does not move the world forward. You must strive to excel in everything you do. Excellence in every task, howsoever large or howsoever small it may be. The decisions which you make today, starting, will determine what you become today. Your academic journey, while being the first step, will lead you to a journey of lifelong learning, and you must be very clear on the end result and how you wish to get there. Needless to say, you will face many challenges, but that's what the real world is all about. And the next phase in your life is going to be a ground where you can apply all the knowledge and the education which you are going to receive here. I remember reading a recent article on education that highlighted three essential interrelated elements to intrinsic motivation: play, passion, and purpose. Whether and to what extent parents, teachers, and employers encourage these qualities make an enormous difference in the lives of young innovators. You must think big, dream, and based on not what it is, but on what might be. You will have amazing network opportunities in your next phase. You will meet new people with different cultures, values, attitudes, and knowledge, and take full use of that opportunity. It is easy to remain in the comfort zone in terms of your friend circle, but the best lessons in life are learned through reaching out. Play your part in sports, cultural, or other activities such as this conference that enables you to expand your network as well as approach and perspective towards the industry. We witness a number of cases where it is easy for university students to give a lesser amount of priority to health and well-being issues. However, it is very important to be able to prioritize that as well, and at the same time to have fun, and important that whatever you do, look after yourself mentally, physically, emotionally, and of course, professionally. And please remember, balance is the key to future success. You must not allow your conviction to become stubbornness. The world is constantly changing, and when the facts change, we must reconsider our views. Hence, we must, as they say, we must change ourselves or we will be changed. We will be swept along as if by waves. As resolute as one can be, please remain ready to continue to learn, unlearn, and relearn for the rest of your life. And this conference would indeed be a very big and a very appropriate opportunity to be able to apply this. As the title of this conference and the theme of this conference suggests, disruptive technologies. So we are going to unlearn a lot of things which we have already learned so far. Do not be afraid to be fearless. We all must have goals and we will all have fears of achieving them. But it is how we handle those fears that determine whether or not how quickly we get there. Of course, not every project or task which we'll undertake is going to be successful. When it is not, learn from the mistakes made and take the necessary remedial measures on to the next project. Well, students and cadets, you are the future of our industry and of our country. What you learn from here is what you will carry with you as you step out of this institute. You must always remember that you will be representing your country, hence India will be judged by your actions. Hence, you must learn to always ensure that the Indian flag continues to fly very, very high at all times. Finally, may I thank Amit for the invitation. It has continued to be a leader within the arena of marine education, both nationally as well as internationally, with all streams and closely aligned with the requirements of the industry. To all the staff at Amit, as well as the teaching staff, keep up your excellent work in helping shape future leaders, and may God bless you all. May this institution grow from strength to strength and let the nation benefit from the commitment and skills of the students that pass out of this institution. So to end this, I will say to the students, realize your potential, realize the potential of what you can do in life, because what you can do in life is limited by only what you would want to. To both the students as well as the institute, continue to make this country proud, make yourself proud. So with that, best of luck with whatever you want to do in life. But as I said, please go ahead and do what you love. Do it with a crazy amount of passion and make India proud. Once again, I would like to thank you very much for giving me a chance to speak here and your patience in listening to me. So thank you very much, and I wish you all the very best for this conference. Thank you very much.
Sir. Thank you, sir. Your speech has been very motivating and to the cadets and to all of us, and we definitely follow the wordings what you have put up, sir. Thank you, sir.
Thank you very much.
Thank you, sir. It's my privilege to announce the guest of honor, Dr. Eric Zarnowski, professor at Gdynia Maritime University, Poland. He works in the Department of Information Systems at the Faculty of Entrepreneurship and Quality Science. His areas of interest are widespread. Mention a few areas are artificial intelligence, collective intelligence, machine learning, neural networks, evolutionary algorithms, data science, knowledge discovery in databases, KDD, distributed knowledge discovery in databases, DKDD. The selected publications are available from DPLB's bibliography server, Google Scholar, the collection of computer science bibliographies, and Springer list of publications. I request Dr. Eric Zarnowski to enlighten the gathering.
We welcome you, sir.
Thank you and good morning. And thank you for the very long introduction, my person. Yes, exactly. I am interested in artificial intelligence and application of artificial intelligence and in general in data mining, but of course I look for an implementation of this algorithm and this method in industry and also in marine area. Thank you for invitation my person to this conference. It is my pleasure to be here now and give the short address. I think that the conference is a very good because it is the time when we must discuss about milestones of this area. And when we very often discuss about the Industry 4.0, and it is the technology where we need the artificial intelligence. I work with the artificial intelligence more than 20 years, but this time was a general very ambition. Now we are in the time when we want and need implement this new technology. Of course, we can find a different area, but one important area is the marine area. Yes, and when we can increase the possibilities of different equipments, when we can run autonomous ships, when we can run a new methodology and new management, etc. So it is the definitely milestones when we run and implement a new ideas and new algorithm. This algorithm create a more autonomous systems when the person and the people only can maybe observe what to do, or maybe only can manage the system and look and on the safety, on the rescue, and etc. So I think that it is the very important time to new direction in a different area, and as I mentioned, especially also in marine area. When we discuss about the Industry 4.0, and when we discuss a new technology, when we discuss about the artificial intelligence implementation in this area, when we discuss about cyber physical systems, which are a compact system when we have the artificial intelligence, we must have also the reflection about the skills, new skills for people, for officers, for mariners, because without such meaning and such discussion, we cannot create a new skills and new possibilities to work with such systems. So I think that the conference is ideal meeting, yes, to discuss about this new direction, this new milestones. In my university, we also very often discuss about this a new direction, about the Industry 4.0, or what we can do, yes, in which kind of project we can go. And of course, we discuss about these new skills, because when we thinking about the university, we not only must think about the research, but also about the education, how the new skills should go to the mariners, to officers, to people which will be very close to the new technology. Of course, the new technology create a very huge different area of the implementation, from ship to onboard equipment, land equipment, and sky equipments to the communication. So thank you for the conference. The conference can have a very important impact for, I think, also for me, but all participants. And I wish all through its presentation and discussions. And I think that the conference is now a success, now a success. So thank you very much. And once again, thank you for my invitation to this conference. Thank you very much.
Thank you, sir.
Before we start the technical session, we would like to thank our guest, Dr. Panneerselvam Ramaswamy, Principal Director, MSME Technology Agra, Dr. Sanjay Bhavnani, Director and Chief Operating Officer, MMS Maritime India Private Limited, Mumbai, Dr. Ired Zawnowski, Professor, Department of Information Systems, Jitnia Maritime University, Poland, Chief Engineer Sivaram Narayanaswamy, General Manager, Cochin Shipyard, Chief Engineer Indranath Bose, Advisor, the Great Eastern Shipping Corporation Limited, Mumbai, Dr. Mohammed Awai, Senior Lecturer, Department of Computer Science, HGL University, UK, Dr. Dinesh Babu, Director, KUM India Private Limited, Chennai, Dr. Mohsin Raza, Senior Lecturer, Department of Computer Science, HGL University, UK, Dr. Vijay Kumar Banga, Principal, Amritsar College of Engineering and Technology, Amritsar. I thank the honorable members of the management, Vice Chancellor, Pro-Vice Chancellor, Registrar, Principal, Vice Principal, Dean, heads of various departments, faculty members, participants from industries and other organizations, and students cadre for gracing the occasion. Thank you all.
Thank you, sir.
Thank you, sir. Thank you, madam. Thank you, one and all.
Thank you, sir.
The technical sessions will be devised shortly. I request the participants to join their respective tracks. Track 1, Integrated Logistic Materials and Production. Track 2, Meteorology and Weather Forecasting. Track 3, Smart Technology. Thank you all.
Track 1. Good morning to all. I am A.S. Oma Mukta from first year Department of Marine Engineering. Feel extremely glad and overwhelmed to introduce Chief Engineer Mr. Sivaram Narayanaswamy, who is an keynote speaker of Track 1, Integrated Logistics, Materials and Productions. Sir, we welcome you to this session. He graduated from Government Engineering College, Thrissur in 1989. He experienced in maritime industry span of about 3 decades. His tenure has been very versatile and he has contributed to various divisions of the marine sector. Currently, he is working as a General Manager in Business Development Division, Cochin Shipyard, Cochin. Cochin Shipyard is known for manufacture of bulkers, tankers, tugs, floating platforms, platform supply vessels, anchor handling tugs, and passenger vessels. He is also an expert committee member in Maritime Indian Vision for 2030, initiated by Ministry of Port Shipping and Waterways. May I now request our keynote speaker to address the gathering. Sir, please.
Yeah. Good morning to one and all. Am I audible?
Good morning, sir. Audible.
Good morning, sir.
Yeah. So,
Good morning, sir.
Well,
Audible, sir.
Okay. First of all, thank you, Ahmed, for giving me an opportunity to share my thoughts with the young future right engineers who are going to be part of this industry. I'm very proud to be a fraternity of this industry, and I am very, very optimistic that this industry can go a long way. And India, with such a rich human resource, that to young technical professional people around, we can really put a real, we have already done quite a good work in our operations and other technical matters. We also can advance further in innovative and future developments of this industry. So I will just, this topic of integrated logistic materials and production is something which is, I will be specifying more to do with how this is impacting the industry in general with respect to my industry, which I am presently working. It's basically the shipbuilding industry. And it is one of the complex industry when we talk about EPC type of work, that is engineering, procurement and commissioning type of work, where we need to integrate maybe 50,000 plus different parts into a mobile platform and make it function as a single unit. So it needs all divergent requirement from with the respect to the skill sets. It is not about a structural engineer. It is not about a welding engineer. It is not about a naval architect. It is not about electrical engineers. It is not about mechanical engineers. It is not about industrial combustion IC engine experts. It's a mix of all trades which join together, and that product is made. So we have got main propulsion plant. We have got other power generating units. We have got accommodation systems where hotel loads. So it's a floating hotel by itself. If you are talking about a big passenger vessel, so it is highly complex and it got its own unique requirements. So each project is different. Each project needs different requirements, and hence the project becomes very complex. So many times when we talk about the efficiencies, especially in an industry like shipbuilding, we find it extremely difficult to understand why many of the shipyards sometimes could not perform, who are very good in one aspects, but they fail in another aspects. When I talk about this, I can cite an example of a huge shipbuilding company like Mitsubishi in Japan. They were very good in various types of ships, and they have got more than 50 years of experience, and they are one of the leaders in shipbuilding. Yet they took a project for a huge passenger vessel, and they miserably failed. A Japanese shipyard like Mitsubishi could not complete a project, and that project has to be abandoned, and finally it was rescued by involving various other experts. So why it is happening? What's the reason for this? That shows the complexities of this industry. So in order to overcome this, what is the method? What is the way forward? How we can overcome these complexities? Why it is so complex is something which we are finding it with our new technologies. So when we talk about even Japanese industry, where the planning is so good and they are very meticulous in their executions, they themselves are at times, are unable to handle this complex part. So this can be achieved through new trends, mega trends, what we can call in the shipbuilding, as well as in the industry at large, which is happening, which is basically we all know it's in digital. We cannot imagine that about 3 years back that we can travel without a purse. Now we don't need a purse. We need on a mobile phone to do all our transactions. That's how the world has changed. So this digital platform and the integrated systems and the digital data mining, that is the thing which is helping all the industries, and there is no difference with respect to shipbuilding also. So when we talk about this industry now, when we are going, what are the new things? What are the emerging trends in the shipbuilding which is impacting at large? And then I will come to how it is impacting the logistics and the production. So we are talking about something called as Shipyard 4.0. What is Shipyard 4.0? Why, how it is impacting? We can see it is. We understand that about 20 million years ago, the first mankind has happened, and there was Stone Age, Old Age. Then we, in the year 1970s, late 70s, this mechanical machine were all made, and Industry 1 was evolved. Then further we progressed, and 1870s we invented the electricity. Then the Industry 2 started, that really propelled to great extent about the automation and improving the manufacturing procedures and integration of the materials. Then Industry 3 happened after the Second World War, and we further managed to improve our technology for better efficiencies and making complex systems. Then now we are talking about Industry 4.0. In Industry 4.0, what we are seeing is that it is totally getting into the digital, and there are a lot of things which we are trying to integrate in this single platform. What is Industry 4.0 trying to achieve? Industry 4.3 is trying to achieve a seamless integration of the entire procedures, entire processes, without any human intervention, by analyzing the data and giving right input to the respective people. So when we talk about a ship which is going to be built, what we start is from the concept design to the basic design to a detail engineering to material takeoff list from the engineering list, then from the material takeoff list to procure the right type of material which is required for each and every component, and from that specification matching against the material which is being supplied, then segregating the materials with respect to the requirement from each department and putting it into the production through the planning, and making the material available at the right place with the right team, with the right information, and then executing the work and integrating all the systems, then doing the commissioning and finally trials and verifying the equipments. So when we talk about this in a 2 minutes time, we can talk what is the procedures, but what all things are involved in this is something which is of great difficulty. So I don't know whether I can share a screen. I wish I can. Then I will just show you one.
So you can share a screen.
Is it visible?
Yes, sir. Yes, sir. It's visible.
Yeah. So this is the single page representation of what Shipyard 4.0 we are all talking about. So when we talk about this, there is a total virtual integrated network which is available across all the systems and processes involved in a shipbuilding arena. So we have got a strong virtual model which is available, which is integrated with a cyber security system. So that platform is well taken care. Then we are talking about a big data and analytics. So entire information with respect to all the process procedures and the requirement for making any product is available in this. And this big data analytics is the one which is giving the right information to the right people through the right media. So when we are talking about a design engineering, there are different design engineering methodologies which are available. And we are now talking about no vessel is made without any model nowadays. So there are 3D models and 3D digital twins are available, which can be shared with anybody in the world who can also run through the model with the same people who are working in the design, and whatever requirement needs to be changed for the client expectations or for a OEM who has to integrate something to the vessel, everything can be done with a digital twin. So this digital twin is available. So a virtual model is made even before the vessel is built. So that's how the system is developed nowadays, which makes it more accurate and more predictive. With this aspect, the entire network of the things, information from the design engineering is passed on to all the systems. That includes the material management system, include the production floor management system. It includes the production planning team. It is fully available to the project managers who are handling the project. And also it is entered into a enterprise resource platform whereby the financial aspects along with this engineering aspects are captured, whereby the time and cost also can be evaluated with a single platform. So this level of upgradation is happening all around the world, and it is no Cochin Shipyard is also no exception. So we have formed a separate cell which is working on this, and we have just inching towards Shipyard 4.0, and another 2 years time we wanted to be in a platform which is compatible to a modern shipyards 4.0. So by this integrated solutions on all the aspects with respect to shipbuilding. So I'm not just talking about the logistics of the material alone. I'm talking about the information which is integrated, where the material also becomes a part. And that's how nowadays the systems are moving, and that's how the things are collaborated and integrated. So when we talk about so I just wanted to share two slides further to what in Cochin specifically we are doing on the futuristic vessels, where we are working a lot with various collaborators across the world without meeting each other. In fact, I wish to inform you that we have contracted one vessel in last July. Last July, it was under lockdown. There was no travel possible, and we contracted with a Norwegian company for building a fully autonomous vessel. So, and the company is entering into the ship owning for the first time, and we have not dealt with them earlier. So we don't have any prior relationship. In such a situation, a Norwegian company, it's a large company, listed company with 8 billion turnover, placed a fully autonomous pure electric vessel to Cochin Shipyard in India, in a remote place. This was possible only because of the digital platform and the strength of communication we can do with the virtual media. So entire audit of the shipyard, entire evaluation of the shipyard, entire processes of the shipyard, everything was evaluated over the internet and with sharing the information through the digital way. So this vessel is now under construction. By January, early this next year, we will be delivering this. These are zero emission, green, autonomous, pure electric vessels. So here we are collaborating with various technology partners. The autonomous systems are provided by the leaders in the world called Kongsberg Maritime, another Norwegian company. So they are also unable to come here and sit with our engineers and interact. Everything is done in a digital platform. So this integration of the system is entirely happening in the digital platform. And this is the way how the world is moving. So the world is becoming so close with the availability of technology, what we are seeing. So, and this is a very classic example, and which also will be an eye-opener for many of us, that how the commerce is going to work in the future when we are talking about integrating various systems. So this is a very proud moment, not only for Cochin Shipyard, it's a proud moment for India as well as for the world. When we put this vessel into use in Norway, these are all basically 16 European truck containers can be loaded in this vessel, and it can ply between two port locations in the ports of Oslo, and it will be fully automated. This autonomous part, autonomy is will be tested in Norwegian waters for almost 2 years. Then they will be given the full autonomy, where nobody will be on board the ship, and it will be controlled from a third control station somewhere outside. So this is how the world is going to move. So with this good example, I thought I will short my lecture here, and I will give more time for the people who are going to present it. And what I wish to tell is that this world is becoming highly dynamic. The only way to survive is to be agile. So agility happens only by updating our knowledge, and knowledge is available for us through various means. It is not that physically we have to be present in some location to upgrade our knowledge. So with this, so it's a huge opportunity for the youngsters to adapt themselves and also make them relevant for the future industry. And one more thing, which always comes to the people's mind when we are talking about this autonomy and autonomous vessel, is how the future students are going to be employed and what is going to be their role. I feel their role is going to be even more important. Only the skills needs to be sharpened little differently. So I am very sure that AMET also will take note of this. And definitely you will also include more relevant subjects such as autonomy and other aspects which are going to drive the future industry, so that the students are well skilled, as well as they can perform better, and they will be in great demand. And generally the Indians got very good analytical skills, and they're very good in mathematics and communication. And I am very sure that with AMET's professional imparting the training, you can create great minds which can be of great resource to the future industry. Thank you. I wish good luck to this entire seminar, and I also congratulate AMET for taking this initiative in bringing the industry and motivating the students. Thank you. Jai Hind.
Thank you, sir. let us start the technical paper session.
Dr. Edison?
Madam, the technical session 2, keynote speaker is also available.
Yes, sir. Yes, ma'am.
So the present papers from technical session 1 will be presented right now. Am I correct?
Yes, sir.
The afternoon session, session 2. As well as,
Correct, ma'am.
please proceed. Yes.
Dr. Edison? Ashok, sir?
Yeah, he's muted. He's muted.
Good morning to all. We will start the track 1 presentation. Umar?
Yes, sir. Yes, sir. Sir, am I audible? Yeah, no? Okay. Track first paper will be done by ICD TMSO 201, paper ID. Title of the paper, A Review of Additive Manufacturing Process. Name of the author, K. Hemaprasad, HOD, Mechanical. Dr. V. Sendil Kumar, Principal. So please carry on.
Screen is visible, sir. Is there, sir? Umar?
No, sir. Sorry, your screen is not visible, sir. Sorry, sir.
Not my screen. It's presenter screen.
Yeah,
Umar,
sir, it is
Umar,
not
could you
visible.
just tell the participant's name?
Yeah, sir. The name of the participants are K. Hemaprasad, HOD, Mechanical. Dr. V. Sendil Kumar, Principal.
I request the system manager to add them as panelists. Otherwise, they cannot present their papers.
Ma'am, added, ma'am.
You can ask a star.
Cadet Omar? Cadet Omar, can you just call upon once again? Because, maybe
Yeah, sure,
he's
sir.
added
Sure,
just
sir.
now.
I will come again. Paper ID ICDTMSO 201. Title of the paper, A Review of Additive Manufacturing Process. Name of the authors, K. Hemaprasad, HOD, Mechanical. Next, Dr. V. Sendil Kumar, Principal. Sir, please carry on with your presentation, sir.
So he's not there. Umar, please call.
Sorry, the first presenter is not available.
Please call the second presenter. Stalin is also not there.
Ma'am, sorry to disturb you, ma'am. Ma'am, can you able to hear me?
Yes, Mr. Prabhakaran.
Ma'am, first presenter, can I know who is the name, ma'am? Just now, ma'am, system is connected.
Excuse
me. Yes, sir. Sure. I will read the name of the authors once again. The name of the first presentation authors are K. Hemaprasad, HOD, Mechanical. Next, Dr. V. Sendil Kumar, Principal. Sir,
Okay,
if
sir.
you
Thank you. Thank you.
carry on. Okay, I will go to the second paper with ma'am's permission. Ma'am, shall I move on to second paper?
Yes.
Okay. Paper ID ICDTMSO 202.
Hello?
Title of the paper. I think so. Hema Prasad sir is here. Sir, yes, sir. You're audible.
Yes, sir. Due to some network issues. Sir,
it's okay, sir.
Sir, please share your screen, sir. Please
Already
share your screen.
Because already I share the info that my PPT to the office. So because give us a option for sharing option.
So you are provided with the sharing option, so you can go ahead.
Yes.
Sir, Hema Prasad, sir, you have the option of sharing, sir. If you are not able to share, can you please inform us, sir?
Umar, what about
Sir, can you come again, sir? It was not audible.
Yes, what is your paper name,
yeah,
pa?
it
File
is
name?
visible. Okay.
Sir, that is the file, sir. You are right. A review of additive manufacturing process.
It's now it's clear, sir.
Yes, sir. Can you please zoom it in, sir?
Yes, sir. Yes, sir. So myself, Hema Prasad, from TS Srinivasan Center for Polytechnic and Advanced Training. So today I will present my paper on review of an additive manufacturing processes. So my content, the introduction of the additive manufacturing process and what are the different additive manufacturing processes are there and what is the present conditions. So normally manufacturing is nothing but it is the process to convert the raw material into a finished product. In that nowadays many industries are using the conventional machines as well as CNC machines. In conventional machines it's very difficult to maintain the quality as well as the dimensions. So we move on to the next level, that is in a CNC. In CNC is maximum we are maintaining the quality as well as the dimensions. Now the next process is in additive manufacturing. It overcomes what are the problems in conventional machining as well as in CNC machining. So additive manufacturing is a process of joining the materials to make up objects from CAD model. So usually it was done by layer, as the opposite of this additive manufacturing, that is a subtractive manufacturing. Normally in manufacturing in CNC or conventional machining, the material will be removing. But in additive manufacturing, it is just opposite, that it is by adding the material by adding in layer by layer. So it is also known as a 3D printing or additive fabrication or freedom of fabrications. The functional principle is we have to make a model in a CAD, then export it into a stereolithographic file format that should be a read by the additive manufacturing equipment. So normally in techniques we are using that we are done by the create by layer. Then the speed is very important. If the speed is not in good condition, then we are not getting the good quality of product. That also the layer. Then the range of material will vary from product to product. Then accuracy as a cost. So these are all the different additive manufacturing processes are used: VAT photopolymerization, powder-based, and binder material jetting, sheet lamination, and material extrusion. So in VAT polymerization, in that it uses a vat of liquid polymer resin, out of which the model is constructed by layer. In that we are using ultraviolet light is used to cure or harden the resin where required, while the platform moves the object being made downward after each new layer is cured. It's nothing but layer by layer. So in this process, the use of the liquid to form an object. There is no structural support from the material during the build process, unlike the powder-based methods. The support is given by unbounded materials. In this case, the support structure will often need to be added. That is, the resins are cured using the process of photopolymerization or ultraviolet rays, which the light is directed across the surface of the resin with the use of motor-controlled mirrors. Where the resins comes in a contact with the light, it causes a harden the materials. The main process of this web polymerization, the build to platform the lowered from top of the resin, then downward by the layer thickness. The ultraviolet layer cures the resin layer by layer. The platform continues to move downward and additional layers are built on top of the previous. In some machines, uses a blade which moves between the layers in order to provide a smooth resin surface to build the next layer on. So after completing the first 3 steps, the vat is drained and the resin and the object will be removed. This is the principle of vat photopolymerization. The next one is a powder-based fusion. In this, it includes the commonly used printing techniques like DMLS, that is a direct metal laser sintering, or EBM, electron beam melting, or SSS, selective heat sintering, or SLM, selective laser melting, and selective lasers in SLS method. In powder fusion method, use either the electron laser or electron beam to melt and fuse material powder together. In electron beam melting methods, acquire a vacuum but can be used with metals and alloys in the creation of functional parts. All the powder bed fusion method process involves the spreading of the powder material over previous layers. These different mechanisms enable is including the roller or a blade. It's our wish to stick. A hopper or reservoir direct material laser sintering process is the same as SLS method, but only difference is use of metals and not plastics. That is a major difference. The process sinters the powder layer by layer. The selective heat rinsing differs from other processes by the way of using heat and thermal print. The main step-by-step process will be the layer that is typically majorly 0.1 mm thick of material spreading over the build platform. The laser fuses the first layer or first cross-section of the model. A new layer of powder is spread across the previous layer using a roller. The process repeats until the entire model is to be created. Then unfused the powder is remain in position, but the removing during the post-processing step. The next one is the binder jetting or a 3D printing. In this, the binder jetting process has two materials, a powder-based material, and the next one is the binder. In this, the binder acts as additive between the powder layers. The binder is usually in liquid form and the building material in a powder form. The printhead moves horizontally along the X and Y axis of the machine and deposits alternating layer of the build material and the binding material. After each layer, the object being printed in lowered on in the build platform. Due to this, the material character due to this, the material are not always suitable with the structural parts. In binding material process, the powder material is spread over the first part over the build platform using a roller. The printer head deposits the binder adhesive on top of the powder where required. The build platform is lowered by the model's layer thickness. In this, another layer of powder is spread over the previous layer. The object is formed where the powder is bound onto the liquid. Unbounded powder material remains in position surrounding the objects. The project is repeated until the entire object has been made. The next in this, then the material jetting and the binder jetting is more or less the same. Only difference will be the metal. In this metal joining, the coating blade represents a thin layer over the build platform. Then that's the nozzle, that is a 2D. The inkjet nozzle is like a printer nozzle, which it passes over the bed and selectively depositing the materials over the layer. So it will create a bonding between the liquid resin as well as the powder materials. In that, the ultraviolet rays will also cure the difference, that is curing the metal with the powder. That is a major thing. Here, the main important point will be the nozzle size. If you are select the correct nozzle size, it will give the good quality of materials. Next one is called the sheet lamination. In this, the sheet will be moved along the cross section. Here we are using the ultrasonic rays. This ultrasonic rays will be moving in both the process. It's like a printing. It's normally in printing, the paper is moving in a roller side. Both whatever the material, whatever the objects printing in the same way. In this sheet lamination, the process also is moving. Here, main process ultrasonic additive manufacturing and the laminar object manufacturing. The ultrasonic additive manufacturing process use sheets or ribbon of materials which are bound together using ultrasonic welding. Also, it's like the process that requires additional CNC machining and removal of unbound materials. Here, after finishing this, we can use this material also. We using the CNC machines. Here the main process will be the material is positioned on place on the cutting bed. The material is bonded in place over the previous layers using the additive materials. Here the required shape is then cut by layer by layer. Then the next layer will be added. The first 3 steps will be continuously done. Then the material being the post after that material will be post processing. So in the presentation, the main data, converting the data, design data on machining process, it was somewhat difficult to reduce the manufacturing and the product cost. Sorry.
Hello. Sir, please proceed.
Sir, yes, sir.
Hello, sorry. So in this present, the main problem will be the converting the design data to the machining process is somewhat difficult now. So apart from this, we have a different process are there. In that there is some main problem is reduced.
Sir, track and charges.
Ma'am, yes. Next person, afternoon, one person having an exam, ma'am. So that person is interested to present now, ma'am. Shall you allow?
Permit பண்ணுங்க.
Yes. ICDT MS 20106.
Yes, good morning. Am I audible?
Yes, sir.
Good morning, everyone. Thanks for considering us. So I'll be sharing our screen regarding our paper. Is it visible?
Yes, sir, your screen is visible.
Visible, madam.
Thank you. Thanks a lot. So we are BTech undergraduate students from Asansol Engineering College.
Hello.
We belong to the first year. Thanks for including us in this and selecting our paper.
Okay.
So we'll be moving on to our project, which is glasses program to sense drowsiness while driving an associated alert system. We all know that driving can cause accidents when it's in a process. When the driver is in a process of when driver is not concentrating on the road or he is facing a problem. There are several cases of drunk driving or drowsiness driving which leads to accidents. So we plan to remedy. We plan to remedy for that. We plan to give a solution to that problem. So we introduced a project. But first of all, before understanding what a project is, we need to know why do we need this project. So according to NSF, half of adult drivers admit to consistently getting drowsy, while 20% admit falling asleep, and 40% admit their life risk. In India, 7,000 people died in 2015 in crashes involving drowsy driving. These are the statistics that take us to believe that how important it is to inculcate or to enforce something which would aid people to promote self-driving or to promote safe driving. An estimated 1 in 25 adults drivers aged 18 years or older report having fallen asleep while driving in the previous 30 days. The National Highway Traffic Safety Administration estimates that drowsy driving was responsible for 72,000 crashes and 44,000 injuries and 800 deaths in 2013. However, these numbers might vary and these numbers might be more or be less. But it is estimated that 6,000 fatal crashes occur each year. So it's a major problem that we need to solve. Now, moving on to the next slide. What are the built-in systems from which we have taken inspirations from? There are several built-in systems like electronic stability control, in which the driver, if is going off-road or the driver is going on a road which is not properly smooth or properly concreted, the vehicle using gyroscopic technology balances itself. It balances itself and it ensures the safety of the driver. Warning and emergency braking systems. There are several braking systems. Even if the brakes fail, apparently there are several internal braking circuits which could stop the driver from crashing. There are blind spot monitoring systems which help the driver in parking properly. There are speed alert systems which alert the driver when he is going beyond a certain speed limit. There are driver drowsiness detection, which is the main inspiration for our project. There is steering wheel pattern monitoring. There are vehicle position and line monitoring, which includes video, laser, infrared sensor. What it does is that when you're parking a car among a lot of other cars, you need to be very cautious. You need to be cautious when you're parking among a lot of other vehicles. So for doing that, you need to be having a proper idea of how much you're far away from each vehicle. These sensors helps in that. So there are a lot of already existing technologies from which we have developed or which we have drawn inspiration from. Now, moving on to the next slide, this is our solution. What does this eyeglass or what does this our project comprise of? It's a very, very simple project. Anyone can, anyone with the proper materials and proper understanding can apply and implement this. The eyeglass is equipped with IR sensor, which is an infrared sensor, a 9-volt lithium-ion battery, which is to power itself, a microcontroller, in our case an Arduino Nano, which is the most compact and smallest microcontroller available in the market, a buzzer module to alert the user, which alerts the user if he is drowsy driving or not, or if a problem occurs while he is driving or not, and a few pairs of jumper wires. The few pairs of jumper wires are generally used for the connection purposes. The main working principle of the system is to detect the difference in reflectivity of light as sensed by the IR sensor and alert the user accordingly. I'll be explaining this a lot more detail in the next few slides, but the main purpose or the main principle of working is the working of the IR sensor. The IR sensors working helps the user or the microcontroller in this case to understand the problem in the scenario. Now moving on, these are the materials we needed: an Arduino Nano, a spectacle frame, infrared sensor, jumper wires, 9-volt battery, and a very minimal double-sided tape. You see, this is a simple setup which will help us to implement this complex project, although it has very simple beginnings. Now moving on to the next slide, this is the circuit diagram. And you can see there's a buzzer module and there's an IR sensor attached to it. The buzzer module is attached to a 5-volt pin, which supplies the buzzer module with the required voltage for it to beep. It also is connected to the D2 pin of the Arduino Nano, which helps the microcontroller to know when and how to alert the driver using the buzzer. And there's also a ground wire connected just for the circuit purposes. Now, the IR sensor is connected to both the buzzer and the 5-volt pin for, of course, supply purposes, and it's also connected to the A0 pin from which we are reading the input. We are reading the input whether the user is asleep or not. So the IR sensor is connected to the A0 pin for this purpose, and there is a simple switch and battery for further processes, for further control or automation, if you ask me. This is the Arduino Nano we have used. It's the exact model of the microcontroller we have used. It's readily available in the market, and it's one of the cheapest one out there and the most compact one which we have used. So it's one of the best ones available for this project because we need to minimize the area occupied. You cannot wear a spectacle frame, or you cannot wear something on your eye which is bulky and heavy. It won't help you under. So this is the one we have used. Now let me explain the working properly. When the eyelids are open, the corneal pupil absorb most of the light emitted by the LED. Being a shiny surface, our cornea being a shiny surface, it absorbs most of the light and reflects in a regular pattern. Since we all know that shiny surfaces reflect light in a regular pattern, so the fraction of reflected light detected by the receiver is far lesser than when the eyes close. The skin of our eyelids, being a rough surface, being a more rugged surface, causes diffuse reflection. It causes haphazard reflection. It causes less absorption and more reflection, which causes the receiver to sense more, which causes the receiver to detect more light. In this case, the amount of light detected by the receiver is greater. It is a difference that helps the microcontroller. It is this difference in the sense, it is this difference in the reflected light, or it is this differences in the reflected light received by the IR sensor's receiver. IR sensor has two parts, an LED and a receiver. The LED emits the light for deflecting purposes, and the receiver receives the reflected light. The difference in the amount of reflected light in both the scenarios helps the IR sensor and further the microcontroller, which is aided by the programming, to decide whether the user's eyelids are open or closed. If the user eyelids are open, it will not alert you because it knows that you are driving and you're concentrating. But when your eyelids are closed, it will alert you. But it won't alert you when you're blinking, because while you're blinking, your eyelids might get closed. But it won't alert you while you're blinking because we're included a delay time in the program, a delay instruction, which will further help it to understand how much time it should consider for one person when his eye is closed. Now moving on to this, since we are not in a physical environment right now due to the pandemic, this is a picture of our project which we have included. It looks a bit bulky and wired, but this is the most compact we can bring it to now. We have more future plans. This is the buzzer module and the IR sensor in the very proximity of the eye. This is the Arduino Nano module, which is the microcontroller we have used, and this is the 9-volt battery for powering purposes. Now moving on to the next slide. This is the program. This is the Arduino program which we have used to power it. It's a simple and very short program. It just in the void setup, we just initialize the pin configurations or the pin modes in which, for example, I have defined the sense variable at A0 from which I'm reading the input by the IR sensor. So I am taking that as an input mode, and pin 2, which is connected to the buzzer, I'm taking that as the output mode, because the buzzer needs to give the output as a sound alert system when we are facing a drowsiness case. So, and the pin mode LED built-in corresponds to the output. The LED built-in is an LED in the Arduino which alerts us that whether the Arduino is working properly or not. It's just for technical purposes. Now, we have included an if-else condition which consists of which monitors the difference in the reflected light, and continues to do that in a loop. And we have here, you can see properly that we have included a delay of 2000 microseconds. 2000 microseconds is 2 seconds. We have included a delay time. What it will do is that this is the most integral pivotal element of this programming, that it will do that whenever you close your eyes for 2 seconds. For example, you are driving and you fall asleep, your eyes are closed for 2 seconds. The buzzer module will alert you through that. The buzzer module will alert you through that, and it will move on to the next instruction, where it will, if it sees that your eyes is open, that is the amount of reflected light on if reflected light on the receiver end is lesser, it will again go back to its normal functioning mode without beeping the buzzer. But if it sees that you are continuously keeping your eye closed, it will, for more than a delay time of 2000 milliseconds or 2 seconds, it will let you know whether it will let you know or will alert you through the buzzer system. So you wake up and you realize that you had been sleeping and you go on driving. So it will again go in the normal mode. So this is the working. You can of course adjust the delay time in the programming. We will include something in which the user can easily change the delay time or easily change the time from 200 microseconds to a minute or so. Now, moving on to the next slide, we are proud to say that we have proposed our this project in the IICDC business proposal, and we have reached a quarterfinals round for that. And when we had proposed it through a design of the final product or a project layout in which actually what we plan to do or how the product would look if it was ever implemented. So this spectacle, I have a hand drawn it because it's a hand drawn illustration. Pardon if it's difficult to understand, but it has got lithium-ion batteries, a sound module which is much more compact, and a much more less shorter microcontroller, which will help us to make it less bulky. We might just include that mega chip instead of using the whole microcontroller periphery, but this is what will help us to include it to modify our product. We see that we plan to eliminate the IR sensor completely and install contact lenses which can observe or which can sense the change in your ciliary muscles. When you fall asleep, the ciliary muscles in your eye relax. They try to relax, and this difference can be measured by the polymer contact lens. So although this involves a very high module of technological advancement, but this can be done someday, yes. So this is the future. This is the future plan we are planning to incorporate if we ever get a chance. And this is the explanation of the IR sensor. Due to the rough surface, the receiver receives more reflected light. Since the IR sensor senses the difference in this, it alerts the user through a buzzer module. This is the main functioning or main principle. Now, moving on to the next slide, what are the technical aspects? How is this working technically? The glasses can sense the closure of the eyelids, and hence, if a person feels drowsy, it will wake him up by turning buzzer on sound module alert system on. Therefore, a lot of accidents can be prevented by avoiding instances of drowsy driving. The glasses can sense this closure of eyelids for more than a few seconds, decided by the detailed instruction in the program, in which we have included it up to 2000 microseconds. We can alter it anytime. In the program, which can be varied according to the user's preference, so that the sound module doesn't beep every time someone blinks the eye. The alert system is a simple one, a very simple one comprising of a powerful yet reliable sound module, in this case our buzzer module. In our prototype, there is a simple buzzer module powered by the battery and controlled by the output of an IR sensor received by the microcontroller. We also plan to install a solar backup system for drivers engaged in long trips and replace the IR sensors with other sensors which have greater range of perception and don't directly emit infrared light in such close proximity to a user's eye. We all know that any type of radiation beyond the visible spectrum might be dangerous for us. Especially, we plan to change this. We plan to incorporate other sensors which are lesser harmful for the eye, which are perceived to be lesser harmful for the eye. Also, we plan to incorporate a solar backup battery system so that the user doesn't need to carry a 9-volt battery always with him. We plan to install a solar backup system so for long trips, so that the user can wear it while it's getting charged, and it doesn't need an external power source or outlet to charge it always. Now, moving on to the next slide. What are the things we learned? We were we take first year engineers when we made this project. We knew very little of the advancements, what we are going to do. Now we are in the second year, we are pursuing the second year. So it was a very new work for us. So we learned a lot of things. We learned that the IR sensor had its own range of perception and capability, that how much we should keep it in the proximity of the eye to sense to sense it or to increase the precision. The IR sensor's area of sensing is often bigger than the human eyeball. We know that the IR sensor can sense the area up to an A4 sheet. So we have to calibrate it to such a level that it senses the minute changes in the reflected amount of light in the person's eyeball in the very close proximity. We needed a buzzer module to work according to the program, so we put up earlier in the Arduino. Next, moving on, what are our future plans? We plan to use lithium batteries, the same ones that we use in our mobile phones, at a much compact level, which are chargeable, and also sound module which is biologically safe for our eardrums. Our module sensor aims to be compact for minimum disturbance in vision, and we will install a digital regulator which will help us in decreasing that time intervals. As I said, that it might be difficult for the user to continuously go to the program and change it. We don't trust the users, or we don't want the users to continuously change the program while they're doing it. It might be inconvenient for them. So we will include a digital regulator, which will help them to change the time, the interval from 2 seconds to 1 minute. Considerable amount of research is going for replacing IR sensor in all the perceivable ranges. For example, in the previous technology I told about the parking system, we plan to change it in future by a polymer contact lens, which can sense the movement of ciliary muscles or can detect the change in intensity of the incident light on the cornea. We see that with increasing advancement in technology, things are becoming more compact. So with that progression, we believe that we might be able to include it as a normal glass someday. We might be able to release it as a normal glass someday. We plan to develop a system which measures the integrity of the outer layer of the car when it experiences a collision. If the car's outer shell integrity is lower than a fixed value, we will automatically send an SOS to the nearest hospital or to the nearest relative as per your choice. All these things are operated by a microcontroller and a part of the vast topic called Internet of Things. We know that whenever a car experiences a collision, there's a cell integrity of the car which is hampered or which is compromised. We can use a sensor to measure the shell integrity, and if the shell integrity is compromised below a certain level, we can then import GSM network. We can import a GSM communication system and then automatically send a Save Our Souls or SOS call to the nearest hospital, police station, or a nearest relative, informing them that there is a certain accident faced by the driver. Now, this is the working of our module. Pardon me because it's rotated in 90 degrees, but this is the working auto module. Let me play it. I guess it's not audible. The buzzer is the buzzer audible? Is the buzzer sound audible?
No, it is not. Sorry.
Sorry for the inconvenience. Actually, the PPT presentation might be some of the technical glitches. It's not audible. But whenever the user closes the eyeball for 2 minutes, the buzzer will ring. Okay, moving on to the next slide. We want to acknowledge all the seniors and faculty members, especially Mr. Shomanson sir, Assistant Professor of Department of Electronics and Telecommunication, Association College, who has been our mentor throughout this journey. He had told us of several platforms where we can take this project and learn from it. And our seniors, thank you to them for realizing our potential, and thank you to the organizers of this event for giving us a chance to represent this. Last but not least, thank you everyone. This was our project, and this was the paper regarding it.
Thank you, Pa. Any queries? Next, we call on the ICDT MS0504 ship collision prevented using emergency collision prevention track rudder ECPDR. Chief Engineer Soundarajan sir.
Hello, good morning, one and all. I hope I'm audible, madam.
Yes,
Am
sir.
I audible?
Yes, sir. Yes, sir.
Yes, thanks to one and all in this department. Thanks to principal for giving me an opportunity to speak on this forum. And we have been seeing so many dignitaries have expressed their views and how we have to, as an MTI, how we have to improve ourselves in a greater way. So I wanted to straight away put my speech towards the cadet that you should understand. When I was there, when I was as a sailor, when I was sailing as a chief or even on the lower ranks, always I used to remember what I'm doing. I'm just repairing and passing on to the next oncoming, just repairing and maintaining. I have not done a single bolt at designing factor during that time. That crops me in my, during my sailing period. I have to do something like what others, other countries have been doing. They have been innovating, they have been designing in a lot of equipments on board. They are bringing in so much of this thing. And what we are doing is just to operate that. I wanted to see, okay, let me also look in. We are also engineers. We are not a mechanic, as we are just doing the repair work or maintenance work. It's not a mechanic. In fact, Norwegian marine engineers call chief mechanic, second mechanics, like that. That word is quite towards the maintenance and repair part of it. So I thought, let me make something. So I have made a lot of projects here and there, and I kept it for me, and I used to share with so many people. One of such is this one, ECPDR. Whatever you have on the road, even if you have a car, a Plymouth car or a Fiat car or a Mercedes Benz, there is a brake. There is a brake, there must be a brake, and on ship, there is no brake. So the collisions are happening. So what I'm trying to do here to all the cadets, just to understand, put yourself as an AMET, which is there. 1 minute, please. I would like to speak for a minute, and I'll go through the listen. I'll go through this PPT. Just a bit, madam. 1 minute. I wanted to emphasize at this juncture that cadets, please go for some projects. Cadets have some innovative ideas. Cadets in future, this is the future participation is very important, and the only institute, rather university, is AMET, wherein you can gain. Thereby, we are going to enhance the AMET into post-graduation in marine engineering. We will do something on the research also. We will be pioneer like what we have been for 2 decades. We will be pioneering in the research also. To motivate you in this aspect, I have one such item which I have designed few years when I was sailing in 40 years back. This one project which is called the project ECPDR. Whatever happens, even let it be autonomous ship, this ship, that ship and all, you should have a brake. Where we don't have, at this moment, we don't have any brake or something like that. So I was thinking what else we can do, at least to slow down, at least to change the direction in drastic turning. So the project which I have developed is this one. So I'll go into this a little bit faster, and thereafter I will be asking all the cadets to involve yourself in the project, and we will do some research oriented, and we develop this AMET into pioneer for research oriented center like other MTAs in abroad. like Australia, AMC, UK and all. We will develop to that level, and I hope we will achieve in that with the so much of facilities, infrastructure, so much doctorate in various engineering divisions. You cannot get anywhere in India except for AMET. So with so much of chief engineers available, masters available, and doctorate available, very great opportunity. So I commence my introduction of my project, which is called ECPDR. As the name implies, it is Emergency Collision Prevention Drag Radar. Okay, next please. Yeah, it is by me. It is an additional mechanism is deployed to decrease the drag, to reduce the speed instantly by decreasing the turning circle of the vessel. Whenever you are facing in front of you, some vessel is coming, all the systems failed. Finally, you are bound to you hit the shape, so we can employ this ECPDR. This is my own presumption, my own project. Let us see how it is going to work, and I am going to put forward all these things for you in front of you. Please adjust and let me know what it is. Okay, right, so next please. An auto operation with a motion sensor at the forward of the vessel is linked in conjunction with the close point of approach. This is the one phenomenon which is there in ARPA on the bridge, which is called automatic radar plotting aids, where there is a close point of approach will be indication of there. Even that fails. After that, as a 11th hour measure, is ECPR PDR, which I'm going to introduce. Next, sir. So these are the motion sensors which we have, transmitter from the forward, and it senses everything from the forward and receive the panel in the engine room, electro-hydraulic mechanism in the engine room. And it is like a rudder. It is like a half shell bearing, half in size, that can be deployed when the ship is in motion. Any ship of any size. The next please. So you can see here, if it's possible to enlarge it, please, possibly. Yeah, you can see the motion sensors which I kept in the forward, that is sensing out, and it is collaborating with auto manual steering switches and all. The sensor camera are placed in that vantage point, capable of seeing the motion picture, distance and all. Okay. Hello, please. Yeah. Can you just expand this please for me? Yeah. And it is the ARPA which is there in the second picture. Sensor is linked with the CPA and gives alarm like, okay. So the motion sensor cameras are placed at vantage location, capable of seeing the motion 1 nautical mile, and you can see the signal is received through the junction box and collaborating with the EPA. Sir, it's faster. Please stop it. I'll go proceed in that way. All right. You can see what it is in the. Can I proceed, madam? Can I give this thing? Yeah. All right. And you can. All right. Then you can see how it has been. You can see how it has been drawn inside. The radar is not going to be visible outside. It is like landing gear of the plane. Only when it is landed, it is going to drop. It is going that the wheels are going. Similarly, this drag radar, which is shaped like this, which is given in the 4th figure, will be deployed in conjunction, all by automatic, or it can have the human officer of the day of the watch can also activate that. Next, please. A panel at the bridge, the unit. Okay, next, please. Next figure. Possible collision captured by the motion sensor. All sensor signal converge to a panel. Resultant signal is transmitted to ECPDR. All right. Hello. All right. In bridge, CPA and ARPA are data compared. Alarms extended to master cabin, CCR cabin, ECR cabin, and the telemotor signal is also compared. Steering gear is linked to ECPDR. local execution, hydraulic panel, everything we will be seeing. And thus, by employing this ECP emergency drag rudder, it is going to slow down immediately, creating much more drag. At the same time, it is going to divert the water in one or the other angle according to the motion, according to the collision ship which is ahead. Please, next. Next, please. Yeah, you can see normal sailing, there is no certain collision course. We have to see, oh, it is going to collide, definitely it's going to collide. But this system, employing ECP instant remedial action to prevent collision, it is either it can be kept at the aft, next, or at the forward, or on the sides, which we can deploy. It is not only going to create a drag, but also will help in turning the angle. Now here, now that is the second picture, we have the ECPR on the sides, or otherwise we can have in line with hello. Understand? So okay, ECPR is the bridge action is initiated. Okay, these are the steps what we can achieve in the wrong direction. In case if it is going also, it is connected to the ARPA, as well as it is connected to the CPA, and this can be accommodated, this can be activated automatically. When doing such, when doing like this, instantly the ship can turn and avoid any collision. That is the criteria in this. All right, next, please. Okay, this is, we have already discussed on that. Next, please. So this is the one which the link and all, it is given here from ARPA. It is linked to the CPA system, and you got a base unit in the bridge, and you can see from the cameras what we have put on there, and the signal goes to the engine room. Next, please. Existing ship collision, if this has to happen, it will happen. There is no remedial action because of the momentum of the ship, and we can do nothing as there is no brake. Here, ECPR is going to apply certain amount of application, applying the brake is going to happen, as well as it is going to reduce the turning circle so that we can avoid at least some, many occasions, on many occasions, you can avoid pollution. Next, please. So, fitted to increase the drag and decrease. This is what it is. We are given, and it deployed vertically down, extension from the keel. I told you as before, it can be retrieved inside when normal sailing. It is deployed only when we have to do it manually or automatically when the collision is imminent. Next, please. So now here, it is not only the ECPR, besides producing sufficient drag, turning in conjunction with the main rudder, giving an instant additional drift angle in the front, in the bow, and reduces the starboard side turning circle. The turning circle, if it is normal turning circle, it will reduce by this drag rudder. I can judge to 20 or at least 5 times the smaller circle. The size it can reduce. This is what the peculiarity. It is not only acting as a dragging, but also guiding this the flow of water so that it creates a high-low pressure. The bow, the front of the ship is creating the more drift angle, and thereby hull acting as a rudder, which is going to turn the ship faster and thereby decreasing the turning circle. Next, please. So here, if it happens to the port side, similarly, it can happen. It can turn to the starboard side also. This is the way it is working in conjunction with the main rudder. It is working in the conjunction with the main rudder telemotor transmitter system, which will be also concur with the ECPDR panel in the engine room, and it will act full hard starboard or a hard port in accordance with the main rudder turning. Next, please. Now you can see the ships when it is there in the second picture of the ship. You can see it is inside like a landing gear of an airplane, And when it has to deploy, it will deploy straight away vertically down, and the dragging is going to happen. It will slow down the ship. At the same time, it is going to decrease the turning circle drastically, thus avoiding emergency collision, which is imminent. Next, please. So this is activation of rudder, which I have given using the hydraulic system and all. The telescopic actuator attached to the ECPDR that is there in the engine room, which will immediately release, because the hydraulic pressure is in the accumulator pressure. The moment the solenoid valve releases, the hydraulic oil pushes. It takes about hardly 10 to 15 seconds to drop this anchor and activate, thereby creating extreme drag condition, and to slow down the ship as well as to turn the ship to increase the turning circle. Next, please. So this is the hydraulic actuator, which will be there in the engine room. If we are not convenient to put in the engine room, we can put it in the forward. Normally, when we try a car or something, the front wheels are being steered. Similarly, we can have this special drag rudder at the forward, and we can have an extensive turning circle by deploying this ECPDR. Next, please. Next, sir. So manual deploying is also possible. You can interact with that, and we have a selector switch, auto or manual or emergency situation. All the three modes of applications can be had for this. There are so many gadgets in the nowadays, like AIS, VDR, and ARPA, or GPS and all. This system will be incorporated, indulged, or in combination with the CPA. This will be working on the bridge if this model is proved, and we are going to conduct a test of this, and I hope we can achieve, according to the size of the ship, we can change the size of the rudder. Next, please. So this is what the size of the ECPR depends on the size of the vessel, and the momentum actual calculation can be derived accordingly. We can deploy. As I told you, it will take with a maximum of 20 seconds. When the motion sensor is sensed, when the collision is imminent, the signal comes to the bridge, corroborate with the CPA, and the APA gives the signal to the ECPDR panel in the engine room, deploying the drag rudder, which you are seeing the picture right now. Next, please. So this is officer of the day or the watch can prevent an imminent collision also. Turning can be operated in auto and manual mode. That's what I told you. And directing the water flow, which is coming from the front, it directing to 90 degrees transverse, 100%, the turning circle is going to reduce drastically. That is what they aim. In addition to the dragging, turning is vital, which we have to know in this, and increasing the sway velocity. And the hull is subjected to so much of opposite reaction force according to the Newtons. And actually, many people do not know, it is not the rudder which is turning the ship. It is the hull of the ship which is turning the ship, creating a drift angle in the front. That drift angle is being achieved by the main rudder, but to augment that turning circle, this extra rudder that is called drag rudder will be of immense help during these emergency conditions. Next, please. So this is what I have given here. These are all telescopic, like a crane moving this jab or the boom in and out. This can be just dropped using that. The hydraulic pressure is using the accumulator, as I told you. So in addition to the dropping, in addition to the straight dropping, it will move on either direction, 35 degrees to port to 35 degrees starboard, thereby directing the water to assist the main rudder, decreasing the turning circle drastically. Next, please. So in conclusion, in a nutshell, the ECP-DR design is a unique operation working in combination to produce drag and to improvise a drastic turning of the vessel in emergency. This is a rough DPR actual engineering concept in forwarded in due course, because this I wanted to tell our cadets. Sir, 1 minute, I would like to present my screen because some are missing here. I cannot do that. Can I do that, sir?
Yes, sir, it's possible, sir.
Yeah, because there I have, which I have posted only in the last night, which I have prepared. Are you seeing my picture, madam? My screen?
Yes, sir, your screen is, yes, sir.
Yeah, my screen is visible there because yesterday only I have, night I have made this PPT. I think you have made it from this thing. And I wanted to tell boys, I wanted to tell our cadets, all right? This is the one which I wanted to show that the turning circle is very, very important factor in this connection. All right. So here, all right, ma'am, can you see this for me, please? Can you see that?
Yeah, we can see it, sir. We can see it.
The ECP-DR produces sufficient drag turning in conjunction with the main rudder. That's very important here. And we can put it on either direction of the vessel. And thereby, it is not necessary, it has to be in the aft side, it can be on the side, it can be on the forward side also. All these things will happen and by deploying this drag rudder. What I wanted to emphasize to our student, we can have so many things, so many research and all. We have to, I myself, being the engineering department, want so much interaction from the boys, from our cadets in the form of research. We can do, there are hundreds of research which is possible. We don't want to be a mechanic or the chief mechanic on board. We wanted to produce our own concept. We wanted to increase as an Indian-oriented one. So much of 3,500 coastal areas, still we are so much back. And by guys like Singapore, they are doing so much of shipping work and all by the design. So we want as AMET is the only institute, the only university which has got all the infrastructure, all the faculties, even the doctorate, PhD levels, even the chief engineer. So next year, when we are going to give, we will be very happy to see so many research-oriented students right from now if you do that. So what our intention is to have a postgraduate study in marine engineering and the research study in marine engineering, so that we can produce our own. AMET stands as a pioneer in that connection also. For example, I'm going to give you a little bit of ideas what else we can develop in this. Just watch it up here. Can you see this? This is how we can develop a wave energy. The waves going in and out, a box is there, the waves is going to compress and in a chamber, it is going to turn a turbine, we produce current. This is one of the projects which I have made. And I have also made one drone. The drone which is going in the skies only. We wanted to make a drone which is going down and do the underwater inspection. In matter of 2-3 lakhs, we make a drone, and anytime we can deploy. Okay, my condition of the propeller okay, why my sea chest is okay, everything which we have designed, it is also in the factor. So what I'm trying to say, all these things are to impress, to lure our own student to go into research-oriented way of education. This is what is required. It is not that every time we read the same thing and we all converge into as training marine engineer. I had only two during that time, only 2 institutes. Now in Madras, in Chennai itself, we have got 20 plus. So where we are going to, all are going to converge in the TMC. Know that way. not that way henceforth. We have to develop into research. We have to develop into post-graduation. Thereby the opportunities are widespread. You can join in the shipyard. You can join as a surveyor. We have got naval architectures. We are all naval architecture PhD holders. So we can through them, not only through them, we can make the chief engineers help you. We can make the naval architecture help you. We can make all the doctorate who are there present in mechanical engineering to help you to come up with something like this. So that if these are all for luring, it is not to pat my own shoulders, just to tell you what all we can do. What all we can do. Now here you can see this one I have developed to make water, the underwater current turbine, underwater turbines here. So these are the things which you should realize and come up. This is especially I'm addressing to the cadets of ours, because as Mr. Sanjay Bhavnani or Mr. Shivaraman from Cochin, CEO, they are all emphasizing only the same thing. Please make yourself to fit enough for the future. It is not that I keep on teaching you, because I've been interacting the cadets only with the lessons and all. Now here is a platform which Principal Sir and the Marine Department has given me to speak, that the research oriented one which is going to help you, and that is the future. It is not autonomous. Even autonomous shipping has got to have safety. So such projects like ECP DR, which is the collision prevention, will definitely help. Such research has to come out from the cadets. We are there to help you. Now you can see this one is to produce FTPS. This one to increase by producing the air bubbles, decreasing the drag, and thereby increasing the speed, and we are getting more. We are saving more money. Even the drag radar, when you want to anchor, just because I was in the world largest ship chief engineer, right? We have to go, if you have to go stop at 30 nautical mile, right? From now, about 2 hours before, I have to slow down. If I have the ECPDR, I will go straight closer to 5 nautical miles, deploy that, decrease the speed, and anchor. I save my fuel. I save my time, maneuvering time. So these are the concepts. Not only that, you have to be prepared for a step towards the green propulsion. Okay, we have to have this sort of tendency in the mind, right? This is the Flettner, which is going to be the future. The Flettner shipping, the Flettner rotor, this is called Magnus effect. By this, it is a sailing. It is a sail when those times the ship is to sail. Same principle is going to come. And this is the Flettner rotor, which is going to drive the future ships. There is no fuel involved in this. Okay, here, there is another one where we can do in the shallow waters. We can bring up the propeller up and down so that I can operate the ship anywhere in the shallow water with a minimum shallow water. All right, in loaded and ballast condition. So why I'm telling all this, even the configuration, even the accommodation should not be just wind blowing towards that and dragging is happening. So we will construct the accommodation in such a way it is aerodynamic, aero profile. Right? All these things are there, which I am showing you right now. This is the magnet effect of the Flettner rotor. This is going to be the future with the autonomous ships, like. Okay, so by all these things, what you should do, if you try to stop things and stop to think in motion on board, you will sink. Understand this very well. You have to think always as a marine engineer. As a chief engineer, your responsibilities are going more and more. So if you try to stop things and stop to think in motion on board, you will sink. Understand that. So with this, if the facts don't fit the theory, change the facts. That's what you should. That is what your ambition has to be. So there are so many things which I have been telling. There are 6 stages of project when you make a project. So understand what are the project. Say confusion will happen. All right. So then the second one, first one is the enthusiasm you must have. Second one is a confusion. Third one is a panicky, which you will be trying to go away. Fourth one, you will be hunter for the guilty, whatever it is, and you can see punish the innocent, and finally reward for the non-participant also. So that so much is the involvement of the cadets towards the research. And I believe the only platform, the only university in the whole of India, I'm repeatedly telling, because we in the past 2 decades, we are the pioneers of marine, as well as the university now, which has got so much of 30 to 40 doctorates and chief engineers and infrastructures. Please, please, please use that and go into the research forum, spread your wings. It is not only congesting towards the training marine engineer, you go in the different forum of career and improve. And we will ensure, as faculty myself of AMET, we will ensure more projects will come, and we will have the research-oriented institute in a marine way. Thank you. Thank you to one and all.
Thank you, sir. It has been a really, energetic lecture, I should say, and a lot of research work. And of course, as you have projected, our cadets have got a very good future in getting into all these activities one by one.
Yes,
the willingness of heart should be more and more from the cadet side. It has to come in. Now here we are, as you rightly said, Amit has created a wonderful platform with good volumes of chief engineers, I should say, doctorates, the mechanical department, the electrical department, and so on. They are very helpful.
Nowhere we can get such facilities, sir.
Yes.
Everywhere, even naval architecture in the doctorate level.
Yes,
even a chief engineer experience level. I was 40 hours into marine industry, and I'm still learning. With the attitude, with the perception of the current cadets, who has got very exponential knowledge in interacting with their gadgets. If they apply to this, which is going to be an automation, autonomous ships and all, which will be of immense help, so that we don't be a mechanic. We don't be a mechanic repairing what others country has found, 600 equipments on board, right? Not even one bolt I have done in 40 years, designing. What I have done, I have just screwed it in and taken it out. Why I have not done that? Because we are not research oriented. This is what we have to have, and AMET is the platform. We will definitely achieve with all the cooperation with the Marine Engineering Department. Thank you very much, sir.
Great, sir. It's thank you very much, sir.
Thank you, sir.
Yeah.
Please make us enquiries, please, sir.
Regarding another question, regarding the turning of the vessel by the drag radar, suppose there is one more vessel there, will it be sensed by your EPCDR?
In 1 nautical mile, because even the CPA fails, which is 6 nautical miles, even the officer of the day sleeps. This sensor, which is motion sensor, 1 nautical mile it will sense, and also it will sense in such a way where what action you have to take. Suppose if the officer of the day, officer of the watch woke up and suddenly giving the wrong direction, straight away going into the collision, it will give a wrong direction alarm. Also, it is going to give an alarm, not only in the bridge, but also in the CCR and the master's bridge. Yeah, the collision is imminent. We are going to deploy this ECPDR. Once it is done, 100% there will be a dragging which is going to take place. 100% there is a drastic turning is going to take place, decreasing the turning circle by 1/5.
No, I am coming to the point of turning only.
Yeah.
If there are cluster of boats, especially you become tired during the discharging time, and then you
there are occasions everywhere, right? There are occasions, every occasions are there, but 90% this deployment of ECPDR is going to gain by fuel also. Even in maneuvering, I go fast and stop. It is not that I have to wait for 3 hours of maneuvering, 3 hours of fuel wastage. Such things are there. If there's a drag,
double astern is there. Already double astern is there.
Sir, whatever it is there, you have to talk and all. Even if it is there, everything is there. Even the human is there. Even the officer is there. Still accident happens. Everybody is there. Still accident happens. This is the 11th hour deployment. An aid, augmentation for preventing collision. In spite of everything is a final action. This is what I want to emphasize, sir.
No, I don't want to discuss on that. I want to say it is not a fail-safe method. Your EPCDR is not a fail-safe method. You can say that it is absolutely fail-safe. It also has got sensors and so many hydraulic units.
Yeah, that and all. You see, it is a concept now. It is a baby. It is just born. If you go at it, I can consult with our own PhD. I can come up with a fail-safe with the naval architecture. I can come up with a design with the other chief engineers like you. I can take some input. We will do it. We will do it afterwards. No problem, sir. Just a concept it is.
Okay, Sundarajan, I have a question for you.
Yes, sir.
Okay, now this is a retractable extension of the shaft.
Yeah.
Of the wings of that EPD or what you call it, the wing, like an aircraft wing.
Yeah.
But what about the momentum? At the momentum,
not the wing, sir. Not the wing. It is like a landing gear, right? Like a landing gear, the wheels. Because I don't want to have the ship dragging to reduce the speed. Then only in emergency it is deployed.
Yeah, when you lower it, when you lower it to the water, what have you considered that it can get sheared off? You know, the momentum of the ship.
The same. Whatever the material you are using for the main rudder, whatever the principal hydraulic you are using for the main rudder, we are using this one, so it is not a problem.
No, rudder is fixed at it's not going to go. It retract inside outside. But you are talking of is going to be retracted inside outside.
It is so much of weight, tonnage and all, according to the size of the ship. The crane which is having a telescopic, a crane which is going to lift 200 tons, 1,000 tons and all, with this telescopic way of approach in the hydraulic approach, I will use that.
Yeah. So you mean the keel plate has to be strengthened to that extent?
That portion, that minimized portion. Yes, sir. Or we can employ it. We can employ in the forward section, not only in the back of the front or in the sides of the. We can do that, sir.
So thank you very much, sir.
We will discuss later.
We will discuss this later in depth. We will have a separate session for this.
Of course, it is a baby.
Yeah, because we have many more speakers also to go on, please.
All right, sir.
Anyway, kindle the interest we can see. We can take it up later on. Thank you.
Thank you, sir. Thank you. Thanks for thank to one and all, sir.
Yes, sir. Thank you, sir. Thank you, sir. We will have a Monday session for it. Thank you, sir.
Next, we call on the IC DTMS 0203. Effective transmission of marine surveillance video using up and down sampling. Author is Anbiran Pacha, Sonali Circa Professor. Next, extra. Thank you.
Hello, good morning, everyone. Is my screen visible? Hello.
Yeah, your screen is visible now. Yeah.
Yes, sir, your screen is visible.
Okay. So, very good morning to all of you. Our paper ID is effective transmission of marine surveillance video using up-down sampling. So, we are from JIS College of Engineering, West Bengal. Now, so first I have to say that what is the importance of this, of our research work. In marine engineering, one main part is the video surveillance. Whatever it may be, the coastal area, it may be the port, or it may be from ship. And the main problem of the video surveillance is that in this video surveillance, actually to store these video images, it takes huge space, okay? And it takes too much time. Also, it is very, very difficult to transmit over a long distance with the available bandwidth. So our main target is to proper utilization of storage space of the video data, because we cannot stop this video surveillance. okay, and to share it with the optimal bandwidth and to make the process fast. These three are the our main target, but our highest importance target is to proper utilization of the storage space, because storage space is the main criteria for the marine surveillance video storing. Okay. So for this purpose, we are using downsampling and upsampling. Now, what is downsampling? Downsampling process is that, suppose this is an image, okay, 5x5 image. Now, there are 5 pixel in row as well as column. So I am just explaining this process with a very, very simple example, the downsampling process. So in downsampling, we are eliminating the alternate pixel and we are taking only the alternate pixel. Okay. So that is done in both row wise as well as column wise. So look it, the green color pixel, the alternate pixel, they are accepted from the row wise and from column wise also, and the red color pixel, they are eliminated. So what is the result? From 5x5 image, it has become a 3x3 image. Okay, and maximum pixels are eliminated. Now you can ask me that if we eliminate a huge number of information from the video, made in video, then there will be a huge loss in the image. Okay, image will be blurred, the image will be degraded, we cannot analyze the image. But we will prove that if we perform, in spite of performing or applying downsampling, image quality remains almost constant. Of course image will be lossy, but from human visual perception system, our eye cannot sense the difference. Okay, but we can save a huge space. That also we will discuss now. So downsampling, already we have discussed that we are taking the alternate pixel and we are eliminating the other pixel. Now to reconstruct it, okay, we are transmitting the downsampled video to a long distance. At the receiving end, sometimes we have to reconstruct the video, okay, to maintain the same size. Now at that time, so how we can reconstruct? We just add in between zero value in between the pixels. Okay, so the blue color pixels are zero value pixel, they are added together. From downsampling, whatever pixel we have eliminated, and then we have transmitted this small image. At the upsampling, we are replaced the same pixel by the zero. Okay, so this is the basic idea of downsampling and upsampling, and in our process we have utilized this property. So the video is first divided. We are first, I say that we have worked with a 1 minute marine surveillance video. Okay, and we have first divided the frame into video into multiple frames. In 30 frames we have worked. Then we have applied downsampling, transmitted it to a long distance. Then at the receiving end, we have again reconstructed this, and this is our work. Okay, the selected. So I again repeat that actually we have worked with 30 video. Okay, so 30 fps system per second, 30 images are there, but here I have represent only 12 images. Okay, so the selected 12 selected videos are there, the surveillance video. This is the original video. Now we have applied downsampling. Look, of course image is lossy compared to the original image. These images are lossy. Okay, there are many losses, but our eye cannot sense the difference. Our eye cannot sense the loss. Okay, so that's why we can compress the images or the video by using downsampling. And at the receiving end, this is the upsampling. So quality from human visual perception system, quality remains almost same. This is the original image. I again show, this is the downsampled image. It is transmitted, and then at the receiving end we have to reconstruct the images again to form it the video. Okay, now the comparison result analysis. So the image size, what we have taken 800 cross 600, that means 800 pixels are in row wise and 600 in column wise. We have downsampled, divided it. Okay, and then upsampled to maintain the same size. And what is the main advantage? Just look here, our selected video, only 1 second video, it consumes 1.46 MB, whereas the downsampled video where we are transmitting, that is 0.9 MB. So per second we can save 0.56 MB. I repeat it again, per second we can save 0.56 MB. Okay, so in a 1 hour video, so we can save a huge space, and time required to do this entire process from beginning start to end, it takes 0.7 second. Okay, that is less than 1 second, so it is a very fast process. PSNR and correlation coefficient. So they are basically used, we have used to maintain the quality, to check the quality, to measure the quality parameter. PSNR, peak signal to noise ratio. If it is value is greater than 25, image quality is very good. It is represented in decibel. If it is less than 25, image quality is bad. Okay, but in all cases, again I am saying that only in 8 images we have displayed the result, but we have tested on all 30 images. Okay, so in all case the value is greater than 25, so image quality is very good. From the result we can decide. And correlation coefficient means we are comparing the two images. If the two images are same, then correlation coefficient is 1. Okay, and if there is no relation between two images, correlation coefficient is 0. But in our experiment, our research work, in all cases correlation coefficient is very close to 1. Okay, that's why it actually indicates the very good reconstruction process. So the literature survey for our research work. Thank you for listening, and now I am expecting question and valuable suggestion from the respected dignitaries. Hello.
Yes, thank you, Anirban, for participating and presenting in our conference. So kindly wait for the queries. Okay.
Okay. Thank you, madam.
So participants, if you're having any queries, you can ask Anirban. Okay, we'll be present.
Sir, it's a very interesting, development which you have brought in. I hope you're able to hear me, sir.
Hello. Yeah, sir.
Yeah.
I
think
can hear you.
we have a lot to discuss on this one. It will go on for a day also, because now I find with this data reduction and available of space for another utilization, really with the module what sir has explained in the previous the rudder point of it, the emergency stopping circles, there I think we need your help in getting the model designed. Definitely we will keep in touch and get get you also into the design point of it, and we in the model design point of it, and we will get things moving, sir. Thank you, sir.
Okay, definitely, sir. I am ready to help you.
Yes,
actually, we can compress it too much, sir, to save the more space. But
Correct.
problem is that if we compress too much, so
yes.
more information we have to eliminate, and therefore the image quality will be degraded. Okay, so
Yes.
whenever we have to analyze this, so proper analysis is really it will be impossible.
Correct.
So that's why we have maintained the compression ratio in 0.75.
Sure,
okay,
sir.
that's the problem.
Sure, sir. In one of the design aspects of model design aspects, we will definitely include you also, sir. And we need your help more and more to get the best outcome. And it will be a test also for us. And we can improve on the speeds accordingly, sir. Thank you, sir.
Okay, thank you. Thank you very much. I am always ready to cooperate with you.
Sure, sir. Thank you, sir. Thank you.
Sir?
Yeah.
Sir,
yes.
How much would be the computation power required for the downsampling? If so, then how much?
Sorry, sir. Please repeat the question. How much?
For processing of the video for downsampling, we would need computing power.
Okay, very good. So, okay, I understood. Sir, actually, we have used or we have done our research work in simulation software. So the computer where we have applied it is i5 processor, RAM is 16 GB, and we have done it in MATLAB 2015 version. Processor i5, RAM is 16 GB. Actually,
Thank you, sir.
optical hardware also we can use, and in previously I have also used this before the pandemic situation. But in West Bengal for more than 1.5 years, all the universities are closed. That's why I am unable to show you the result using the optical hardware system. So this system you can apply both in software as well as you can do this in using the hardware also. Okay.
Thank you, sir.
Okay, welcome, sir. So may I stop the sharing now, sir or madam, if you permit?
Yes, sir. Yes, sir. You can stop, sir.
Okay, okay.
Thank you,
Okay.
sir. Thank you, sir.
Thank you for your kind patience.
Thank you,
Okay,
sir.
definitely I shall contact with you. Keep
Thank you,
contact with you.
Thank you.
Okay.
Thank you. Thank you. Shanti ma'am.
Yes, my panelist, they ask a question.
Okay.
Any questions in the panel? You can post, and you can also mail it to sir also. If sir gives the mail ID, you can mail it to sir in the later stages too. Dear
Yes, sir.
cadets, don't miss such opportunity, because very rare, as Mr. Soundarajan sir and others, we all insist on, is these kinds of platforms has to be utilized by the cadets to the best of the knowledge. It is for you. So you have to act now, and you can see wonders when you achieve something. Thank you.
Yes, sir. Thank you, sir. We'll be our students, cadets, will be having collaboration with those students and do some projects with them. Okay, sir. Thank you, sir.
Okay. Okay, welcome. Actually, I am working on video compression. Okay, in my PhD topic is this. There are also many process. So later we will discuss in detail. Okay,
Yeah.
which one will be effective for more effective for marine surveillance.
Correct.
Okay, thank you. Thank you all for your okay.
Thank you, sir. Thank you, sir. Thank you. Yes, Dr. Shanti. Yes, Dr. Shanti.
Dr.
Hello.
Shanti, madam?
Yes, sir.
Yeah, next, please. Next participant.
Next, ICDT-MS 0117 QR-based Aadhaar electronic voting machine for privacy and security enhancement. N. Prabhakaran, sir.
So, Dr. N. Prabhakaran, sir, please, you can present.
Ma'am, my voice is clear?
Yes, sir. We can hear you. Yeah, we can hear your voice, sir.
I'm sharing my screen. Can you able to see the screen right now?
No, sir, but you can present now. You can start present your PPT,
2
sir.
minutes, 2 minutes, ma'am.
Yeah.
2 minutes.
Yes, sir.
Whether it is visible right now?
Yes, sir. We can see your screen. Yeah. You can continue, sir.
Yes, ma'am. Yes, ma'am.
Thank you.
Thanks for giving me the opportunity for selecting my paper in electrical engineering. My proposed topic of research area is QR-based of the electronic voting machine for private and security enhancement. Right now, in India, many people have put voting. That is, once they identify with the security, or whether it is under normal environment or whether it is in a virtual environment, they have a small doubt in their environment. So in my proposed area of research, it is mainly to identify the security, whether the voting is done in related to security application with related to the vote has been done or not. So the main aim of the research is nothing but to have a fingerprint authentication system as well as the author vote identification system in order to have the security application. Meanwhile, whenever the people get voting, you will be having the electronic polling machine with respect to the electronic project for that is nothing but a valid application for any person who vote in database administration system through Wi-Fi. Okay, whether the voting is done parallelly. Now the project is, that is the proposal is designed with respect to two system of security. One is due to the QR based, and another one is nothing but your thumb expression. Once these two are identified, you can able to analyze whether the voting is done with respect to the security, that is 100% of accuracy is delineated with respect to the voting machine. Second is nothing but when Wi-Fi is connected, definitely there will be some theft will be that is the security will not be happened in any related application. So in order to see the security level, once the voting is processed through three processor. First processor, it is nothing but the machine is tested with the help of SCADA processor, where it is nothing but a time consuming processor. Moreover, when the time is increased, unfortunately the security cannot be increased at all. Next is nothing but when you use ARM processor, same, it is nothing but a time consuming processor. So I go for an advanced processor, which is nothing but an embedded processor. In order to then the security application related to the voting machine is done in a processor. So the scope of my research, it is nothing but whenever the security is enhanced with high accuracy, definitely there will be a processor with respect to security application. And then here the real-time authentication is required for many processors. Now I show the block diagram of the present processor, which is done by a microcontroller. What happens is when the machine, that is the device is implemented for real-time application, you need a power supply block, then you have a buzzer as well as Wi-Fi, and then you can able to check the security environment through server as well as the over the fingerprint authentication system. Meanwhile, when it is done in parallelized analysis, just like that, the voting is processed through microcontroller. Okay, now it can be processed through the server application where security is said to be mismatched. Unfortunately, the voting, that is the person who vote, is not authenticated. So there is a processor which has to be designed for future workers. I am taking a microcontroller instead of a processor design. So I will go for embedded processor. Okay. Unfortunately, the security with respect to accuracy is highly delineated. That is, the voter is 100% authenticated. That is, they are eligible to voter mission. Moreover, the future work of the research, it is nothing but people are waiting for the result nearly for 1 month. Now you can't wait for 1 month. Okay, nearly whenever a person with fingerprint authentication system as well as with respect to eyeball movement, okay, the result will be analyzed easily with respect to the processor. This is the hardware setup which is designed by the processor. Whatever information which the processor is analyzed through the voting machine, okay, the next moment itself, the voting will be counted for future work. Now, when the voting is counted, unfortunately, the time constraint is limited, and then the people cannot be waiting for a long time duration. So the voting machine, with respect to the enhanced security application, is highly delineated with respect to the processor of the machine. Moreover, the system can be implemented in a real-time application through another system as well as through another processor for further implementation of the processor. This is all the reference which I have taken for the study, ma'am. Thank you. Hello? Hello? Hello?
Sir,
hello? Sir, sir, it is audible, sir?
Yes, sir. Yes, sir. Let
Yes,
the people ask any queries.
Okay, sir. I will wait, sir.
Sir?
Yes, sir. Tell me, sir.
Sir, since you mentioned that Wi-Fi would be interconnected into the network, sir.
Yes, sir.
So would any external Wi-Fi would be connected or a secure server would be connected? Because the only loophole here I can see is Wi-Fi.
Yes, sir. Yes, sir.
So how are you going to secure that loophole?
I will study and tell you, sir.
Sure, sir. Thank you. No further questions, sir. Thank you.
Shall I wind up?
Panelists, please ask the questions, sir.
If any queries, you can ask. Okay, Dr. Shanti, I will, shall I call upon others? Next paper?
Yes, ma'am. Okay.
Yeah,
Thank
please go ahead, madam.
Yeah, thank you, Mr. Prabhakaran.
Excuse
sir,
me,
Dr. Prabhakaran, sir,
excuse
thank
me,
you.
madam.
Yes,
Excuse
sir.
me, madam.
Yes, sir.
Madam, how can I get the contact details of you? Actually, in future, if I want to contact details with the dignitary, especially Bhupati sir and Sundar Rajan sir,
I'll
if you
share it
have
with
no
you.
okay,
See, I
okay,
will share
okay,
it
okay,
with
thank
you.
you.
Actually, I am
Oh,
contacting you with along the acceptance and all I was sending you. So don't worry, I will send the contact number of Bhupati sir, Bhaskaran sir and other faculties. Okay. So
okay, thanks a lot, madam.
Okay, thank you. Dr. Prabhakaran sir,
Thank you, sir.
thank you for your
Yes, ma'am.
presentation. Okay.
Thank you, ma'am. Thank you.
Yeah, thank you for participating in our conference. Now I would call upon Dr. Hemalata ma'am to present her presentation in the session now. Yeah, welcome ma'am. You can present. So it is ICDTMS. Hemalata ma'am, have you joined? Hello, Hemalata ma'am.
Yes, ma'am. She is available. But your voice is not available, ma'am.
Hemalata ma'am.
Not audible, ma'am. Hemalata ma'am.
Hemalata ma'am, can you hear me?
Yes, ma'am. I'm audible, ma'am. One second.
Yes, ma'am.
One second, ma'am. Oh, sorry. Sorry for the delay. One second, ma'am.
Yeah,
I'll share my screen.
Okay, no problem.
Sorry for the delay, ma'am.
Okay, no problem, ma'am. You can.
Yes.
So Hemalata ma'am will be presenting the paper ID ICDTMS 207. Sorry, 607. Okay.
Good afternoon, everybody.
Good afternoon.
I'm Kemalata. I'm working as an assistant professor in Savita School of Engineering from Savita University. The topic which I'm going to present today is cascaded quasi-Z-source inverter for PV-fed adjustable speed driver. I outline my presentation with the following topics. It is introduction and followed by block diagram representation, and I will explain the circuit operation of modified diode assisted cascaded quasi Z-source inverter, then performance analysis of this inverter, and after performing the analysis, I'll be applying this for applications like adjustable speed drive. That is the outline of presentation. Is in current scenario, this PV application is recent day it is growing up. If you see, there was a two-stage system in power conversion from PV. Earlier, we were using a two-stage conversion system in which we'll have one intermediate DC to DC converter followed by an inverter. It goes with a two-stage conversion. This will increase the cost and the size of the component ratings. So it is better to go for a single stage conversion to reduce the component sizing, ratings, everything. For the quasi Z-source inverter was a better replacement, and it replaced very well. But the problem, it has reduced component ratings, it has reduced component count, and it was using a simple design. Everything was okay. But there was a limitation over this voltage gain and efficiency. When we are going in for a PV application, the voltage gain should be achieved should be very high, and efficiency should be good. So to replace this, there is some modification in cascade quasi Z-source inverter, and here comes the cascaded quasi Z-source inverter. And the drawback of this quasi Z-source inverter was overcome by this cascaded. It is of two types. The thing is, it is having one impedance network. It is designed with a passive component. That passive component will enhance the boosting operation. So here I am going to discuss about modified diode-assisted topology of cascaded quasi Z-source inverter. So after analyzing its performance, such as the voltage gain, then its voltage stress, then efficiency, everything, I am going to propose this inverter for a PV-fed induction motor drive. After this is the main objective. I am analyzing the circuit of modified diode-assisted cascaded quasi Z-source inverter and investigate its performance and compare the parameters of it for different modulation index, how the performance parameters are investigated, and then to simulate it for PV-fed adjustable speed drive. These are the objectives of the presentation. As said, this cascaded, it is otherwise called extended boost quasi Z-source inverter, can provide a single stage buck operation or boost operation. So these are the features of cascaded quasi Z-source inverter. Let me go to the block diagram presentation for a PV-fed adjustable speed drive. This is the block diagram, the PV model. For tracking a high maximum, to get a maximum power from this PV model, we'll be going in for a fuzzy MPPT. This is given to a single stage cascaded quasi Z-source inverter. Here the topology which I am conveying is diode assisted type. So we can see from this model, after falsification, defalsification process, this I am not going in depth. This MPPT operation I am not going in depth. This PWM generator, after getting the reference from the defalsification, it is given to cascaded quasi Z-source inverter, and it will adjust the output voltage. So output voltage can be adjusted. So after filtering out the harmonics, we can give it as an input to the induction motor drive. It is like a stator voltage control method. Stator voltage control method is one of the speed control method of the induction motor drive. If the stator voltage is given to the induction is varied, the speed can be controlled. That is the logic I am trying to bring it. The much focus will be given to the topology which I am going to focus. This is the circuit diagram of the topology I am discussing. Suppose we can look at this diagram. We have a PV panel as at the source side, and to the load side is the induction motor drive. In between this two is this modified topology of cascaded quasi Z-source inverter. That which is highlighted within the dots is the impedance network. This is going to perform the boosting operation of the input voltage from the PV panel. We know that we as an inverter, we have 6 active states and 2 zero state and 2 zero state. Here, additionally, we'll be having 1 shoot-through state that take care of this boosting operation. So input voltage is given. This impedance network will operate in shoot-through state to boost up this voltage. Then it is given to the inverter. That boost voltage is given to the inverter. Then after that, after filtration, it is fed to the induction motor drive. This topology is working in 2 modes. One is active state, another one is shoot-through state. Active state is nothing but boosting state. We have that in the impedance. I go back to the previous circuit. You can see within the dot, that is the impedance network. It is made up of inductance, diodes, and capacitor. This is going to take care of the boost voltage. In active, in shoot-through state, this diodes where the diodes are off. So what happens? The inductor will be start storing the energy. It is starting storing the energy in this shoot-through state. So that is the operation in shoot-through state. This shoot-through state we should operate it only for nanoseconds of time, and then it moves to the active state. That is the inverter. Power will flow from load source to the load. So now this boost voltage is fed to the inverter and it is given to the load. We can see the design equation. These are the design equation. So network impedance network design is made up of inductors and capacitor. That we have the equations. After designing, we have to choose the proper choice of the inductance. The inductance and capacitor chosen for the design was 240 microfarad for capacitors and 65 microhenry for the inductors. So the boost factor is given by B is equal to, that is the equations, basic equations of this topology. So design calculation, this is how it has been performed. The design calculation, we have achieved 65 microhenry and 240 microfarad. So the point is, I should look for performance analysis of this topology so that I can use it for this adjustable speed driver. Here, if we see the modulation index, modulation index, we know that inverter, the modulation index, if we vary, we will get the variation in the output voltage. Here, the modulation index variation and shoot-through duty ratio are given, and the previous formulas we have for boost factor. I'll go back to the previous slide. See, the boost factor is relying upon this shoot-through duty ratio. So we'll get this shoot-through for different modulation index. What is the value of shoot-through duty ratio and the boost factor and voltage gain achieved? We can. It is being tabulated here. This variation of modulation index, you can vary the boost factor, and voltage gain is this way, it is getting varied. Let me show the variation of this boost factor, gain, and the stress and duty ratio with respect to modulation index. The first diagram, we can see this variation of boost factor with respect to shoot-through duty ratio. We can observe from the diagram how the curve is smoothly increasing. This shows that by varying the shoot-through duty ratio of the inverter, the boost factor can be improved. So this is the variation of the voltage gain. The second diagram, variation of voltage gain is shown, and voltage stress. This is voltage stress across the switching devices. We can see it is getting reduced. Switching stress is getting reduced as that variation we can see, and this variation between modulation index and shoot-through duty ratio is shown. So the point is the input voltage in a single stage. I can boost up the voltage to the required level by adjusting this shoot-through duty ratio, which in turn will control the output voltage of the inverter. That is the point I am going to try to say. You can see this variation of AC voltage. I can vary it. The variation of AC voltage profile is shown, and you can observe the THD in the inverter, proposed inverter is very less than 5%. So surely I can use this inverter for any type of PV application. Here I am going to propose it for adjustable speed drive. These are the simulation parameters I have taken. I am going in for only, since it is a prototype model, I am going in for only 0.5 HP motor, induction motor, that is rated. So these are the parameters I am going to use it for a simulation. The simulation circuit, it represents the whole circuit, and finally the output of the inverter is taken and connected to the induction motor, right? And we can see that once the input of the induction motor is varied, we can achieve different speeds. So this is the simulation result. It is quite somewhat is not visible. I had used it for prototype model of 9 volt. So 9 volt. This is the three-phase output voltage I am getting of 30 volt. So it is showing three-phase output voltage with that of the current. The results showing the motor is able to run at 100 RPM for such simulation parameters. Likewise, I can vary the boost. Here I am fixing the boost factor to 2 For that, the motor is able to run at 100 RPM. Similarly, I can vary the boost ratio by adjusting this DS and get different set of rating. Yes, so I am finally conclude this modified diode assisted topology of cascaded quasi inverter will be best suited for any type of PV applications. Is these are the reference I had taken. Thank you. Yes, thank you, sir.
Thank you, ma'am, for presenting.
Yes, thank you, ma'am.
Participants, if you're having any queries, you can ask. Hello, participants. If you're having any queries, you can ask queries. Okay. Shall we go to the next paper?
Hello, can you hear me, please?
Yes, sir.
Yes. Madam, it has been very, in-depth designing technical point of it, no doubt. Definitely, we are in need of your help with regards to the new designs which are coming up and the power sector where we are using in onboard a ship. We will with the missionaries point of it and whatever existing on board a ship, we will discuss with you in depth later stages. We will take your contact number and we will speak to you and you can help us help
Yes,
our
sir.
cadets and ourselves a lot, madam. Thank you.
Thanks a lot, sir. Thanks a lot. Thanks a lot for the presentation you had given. I had given. Thanks a lot, sir.
Thank you.
Thank you, sir.
Shall we go to the next paper? Yes.
Yes, madam. Please
yes,
go.
Sir. Thank you, sir. Thank you, sir.
Gurukeshwaran is ready. Gurukeshwaran.
Yes, Shanti, suppose he's not ready, we'll call the next person.
Yeah.
And
Yes,
yeah, Mr. Stalin Kesavan, sir, is ready. So I would like to call upon ICDTMS 0204, study on utilization of waste heat recovery to improve efficiency of an engine by combined cycle approach. And Mr. Stalin Kesavan and Dr. Tanika Chalam and Dr. Elangelian, you can present the paper. Thank you. Sir, I think you are available. Yes,
yeah,
sir.
very good morning.
Good
Am I
morning.
audible?
Yeah, you're audible. You can
Yeah,
continue your
so-
presentation. Thank you, sir.
Yeah, so very good morning to one and all present here. Myself, Stalin Kesavan, and my co-authors are Dr. A. Tanika Salam sir and Dr. J. Ilacharian from Department of Mechanical Engineering. And this paper where we are just going to learn how the waste heat that is being put in an IC engine can be utilized for increasing the efficiency of the engine. So in this, the outline is we will be discussing about what is the total abstract of this project or proposal, and we'll be having the introduction, and we'll be discussing the various energy losses in an
So, hello. Hello. Mr. Kesavan.
Stalin sir, your voice is not audible.
So, Kumaravel sir, can you call him? And Stalin,
Stalin sir,
Stalin,
your voice is not audible.
Stalin sir, you are muted. Please unmute.
yeah. Am I audible, ma'am?
No, we can hear you, but it is not clear.
Sir, Stalin sir, your voice is breaking, sir. Not audible, sir.
1 second. Sir, am I audible, sir, now?
Yes, yes.
Yeah,
Yes, sir,
yeah.
you are audible. You can continue.
Yeah,
sir.
sorry, ma'am. So I have connected my Wi-Fi and laptop, so that's why because of the interruption of the call, it is getting disconnected.
Now also
Yeah,
it's saying,
sorry.
sir. It's creating echo, sir. So please find the problem.
Yeah, yeah. So is it audible now?
Yeah, it's clear now. You can proceed, sir.
Yeah, ma'am. So in the outline, I have given a brief introduction about what I'm going to do in this work. So I'm just going to model an engine, and I'm going to compare the various heat exchangers, and I'm going to find out which is the best suitable for recovering the heat, and that can be utilized for increasing the efficiency of the engine. So this is my abstract. So that is, we know that in any of the combustion engine, that is internal combustion engine, almost 70 to 80% of the energy that is being converted from chemical to mechanical energy is being wasted because of the various losses that we are going to discuss in the next slide. And in this project, we are going to use the waste heat that is recovered using the Rankine cycle, which is mostly useful in thermal power plants, and that we are going to utilize here, and we are going to take what are the various losses, and we are going to capture them in order to increase the efficiency. So for this, I have used the software called as Ricardo Wave software. So this software is a PLC based software where we can select the input parameters, and based on the working, we are going to get output, and the output can be utilized for doing the calculations. So this is the introduction. That is, in internal combustion engine, we know that the chemical energy of the fuel is being converted into thermal energy, and that thermal energy is used for running the engines. And we know that there are two different types of engines are available. One is spark ignition engine, which is called as petrol engine, and the another engine called as compression ignition engine, which is called as the diesel engines. So in this study, we have taken the ignition, that is the compression ignition engine, that is diesel engine we have taken, and the ratio of the compression will be from 15 to 25. So this is a compression ratio that is going to be available. So when we talk about the various losses in IC engines, so the fuel energy, which is 100% burnt in the internal combustion, we are going to have the losses in terms of exhaust as 33%, and because of the coolant, we are going to lose 29%, and from mechanical output, we are going to have 38% of losses. So totally, we can able to see almost 62% of the heat is lost because of the exhaust and cooling. So in this proposal, we are going to consider these two losses, and we are going to check whether these losses will be used.
Second track.
Ma'am, am I audible?
Selvarani ma'am, mute your mic.
Ma'am, am I audible?
Yes, sir, you're audible, sir. Continue. Sir.
Yeah. So that is in the exhaust and cooling, we are going to get almost 62% of the heat energy which is going to be lost. So in this proposal, we are going to utilize these losses, and we are going to calculate what is the efficiency that can be improved for having a very good output. So in this, the heat exchangers are the best uh, support for recovering the heat losses because of the coolant and because of the exhaust gases. So there are different types of heat exchangers are available. The basic principle of heat exchanger is when the heat which is lost because of the coolant and from the exhaust, they are going to be entering inside the inlet, and they will be passing through a tubes, and it will be exiting to the atmosphere, where the heat is going to be utilized here, And there are different types, like I said, it is parallel flow, counter flows, concurrent flows. Like that, we are having different type of heat exchangers, and the best suitable for this work is the cross flow heat exchangers. So where you can able to take an example of a car radiator. So if you see the car radiator, it is a plate type, and what happens is the air from the atmosphere get contact into the uh, heat exchanger, and that reduces the heat. So by that we are going to capture that. So here we are going to compare two types of heat exchanger. One is the shell and tube, which is in the colored one, which is the shell and tube heat exchanger, and another one is the plate type of heat exchanger, where we can able to see the plates are arranged in parallel, where we are going to have the tubes. With the tubes, we are going to allow the exhaust gases and coolant to pass through it. So because of this, we can able to utilize the heat that has been lost to the atmosphere. So the basic system where we can able to see, it is a Rankine cycle, where we are going to have the compressions, the isentropic expansion, heat rejection, all these things which are being explained here in this TS diagram, that is temperature and entropy plot. So using the Rankine cycle, we can able to see that this is a closed type of cycle. So we are not going to lose anything to the atmosphere, but we are going to continuously use it for our purpose. So this is the proposal where we can able to see we are having the IC engine, and in the IC engine, the major losses are due to the coolant, and another thing is because of the exhaust. So where we have studied, we have discussed in the previous slide about 39% is because of the exhaust gases, and 23% because of the coolant gases. So these are the two losses which are major encountered while converting the chemical energy of the fuel into mechanical work. So therefore, what we are going to do is we are going to use heat exchanger 1 and heat exchanger 2. And here we are going to use the heat exchanger of two types. One is the shell and tube, and another is the plate type. So we are just going to compare it. So here the major advantage of this is we are going to make use of the software Ricardo Wave software. So in this software, we do not have to make a real prototype, and we have to test it. So by using the software, we can modify the type of heat exchanger, and we can able to compare the best and the good heat exchanger for capturing the exhaust gases. So therefore here we can able to see the coolant hot fluid which is exiting, it is going to be allowed inside a heat exchanger, and once again the cold fluid it is going to be transferred inside the engine for cooling it. Another is the exhaust gas, which is going to be captured in the another heat exchanger, and the heat is going to be absorbed, and the cool exhaust gas is going to be sent to the atmosphere. So by this you can able to produce the global warming into a less effect, and that working fluid will once again be allowed inside the IC engine. So by this you can able to see that the exhaust gases and the coolant hotness which has been which has been exposed to the atmosphere will be captured here. So this is the concept of waste heat recovery. Why? Because in normal engine, these two waste hot gases are going to be allowed to the atmosphere. So that we are going to utilize here, and we are going to make our engine more efficient. So that I can prove it with an calculation also. So this is the proposed work. So here what we can able to observe is when the losses are being rejected to the atmosphere, the system is going to lose its 100% efficiency. We know that no IC engine can be 100% efficient. So there are 70 to 80% losses are sure. So that is the spark which ignited me to do the waste heat recovery. And so these are the things we have discussed. That is, we are going to recover the maximum heat, and here we are going to use the software called as Ricardo Wave software. in this software, it is like a PLC software, and this has model like we can do simulations and we can do flow 1D flow analysis, and also we can do some certain simulation. So this is student version is also available. So students, those who are interested in learning the CFD concept, so this software will be very useful, and trial versions are also available. And here the two uh, uh, hot gases and the exhaust gases that are going to be utilized here. So in this software, we can change the working fluid. So say for example, if I'm going to use a diesel or if I'm going to use a petrol, I can able to calculate what is the power that is going to be generated. But here I'm going to change the coolant as acetone, heavy water, normal water, toluene fluid, methanol, and acetone. So these are very common fluids which are useful for cooling the engines. So here in the because of the availability, I have checked the various results, and in this I can able to see that the heavy water is having better performance when compared to the other fluids. But the practical difficulty of the heavy water is at high temperature it is going to be unstable. So therefore, I am going to use the next fluid, which is the high performance fluid, which is nothing but the normal water. So the advantage of using water is in elevated temperature, this gets superheated steam. So that also going to be useful for capturing the heat. So this is the model I have done using the SolidWorks software. So this is a compression ignition engine, that is a diesel engine, and this is the plate type of heat exchanger, and this is a shell type of heat exchanger. So all these things I have modeled using the SolidWorks software, and the simulation is also done with the SolidWorks software. And this is a flow simulation. So that is, you can able to see that the transfer of heat rate in the plate type of heat exchanger is 0.412 kilowatt. So this is the amount of heat that is going to be transferred in the heat exchanger. And when we see the shell and tube, here we can able to see there is a almost 3 times higher transfer rate is found. So that is why I have selected the shell and tube. So calculation, I have calculated the brake thermal efficiency using the conventional model, that is the normal model. I could able to see that the brake thermal efficiency for the same parameters I have obtained around 13.2% as the brake thermal efficiency. This is the normal engine which I have modeled, and with the same amount of working load, I have observed that because of the waste heat recovery system, I have encountered 13.86% of the efficiency in the overall brake thermal efficiency. So therefore, the net brake thermal efficiency increase was calculated to be 5.03%. So it is almost a good amount of heat that is being utilized for increasing the brake thermal efficiency. So this is the proposal where we could able to see the losses that are encountered in the engine can be minimized by absorbing the heat that is being sent to the atmosphere. So in the conclusion, I would like to say that we can make use of the recorder wave software. This software, we can able to do analysis, simulations, and also CFD analysis. And here, by using the waste heat recovery model, we can able to see that the brake power is high because of the fact that is the expansion of the steam, reducing the work involved in the compression. Why? Because we know that for compression ignition engine, the compression ratio will be from 14.1 to 25.1. So that can be reduced by using a hot fluid. And also you can able to see that the brake thermal efficiency is increased by 5.03%. So it is a considerable amount of improvement in the brake thermal efficiency, which will increases the fuel efficiency of the internal engines. So with this, my presentation is over. If you have any queries, you can just ask me.
Thank you, sir, for your presentation. And participants, if you're having any queries, you can ask, sir.
Okay, student, this Ricardo software, where did you have? You have it at the college, please?
No, sir, the software is not available in the college, sir. So this is free trials are available in the net. We can download it by personally. And student versions also available, sir.
Okay, okay, thank you.
So the cracked version is also available. That also we can make use for doing the analysis. Instead of spending more amount on the software purchase, we can use the pirated version and we can do the analysis.
Okay. What is it? It calculates the area and all. What does it do?
Yes, sir. The area, everything will be given as a model. So here we can do the analysis, like what will be the input temperature and what will be the output temperature, that we can able to calculate it. And also we can able to see where the more heat concentration will be available and the flow of heat can be calculated accordingly.
Does it also give the graphical option?
Yes, sir. It is giving graphical option. So that I can show you here. So it will be in a graphical representation also, and also it is going to give simulation type of results. And here the models we don't have to model it. Why? Because it is a PLC based software. So if I want a piston, I can select the range of piston that is available and I can use it for the model. I can select the input tubes and what should be the diameter. If I give, the diameter will be changing according to that. So everything like pick and place only. So if we have to select an engine, so that type of engines will be available. We can select them, and what type of piston we need, that also we can select. Likewise, we can select the option, but the input parameters we have to give. So based on the input parameter, what we give, the output will be given by the software.
Okay, I think I'll stop here, and somebody is also having a question. We'll discuss this later on. Thank you.
Yeah, sir. Sure, sir.
I have one question. Is already already having the exhaust gas economizer. So the waste recovery is taking place in the economizer also, and we have a fresh water generator, which is also taking the heat of the and then producing water. So what is the benefit of this one over that one?
Sir, this will be a compact model, sir. The available economizer, the size will be very huge. So this is a compact model, and also, So why? Because here we are going to use this for the compression ignition engine, sir. And
yes, engine also compression engine only.
Yeah.
Okay.
Sir, this is basically a software to analysis what will be the efficiency and what will be the amount of heat that can be recovered. So we can able to calculate that. So using the software model.
Yes, sir. You are not considered the marine engineering, whatever existing system is there. Okay, no problem.
Yes, sir.
Okay.
Yes, sir. Yes, sir.
Yes. Thank you, sir.
You were not a marine engineering student? Oh, mechanical engineering. Okay.
Yes, sir. Mechanical engineering, sir.
Okay.
Shall I, sir? Stalin, sir?
Yes, ma'am.
Sir, Dr. V.L. Mangesh has one question for you, sir. He has asked from slide 8, what are the simulated temperature? He want to know from slide 8, what are the simulated temperature? Please answer him, sir.
So, yeah, the temperature is around 470 degrees, 470 kelvins.
Okay. Sir, Mangesh, sir, is it okay, sir, for you?
So, the operating temperature, what I have taken as an input is 470 Kelvin.
Okay, sir. Fine, sir. So, I think Dr. V.L. Mangesh, sir, is now satisfied with his answer. And then he is asking for temperatures of coolant also, sir. Now he has posted the question and he wants to know what are the temperatures of the coolant. You answer, please, sir.
Sir, both
Yes,
at,
ma'am. So
both at the inlet as well as the outlet,
Yeah.
sir. He's asking about coolant temperature.
So yes, sir. The coolant temperature at the inlet will be around 470 kelvins, and at the exit it is going to be around 320 or 310 kelvins. So we are not going to use 100% the temperature which is going to be existing out.
Sir, can you show the slide 8, sir? Can you put on the slide 8, sir? He's requesting. Yes, sir.
Mangesh sir, you ask questions, sir.
Yes, ma'am.
Thank you, sir. Thank you, sir. You have put it. So, Dr. Mangesh, sir, he has put the
Yes, sir. Can
slide
you
8.
tell me again what are the values of the coolant temperature? That diagram is looks like uniquely. So that's why I was asking only this diagram.
Yes, sir. So
What are the
here is
temperatures
an
encountered by the coolant, sir?
Yes, sir. So at the exit, the temperature will be around 470 Kelvin, sir. So
Okay,
in
sir.
here,
Sorry for interrupting. You said the coolant is water. Water, correct, sir?
Yes, sir. Yes, sir.
Can water withstand 400 degrees, sir?
No, that is what. So the water will be converting into superheated steam at that elevated temperature, sir.
Okay.
So that
And the steam,
I
what
can
you will,
show you here also, sir. So
what you are doing with steam, sir?
I think
Aspirants,
here I have shown.
sorry to interrupt. How many more participants we have?
Nearly 8 members is available, ma'am.
Eight more members to complete the
Okay,
session.
sir. If time
No,
is running
ma'am.
out, we can
Afternoon
go to
you
the
have
next.
to
No,
join.
for this
No
session.
issues.
So you can talk, see, please. You can talk
Yes.
in the mobile.
Yes, ma'am. If
Please.
time is over, we can go.
Sir, yes.
So what time
Yes, sir,
this
yes, sir.
session will conclude, man? What time we break for lunch?
1 o'clock, sir. 1 o'clock.
No issues, ma'am. If time is up, we can go to the next session.
Already time is 1 o'clock, no?
Yes, we can go
Yes,
for lunch.
sir.
We can-
Yes, sir. Yes, sir.
Participants are requested to post their queries in the chat box.
Madam, we can wind up the morning session now for the lunch break. Okay. So we'll resume by 1:30. So those who are not completed the presentation during the first track, let them continue their presentation in the afternoon along with the second track.
So participants, we thank you for participating in our conference and presenting the papers. So we request you to join in the track 2 and track 3, which will be available in afternoon session, and the afternoon session starts by 1:45. Thank you all.
Thank you.
And also there is a request, kindly post your queries in the chat box, and participants will be given only 10 minutes to present and 5 minutes for the questionnaire. Please stick on to the timing. It's a request.
And also we request all the participants to put that if you are ready, kindly put that you are ready and your ID, that is ICDTMS, along with your ID, paper ID, please put that you are ready to present the paper, so that we will be able to call upon you and add in the panel list. So you will be able to present one by one. Okay, thank you.
Afternoon track 2 and track 3, good? Link? Zoom link?
Ma'am, sir, for track 2, you will be given with the Google Meet, sir. And track 3, it will be the same Zoom link, sir.
Same Zoom link.
Okay.
Sir, is it possible to have all the participants, whatever the paper, the number, ID number in one, so that, hello?
Yes, sir.
Yes, sir. Tell me, sir.
Is it possible to have the paper ID of everything? So
Yes, sir.
that,
Track schedule is there. We will be sending it to you, sir.
yeah, thanks.
Thank you, sir.
So track 2 will be in one link and track 3 will be in another link, sir.
Oh.
Okay, thank you, ma'am.
Track 2
Thank you, sir.
technology and weather forecasting. Track 3 is smart technology.
Okay, okay.
But keynote will be done in Zoom because the number of participants are more.
Oh.
Keynote will be done only in Zoom. Okay, ma'am.
Yes, ma'am. Yes, ma'am. Initially, they have to join in Zoom, ma'am.
Okay. Thank you, ma'am. Thank you all. Let us
Yes,
join
ma'am.
by
Thank you, ma'am. Thank you.
1:30 itself, because the session will start by 1:45, right?
Yes, ma'am. Yes, ma'am. We'll be there.
Thank you all. Thank you.
I would request, I would request all the participants to join the same Zoom link by 1:30.
Yeah.
So as to start with the next sessions.
Then we will be going to the link, different link, Google link for other, especially for other tracks. Thank you.
My dear colleagues, team members, kindly be available in the Zoom platform.
Yes, ma'am. I'm here, ma'am.
Yes, sir.
Is my voice audible, ma'am?
Yes, yes, ma'am. System manager, you please add Dr. Irak as panelist so that he can present his keynote.
Yes, ma'am.
I hope I won't find Alex sir in the meeting at all. He's not in the attendees list.
Alex sir is available here. Suresh, sir.
So once he comes to the attendees list, I'll just make him to be the panelist.
Sir, you please inform your students to join because we are going to start by 1:45.
Yes, ma'am.
Maybe you can send either by WhatsApp or by some communication. You please inform them.
Good afternoon.
Yes, ma'am. Welcome back. Welcome, Dr. Irak. Welcome the guest.
Sir, welcome, sir.
Welcome, sir. Welcome to all. Welcome, madam.
Welcome, sir. So the keynote speaker has joined, and yes, the screen is
Yes,
visible.
madam. Yes, ma'am.
Good afternoon to all.
Good afternoon, sir.
Yes, good afternoon. Yes.
Should we start with the address of Dr. Arik, sir?
Okay. So thank you very much once again for the invitation to participate and give the keynote address during the conference. And I am represent the Gdynia Maritime University in Poland. And in general, I am active in research in artificial intelligence and implementation of different tools. This kind of tools in different area, and especially also I very often think in my research about the marine shipping and offshore means, because it is the domain of my universities. So it is the nature that we very often work on the problem from this domain. But what we have now, yes, we have now such situation that when we look on the world and we observe a general progress and direction in new technology innovation, and this direction means that we have a new industry. It is the industry 4.0. And this industry 4.0 have a very close connection to artificial intelligence. Artificial intelligence, what means a general artificial intelligence? Because when I look the definition of artificial intelligence, we can find different definitions, and we can collect a big set of different definitions of artificial intelligence. But in my opinion, and we could go to the such definition that we have define as weak and strong artificial intelligence. Weak and artificial intelligence. Weak means that we can, in general, produce new equipments which can replace a human in one selected things. And it is true, yes, and we can at the moment find a different examples such situation. But strong artificial intelligence means that we in future can prepare such equipment or equipments which replace a human in all activities. And of course, we can now formulate the questions. Each definition is more true and more real. Of course, when we look on the time, on past time, we can observe how the equipment, the different equipments increase your possibilities and get more intelligence. Of course, we can now find a different area of implementation of artificial intelligence. Of course, we can find example in financial, social media, in education, e-commerce, very strong, and in transportation, in shipping, and in general, in area where we produce and prepare a robotics, it is the one main area. But I think that the robotics, I think that we should also think that the robotic is not the equipment with the human skills, but it is a general equipment. We have a rich possibility to do different things and replace the human, maybe not more advanced, not one activities, but 2, 4, 3, but all, I don't know at the moment. In general, when we look on the artificial intelligence, yes, we can, from perspective of the theory, and we can thinking about different problems which are too ready to solve. From problem of learning, prediction, planning, language preprocessing, when we are generally looking for a way to knowledge representation, and where we generally looking for tools for problem solving. Because when we would like to produce and implement artificial intelligence to replace a human in our activities, so means that we try to solve very difficult problems. In more cases, there are optimization problems. Of course, we have, in thinking about such direction, we can find dedicated and with good background, different tools and algorithms. Yes, when I think about the optimization, we have a rich set of different population-based algorithms which emulate the live processes to solve difficult problems. We can also implement thinking processes, and we can also implement the tools to work with a different situation, not sharp. I'm thinking about the fuzzy logic, yes. We, with the tools of artificial intelligence, we can find such algorithms which can learn the problem which is behind or before the equipment before us. I'm thinking about the machine learning methods. Machine learning methods, in my opinion, it is the core today's artificial intelligence, because this algorithm, machine learning algorithm, are such possibility to learn and to prepare good generalization in a given domain. By this generalization, the final equipments based on the machine learning methods can replace the people, the human in these mentioned activities. Of course, different also category of machine learning tools we can find, because I'm thinking about the artificial neural network now, because it is also the tool belong to artificial intelligence tool, belong to machine learning set. Yes, and artificial neural network is also the core for deep learning. Yes, and so means that we now have relatively good, maybe not big set, very strong methods and algorithms to prepare artificial equipment, artificial activities implemented between different things in different areas. And when we thinking about this implementation, now we very often can think about cyber physical systems, because this cyber physical system cannot exist without artificial intelligence. In my opinion, the cyber physical system, it is this system which have the artificial skills based on machine learning algorithm, where this machine learning algorithm process a big set of different data, which include the information about the domain where we would like to use our equipments. And this, of course, cyber physical system can communicate with different others, so have a good interfaces, cyber interfaces. And I'm thinking now of technology which this communication assure. This, of course, interface assure communication in two ways, yes, between the environment and the system, the equipments, and in other direction. And such cyber physical system can some self-modify, can some self-improve your skills and potential, yes, to work with different areas. So means that such systems are intelligence. Of course, the cyber physical system based on artificial intelligence, it can be a small box, yes, with this communication, with this possibility to control, and with the possibility to competition, and with different others. So I think also now about the communication between the different equipments. So means that the equipments can formulate and can prepare the network of equipments, and which communicate, which change the information, which cooperate with the one common aim. So means that artificial intelligence with the physical system, cyber physical system, are now based on the good protocols to communication, and are very often under umbrella new technology called the cloud computing technology. Yes, so means that we have a relatively a big set of different, very new, modern, and strong technology to prepare a very strong possibility to industry new age. Yes, and it is the background to transformation of the industries, yes, and to looking for innovation, yes, and where we have such a new direction in the industry, yes, we have not only to mechanisms which increase the power of the system, where we don't have a possibility to massive production. It is not only the automation by the computer programs, but it is a lot of autonomous this equipment. So means that we have industry 4.0, and it is direction. And this slide shows a general changing, yes, from perspective of a big set of different kind of the instrument approaches, yes, to industry. And we can, and when we see the first step in the industry 1.0 to industry 4.0, and it is today's situation. And of course, this industry so means that they are very strong and they are very autonomous. And this equipment must be very safety, and so means that must be under umbrella of the good security. because when we're thinking about the autonomous, so means that this equipment must be very isolate, yes, from different activities with aim to destruction. And this autonomous system now can, as I mentioned, communicate with other. It is the cloud computing, and based on the good protocols, I'm thinking about the Internet of Things. And of course, without of the data analytics, we don't have such a strong system. So means that the one challenge is also the such new technology and Industry 4.0 must base on the data analytics and define by view of big data now. And okay, so what it means that the in general, the autonomy in the contemporary industry and technological discourse relates to machines and their operations. But what is also the core of the definition? That this operation is independent on the human intervention and decision. It is the autonomy, and it means that we can return to the definition which are mentioned before, to the definition on the strong artificial intelligence. So I think that it is this direction. Okay. I would like to also underline that the Industry 4.0, it is not only the technological aspect, because when we thinking about the autonomy, when the machines, equipments can operate independently of human intervention and the decision. So it is also the question about the social aspects. Of course, I don't know, would like to now discuss a general social aspect. The aspect what human can do if the human is maybe in difficult situation. But I rather in my presentation go to aspect social, but more in context of economy. So means because the direction for 4.0.1 and direction to finding the autonomy in machine equipment, it is this direction when we would like to increase the general progress in domain of new technology, yes, because it is the one main aim of general activities in domain of industry. And what I would like to now underline that the Industry 4.0 it is a general trend. Yes, it is a general trend, and we can now find when we look on the worldwide a different and big set of different initiatives. It is the regional initiative. It is the government initiative directed in the Industry 4.0. Directed into support all activities which can bring a new technology and innovation. And this slide show, for example, European activities. Yes, for example, the high-tech strategy 2020, it is the strategy, German strategy, yes? It is the strategy how prepare a new innovation for Industry 4.0. Of course, in the Europe, we can find more such initiative. It is the Industry 4.0, it is UK initiative. And we can look on the USA, it is also the different initiation, and the one mine, it is the Smart Manufacturing Leadership Coalition. It is an organization which, from the point of view of organization, preparing the law, etc., and preparing the money, etc., to increase the industry. Yes, industry increase of the Industry 4.0. Of course, on the side of different side, we have a different initiative. Japan, South Korea. It is also only a selected initiative, but I believe and I know that not all countries are very strong underlying this direction. But believe me, and maybe it is only my opinion, that the direction and the needs to work in direction of Industry 4.0, it is the important direction which must be supported by government. And in Polish, we have also as such innovative resolutions, and we have, for example, it is the Future Industry Platform Foundation. Yes, it is the government foundation which looking for the money, which have a work to prepare a good law, and which a general support different area, from the industry to education, will increase their possibility to prepare a new technology, to work with new technology, and to increase the level of the industry to the very autonomous and this industry which we now discuss on is the Industry 4.0. And as I mentioned before, because the Industry 4.0, it cannot be independent considered without the artificial intelligence. In Polish, we have independent initiative, yes, for increase the work with the artificial intelligence. So it is the special strategy prepared and with the name, yes, the artificial intelligence, Polish, 2280. So it is the strategy to industry revolution in Poland. We have to support this initiative. We have also the it is like the platform for development of artificial intelligence, and the platform integrate all universities in Polish to cooperate, to work in direction to new technology, and of course with the core, which is the artificial intelligence. It is the name in the Polish, yes, nomenclature. But why I would like to underline that from the perspective on what it is the needed. Of course, in each country now have a such initiative, yes. But when we look on only on the shipping, maritime shipping or maritime ecosystem, we can find at the moment now also different examples where the artificial intelligence exists. As I looked before in one presentation before mine, I also see very common slides, yes, but this slide shows the autonomous ship, so means that we can prepare the road independent on the human action, and we can prepare now the system where the system is very autonomous and independent of the human and can decide about the routing. And so we have a different example of the system. But the question is, how level can be this autonomous? Of course, we can now looking for a different area, domain of the shipping, yes, and the in shipping marines. I think that this area is very huge because we can find a different possibility to implement artificial intelligence, cyber physical system, this autonomous systems on the land. Yes, and in these places where on the land we have a very short connection to the shipping on marine, and we can have a very big and different example on the board when the artificial intelligence is or can be implemented. And we can, of course, now very often discuss this in domain of smart operation, smart machines, smart equipments. In general, I think that the slide showed this. It is the smart operation, smart manufacturing, and smart design, and it is the connection relation between this operation where each one is intelligence from smart design when we prepare, where we design equipments, when we design softwares, when we design general how different things can be do in the smart domain. And of course, then we prepare the smart system and we can have the operation, smart operation. And it is the underline that because we now need the level, which is a very important data analysis. Okay, and so means that we now in different area of the shipping can find different example when the artificial intelligence, physical cyber systems can be and must be and can be implemented. And of course, we can now find different real examples. Of course, maybe autonomous ship, which is very often mentioned by the Rolls-Royce. It is a very, very autonomous system based on very strong intelligence technologies. But I think, in my opinion, it is a real direction. Question only is about the time when such very autonomous intelligence based on intelligence technology system can be run in complete. And of course, only the selected parts or part of the Rolls-Royce shipping intelligence we can find in implementation, and we can find a different system for example, for docking. Yes, it is the Norwegian system, intelligence system, without using the human activities. Or it is system very, very intelligent. We can, of course, find a different system to optimization, the routing, and also to optimization, for example, pollution reduction and generate to prediction of risk of collision, yes, to eliminate the risk. And example of such system when we have a lot of autonomous units. It is the system in Port Rotterdam, where we have very intelligent system to analyze the routing ship in port. And different other, it is on the land, on the port, yes. And in my university now we also work on a different system. And for example, maybe the second one, the ship route prediction system for changing water condition. It's also very interesting, the direction, yes. How to predict the route, yes, where we have the changing the water condition. It is our project, which we have together with the University of Lisbon, and with the one of the Poland University and one of the commission company. And the final, the project on the finish can have the prototype of such system to work to analyze the weather condition. Our autonomous vessel with the air look is also very interesting. Our project. What is the main core of the system? When we have the autonomous ship, and we need the system which will be very strong to analyze what is in the sea. Yes, so it is the special system with the autonomous aircraft which can support the autonomous vessels. Yes, and to inform the vessel about the different situation can be happen in on the sea. My last project, it is a project dedicated to data package prediction in the satellite automatic identification system, because IS, it is a land-based system, but when we all time looking for a good, very strong satellite IS system. And the satellite IS system have one problem, because lost a lot of packages from the vessels, and so means that the data on the satellite component are not complete, and the satellite component cannot regularly send the information to all other vessels. Okay. Of course, I could show different examples of different systems, but I would like to underline where is the benefits of the fourth industrial revolution in shipping. Of course, the beneficiaries are in domain of ship owners and ship managers and manufacturing, but also from perspective economy, business, but also with respect to nature environment, and the beneficial is also in domain education. And when we look pointedly, yes, in this beneficial, and we should very important thinking about the IT managers and the data managers. Yes, and I think that this part of activities is very important, very important. And I think, in my opinion, it is a very close with the education and teachers, because, in my opinion, we have all time with the problem with the process of education from perspective of the industry 4.0. because it is a general a new industry, and we need a new skills. Of course, from the engineering point of view, but also important is also good thinking and thinking about the new possibilities and this industry by the managers and all chain, from the managers, producers, engineers to ship owners. So it is rather the end of my presentation, but I now would like to underline the challenges. Yes, and one challenge is from perspective of the education and training, as I mentioned before. Yes, and especially when you're thinking about the marine, and it is the marine industry, a new direction. Yes, and I think that this is well underlined in Global Maritime Professional Body of Knowledge 2019, joint project of the Nippon Foundation and the International Association of Marine University. Yes, has been approved by IMO in 2019. So I think that it is the one challenges, and in domain of education, without the thinking about the Industry 4.0, we cannot run a new technology, new shipping. And I have also the selected questions for all. Maybe this is open questions. What is your awareness of the complexity of AI technology? Is a marine education system prepared for challenges of Industry 4.0 in shipping? Is the intelligence shipping industry a challenge, opportunity, all that? Thank you very much for attention, and it is last slide of my presentation. Thank you very much.
Thank you, sir. That was a very informative talk. And I'm sure that students have benefited, and they would have got an insight about what is Industry 4.0 is all about and how well they need to prepare for the future. Now, moving on to track 3, it's on smart technology. And I would like to give an introduction about the speaker today. For track 3, smart technology. Today, the speaker for the track 3 is Dr. Mohammed Awas from Edge Hill University, UK. So we are extremely glad and overwhelmed to introduce you to the gathering. And I also welcome you to the track, sir. Mohammed Awas is a senior lecturer at the Department of Computer Science, Edge Hill University, UK. He has been deeply involved in research works on data mining, the Internet of Things, 5G, 6G communication technologies, Industry 4.0, data analytics, signal processing, application-based machine learning, and deep learning for more than 10 years to develop ICT-based systems for remote sensing, digital health, and Industry 4.0. He received his undergraduate degree from Muhammad Ali Jinnah University, Pakistan. He received MS degree in Electrical and Electronics Engineering from University Technology, Petronas, Malaysia, and PhD in Biomedical Electrical and System Engineering from the University of Bologna, Italy. He previously worked as a research fellow at the University of Hull, UK, the University of Leeds, UK, and the University of Bologna, Italy. He is a member of Institute of Electrical and Electronics Engineering, IEEE, and the IEEE Engineering in Medicine and Biology Society, EMBS, and the British Computer Society, BCS. Now, I call upon the keynote speaker to address the gathering. Sir, please, sir.
Ma'am, whether sir has joined?
Hello.
Yes, sir has joined. Sir has joined.
Hello, and good afternoon for those who are in India and for those in UK, or otherwise good morning. First of all, thank you very much for the invitation. And I'm going to share my screen and then I will continue through my talk.
Madam, sir is waiting for sharing of the screen.
So,
yeah, you can share, sir.
Okay, sure. So, can you see my screen now?
Yes, we can see it, sir.
Okay, thank you very much. First of all, thanks for the organizers and respective members for giving me this opportunity. My talk is basically around smart technologies, and within the smart technologies, I will focus on the health side of the technology. I will cover some aspects of how it is used in industry and also how we can use smart technology in environmental sciences and for the betterment of the society. So please let me know if you can see everything so I can continue. And can you hear me well? Okay.
Yes, sir.
Perfect. So, I've been working in the domain of smart technologies, and mainly it is focusing on digital and smart health, as well as using artificial intelligence and to develop smart processes and smart devices for the industry. So I'm a senior lecturer in Agile University at the Department of Computer Science, while my background studies, they are from electrical and electronic engineering. So I've been working in a variety of different domains. Some are related to the computer science, some are to the engineering. So as you know that it is a growing field and there are a lot of mutual interest and domain areas where we can be strengthened together instead of working on isolated domains. So what is smart? Smart word is originated from self-monitoring, analysis, and reporting technologies. So the important components are self-monitoring. So what you do is you try to make the system automated so it can monitor itself, it can analyze itself, and then it can report. So giving you some examples, smart technologies, they are used in a variety of different domains. And for example, in smart agriculture, you can use it for soil monitoring, you can use it for precipitation monitoring, how much rain is there. You can use a sensor, a technology to monitor that. Smart home, so you can have a lot of sensors. Those are deployed within your house. Those are called ambient sensors. So what you can do is you can monitor the temperature, the movement of the people inside the house, and also you can use it for energy efficiency purposes. For example, if you are not using some areas of the house, so you can try to reduce energy usage in that. And there are so many other ways for fire detection, for theft, and a lot. Similarly, for education, we have, the mean that we are using now is also smart technology, using the communication, using the Zoom. This is also a way of we are trying to communicate each other. You can use it for education for a lot of different purposes, and the list is ever growing. So this means that there is a huge potential of using smart technologies, and this can be used. For example, even in the case of COVID, unfortunately, throughout the globe, all of us, we suffered from this pandemic, and we have felt the essence of using smart technologies in health. For example, for contact tracing, you have used for drug delivery, you have used it for example, for detection of COVID. Just giving you a very recent example in which we use chest X-rays and other simple. So all of these, you use technologies to automate and to have that functionality. Similarly, smart mobility. So we have the concept of smart transportation, in which the vehicles not only communicate with each other, but they also try to efficiently utilize the resources that are, for example, fuel efficiency, communications. If there is any congestion on one road, so one can try to utilize the other route rather than using that route which is congested. So there are so many application areas. However, in my presentation, I will be mainly focused on some of the domain areas. Before going into the detail, we need to first understand what are the types of different smart technologies. So we have got smart devices, whether they are home appliances, where they are smartphones, gadgets, or any different type of sensors or devices that can do smart decisions. There are mainly three main components. Of course, one can divide this into different categories, but I have divided in a way that the main components, we have smart devices and then Internet of Things. So what Internet of Things is, Internet of Things provide you connectivity and it connect all these devices. So the idea is that, for example, when we are using a smartphone, a smart watch, or any sensor that is, no matter if it is deployed within our house or it is deployed in an industry. So for example, in an industry where you have mechanical sensors, pressure sensors, other sensors, those are connected through a Wi-Fi, a cellular network with the internet. That is called Internet of Things, everything that is connected and processed. So what will we do from this? So when we analyze the data, for example, you have a temperature sensor that is placed in a production room or in a manufacturing room, and you would like to monitor the temperature. So you have that device. What you need is you need to save the data of the temperature that you are acquiring from, and then what else you need? You need to process that data, and you need to connect that data by means of storing. So we need to store that data. So the idea is that normally now cloud computing and cloud services are used. Let's say the smart device is our temperature sensor, and that is connected through Internet of Things. So Internet of Things is providing, is every device that is connected with the internet is Internet of Things. And let's say the device is connected through a Wi-Fi connectivity means. It can be anything. It can be cellular. It can be your network provider SIM. And then you have the cloud, where you are not only storing the data, but you are also processing the data. And you are trying to, because remember what we said is that this is about smart monitoring, analysis, and reporting. So when we are monitoring, we took the data, then we are performing the analysis using artificial intelligence and cloud computing, and then we are reporting back and saying if the temperature is normal or if there is any abnormality occurred. So in this way, whichever is the procedure, most of the devices, they will be collecting the data, monitoring and analyzing the data, and then reporting back if there are any discrepancies or if there are any abnormalities occurred. And if the process is smooth, so these will trying to monitor for continuous period. And the aim of such is to assist or to, how to say, improve quality of life. And no matter if you are talking about personal life, smart health, we are talking about smart health or other applications, or in terms of the industrial applications. So we know that after the industrial revolution 4, everything is going towards automation. But I will not go into that detail because that is beyond the scope, and I don't have that much time, to be honest, that is allocated to go into that. But the idea is that all these smart devices, they are providing you facility. They are in fact facilitating you to expedite the processes and to make all the processes automated. Then we have the application domain, that's those I will be focusing during this presentation. These are industry, some aspects of environments and healthcare system. And of course, more technologies, they are used in academia as well. I will give you one example of academia that is related to the COVID and how we can use technology for the better better delivery of education. So in healthcare, what happens is that you have got a lot of different sensors, no matter these are mobile sensors which participants are using, or these are in hospital sensors, or for example, your MRI machines. So what you do is you have these all are connected through Internet of Things, and you have cloud server and machine intelligence. That is, this can be together, this can be isolated as well, as I shown in the previous slide. But the idea is that these are the main components of a smart system and with respect to the healthcare. So I will show you, I'll give you first example of smart healthcare, and this is related to the education. So as we know, during the COVID, we all shifted to online learning, and what one of the main issue was that we were emotionally stressed, and there are a lot of students who try to take a break for a while, because not only the academics from the staff, but also the students, everything is just shifted, and then there is a strong paradigm shift from face-to-face learning to online. So students were stressed. So the idea was how you can use technology and how you can make it smart, so you can access the stress levels of the students, and you can say that in which stress level they are, and then as a result, you can inform not only the educational organizations, but also the healthcare infrastructure to make informed decisions. So it means that, for example, if a student is stressed, so what you can do is you can request the student to consult with the healthcare staff, or to consult with the educational staff, so that they can recover from that. So what we used was we used different type of smart devices, and we try to monitor the stress levels. So how we have monitored the stress level? We have used wristwatches, and this is just to give you, this is a proof of concept. So we have used a publicly available data set, and that was used for similar purposes. So what we did is we try to present a paradigm in which you can use wearable sensors, and you can monitor the stress level of students, those who are taking online classes or participating in a variety of different activities. So once you are monitoring their body vitals, I will show you what kind of different sensors was used to build this. Then these are connected through Wi-Fi or through as IoT as a connectivity measure, and then you have the IoT hub. So these all devices, they send data to the cloud server via this IoT hub, and then all the processing, all the artificial intelligence is performed on this cloud server, and then this is connected to the educational institutes and online teaching, as well as to the healthcare server. So, and healthcare services. So for example, if students are stressed, or they are feeling, unhappy, or they have anxiety, and so the educational institutes as well as the healthcare, they can monitor their levels and take immediate actions to reduce the levels or to improve the general health of the student. So what we did was, the data that we have taken, it contains a variety of different sensors. So we have EMG, GSR, respiration sensors, and other sensors. So we analyze these data using artificial intelligence, and in particular we have used LSTM, which is long short-term memory, one type of deep learning algorithms that is widely used in the domain for such data sets where we have more kind of data that is collected across time. So when I say time, when the student is attending the classes, so it's wearing the wearable device, and then you can monitor the vitals. So the classes that we have used are different categories of classes that we use to classify was amusing, boring, relaxing, or scary. So the idea was, if student is relaxing and in a good mood, or it is amusing, those are the positive effects, while other can be boredom. So student is bored or feeling scary or any kind of relevant thoughts. So we try to use different senses we have used, and we try to see how we can classify their emotions. When we use three senses, we notice that although we are achieving performance of about 70%, so it means that how accurate you can go. So this is 100%. And what we found that if you are using a combination 2, C2 is combination, C3 or C4, any of this combination, you can detect human emotions up to 90%, which is quite good. And this suggests that the proposed system can be used to monitor the human emotions, especially in a stressed environment. Originally, our focus was on distance learning, but this can be used on a variety of different purposes, and also this can be used for different applications. Another such application was using artificial intelligence to diagnose and monitor Alzheimer's disease. What we know is that although the later stages of Alzheimer's disease, they are incurable because the disease really affects the human brains and the normal activities. However, if we are able to detect the patient in early stages, then physical activity every day can provide them a mean of improving their health. So one thing is quite sure, that there is no cure for the Alzheimer's disease, but what you can do is you can delay the onset of disease or the severity of that disease if you try to have more physical activity incorporated. So here again, the concept is we are using the devices, we have the data accumulation, then we perform different type of data analytics schemes. I will not go into the details, but just to give you an idea, so you have the motion sensors and you have accelerometers and gyroscopes. So you use them to on different body locations, for example, wrist, as you can see here, chest, lower back, and thigh or shank. And once you collect the data, you analyze these patterns and try to inform the healthcare infrastructure how active this person is. So for example, are they sedentary? They are mostly sitting or standing or lying, or they are doing other activities like walking or jogging or other activities. Even if not jogging, still if they are walking, these activity patterns are quite helpful. And in this way, this is a system that will continuously update the healthcare staff. So how this is related to the Alzheimer's then? So we have analyzed the MRI images, and we know that in the MRI images, there is a gray matter and a white matter, and the distribution of these matters changes when a person is suffering from Alzheimer's. So in your brain, when the images are collected, these are your the gray matter and white matter. Its distribution, in fact, changes, and then you can use this to detect or to categorize if the person is having Alzheimer's or it is developing this disease. We used this is a complex architecture. We used a convolution neural network as artificial intelligence techniques. So we get the images. We use AlexNet, which is quite famous machine learning algorithm, convolution neural network. We trained the model using transfer learning, and then we have categorized that how you can diagnose and monitor Alzheimer's disease. So our method gives us performance of about 95%, which suggests that we can detect the Alzheimer's disease. It's important to note that the data sets that we have used, they were from publicly available. Why? Because in real life, it's going to be a very long study where you can have about 10 or 10 to 20 years of monitoring, where you are monitoring the onset of disease, and you have patients, and then you are continuously taking their images and monitoring their physical activity. And then eventually, so this is more of a proof of a concept in which we propose that you can use accelerometers and gyroscope, the motion sensors, to track the activity. And what will happen is, if you are active and if you are not having a sedentary lifestyle, then you can delay the onset of the disease. Another such examples was related to transportations as well as healthcare. So this was a project when I was in University of Leeds, and it was in collaboration with one of our partner institute in Singapore. So the idea is that how you can motivate people to cycle. The idea is that our the atmosphere of especially Asia, like Malaysia, Singapore, India, Pakistan, and other countries surrounding, it's quite hot. And how we can motivate people to cycle, and how we can make it more immersive. And is there any difference when we try to, see a stimuli or a video or image, and what happens if you use a virtual reality? As you know, the virtual reality or 3D is quite common nowadays to train the people, no matter if they are educational training, surgical trainings, or let's say you can go for other trainings. People are using it for police training, military training. So the idea is you have got all the videos and all those scenarios already built, and the participants, they try to learn from those experiences. Why? I will show you why 3D or virtual reality is so common and why not 2D. So what happened is, we have non-immersive and immersive. So this is a 2D scenario and this is a 3D scenario. Of course, from here, on the slides, it looks like both are same, but in the actual, we have given, in one case, the participant was looking at the screen, and then it was a 2D video, and then they were cycling on as shown in the picture. So it was an instrumented bicycle provided by FCL Singapore. And then we had a 3D images and 3D virtual reality, in which the participants, they were doing the same, but they were wearing this virtual reality device. So the idea was how your brain is processing when you are in a 2D environment, and when you are in a 3D or virtual environment. As we know that in virtual in 3D environment, which is much closer to the real life situation rather than a 2D where you are looking at the picture. So how your brain is processing. The main project was you use the brain signal, and we use as a electroencephalogram or a brain imaging device, and we try to analyze how your brain is processing. So what happens is we have seen that when you are in a non-immersive environment, when we say non-immersive, this is a 2D environment, which is not immersive, and your brain is processing less. So this is an alpha power. So this power comes from the occipital side of the brain or the back side of the brain. And when we are sleeping, our alpha power is quite high. So for example, when we are sleeping or when we are drowsy, the alpha power is high. And now when we are awake and we are performing different activities, our brain alpha power is gets lower. It means that we are active. So what we found that in our experiments as well, when you try to, how to say, train the participants in a non-immersive or a 2D environment, you are having a high alpha power, which means that you are having low activity or you are less attentive, while in 3D you are more attentive. A similar kind of experiment, I will quickly just give you an idea. This was again using a brain sensor, and this was used for surgical trainings. As we know that surgeons, they got experience from years in practices, and then they learn. But the idea is now the technology, this is used in surgery as well. So you have the similar kind of environment here when the participant is wearing a device and using the virtual reality, and then you have the surgeon need to extract this brown part. It means that imagine when you are going for a tooth extraction. So when a teeth extraction, so whenever you go to the surgery and go for the teeth extraction, doctor will only have to take out one teeth or the affected area. And the idea is that if you can get that training using the virtual reality environment, then this will save a lot of cost, and also this will provide you experience, which conventionally doctors get in say 20 to 30 years of practice. So this is very important that we can use virtual reality for such purposes. Excuse me. So the idea was how your brain is processing, and what we did was we have students from first year of dentistry, and we have students from 5th year of dentistry, and this experiment was done in University of Leeds. So we try to see that how students are performing and how their brain is performing when they are experienced and when they are naive or less experienced. So we have two categories, experienced and less experienced. You can call this noiced or experienced. In a similar way, what we found is that when you are talking about the behavioral errors, then these were quite low in the experienced staff. So when they were trying to extract this brown matter and from this, and these are the different signs that we have used just to provide more complexity. So they were having less trouble, or since they were more experienced, so they were having less errors when compared to the novice. So these both are novice, and the red one is this complex task, while the blue one is the other task. And which means that the experience they were able to perform this without having much errors when compared to the novice or the less experienced surgeons or students as they were in their surgery program. And then frontal theta power. Again, when your brain is processing much, in the earlier slide, we were talking about the alpha power of the brain. Here we are talking about the frontal theta. So frontal theta is from the front side when you put sensors here, because this is more about your processing, how you process. So this suggests that the novice surgeons, they were processing much. So just imagine that when you start driving first time in your life, so it means that you are really taking a lot of pressure and you are quite attentive. I mean, in any case, you try to be attentive, but you are less experienced. It means your brain needs to process more for you to learn. And then after, let's say, years of driving, you are performing the same task, so your brain is less engaged. It means you know how to drive, you are more experienced. And so this suggests that we can use the virtual reality, and as well as we can use the brain signals to find the level of experience in stock. I will just quickly go through. This is a project that I did in University of Bologna during my PhD and with NTNU Norway. So this was a project to classify the activities of elderly. As we know that elderly, they are having a lot of functional disorders and movement disorders in later stages. So what you can do is you can monitor their activities, and the more active they are, the less sedentary or muscular problem they are having. So we use a lot of different sensors, and this was more of a exploratory analysis. What we did was we put the sensors, and then all those elderly people, so they were about above 70 years of age, and once we have mounted the sensors, they went to their homes and they performed their normal life activities. What we did was we also used cameras, although there are privacy concerns, but the camera was just used to see how accurate we are performing. And when I say how accurate, we use accelerometers and gyroscopes to record the data, and then we applied artificial intelligence to detect if they are performing sitting activities, lying activities, standing, and other activities, and for how long they are performing such activities. And the camera is just used to, in data analytics or in smart intelligence, you should have a ground truth or a validation measure that can cross-check or cross-validate your sensor. So for example, I say that my sensor is classifying sitting or categorizing sitting up to 90%. So this means that I'm giving out of 100 episodes of walking. When I walked, my sensors provided me 90 times the accurate information. But how I'm going to cross check? I should have a ground truth or a validation measure. So in that case, we use cameras to capture that. And then we eventually we ended up using one sensor, which is at lower back. So what we found is that you can use only one sensor and you can perform up to 80% of accuracies or performance. This is quite significant. For example, everyone has got a smartphone. So we have got a smartphone and we can use that for activities, especially for elderly. They can use their smartphone no matter where they are putting the smartphone, their upper pocket, lower pocket, or they are keeping it in their hands. Still, we can use such sensors. And in a similar project I used, it was a European project, Prevent It. So the idea was that how you can accurately measure the activities, and because the lack of physical activity is related to fall related injuries, muscle loss, mobility disorders, and loss of independence. I will quickly skip through this. So just give you an idea, I used one sensor here, and this was activity of one person across 1 week. As you see the blue bar means lying. So this is the nights period when the person was sleeping. So all nights you can see this is 7 nights of data, and walking is green. So you see some parts where the person was walking. The other is sedentary. So sedentary mean either when you are sitting or standing. So normally most of the time elderly people, they try to they are sedentary in fact, and there are very less active periods. So this is the sensor data, this is the accelerometer data, inertial sensors data, and then after extracting we were able to identify their patterns. This project, what I did was in collaboration with Malaysian Institute of Road Safety and Research, MIROS. So the idea was how you can detect driver drowsiness or when the driver is sleepy using the brain sensors. So we have used a variety of different brain sensors. We have used for the frontal and for the lower side of the brain of the back side. And we use ECG sensors as well. And the idea was that how accurate you can classify when the person start drowsing or start sleeping while driving. So we use a simulator here, as you can see, and we classify the activities using different data analytics techniques. So all these, we're talking about the smart technologies. You are analyzing, you are connecting that either, I mean, some devices, you can connect them to internet while others not. For example, a coffee vending machine. So in the coffee vending machine, you don't need to connect it to the internet as a customer. I mean, you just go there, you insert coin or you present card and you order the coffee. So that's again a smart machine. It has got some algorithm. And then you can talk about more complex applications like robotics, those who are performing amazing tasks. So everything that we are talking about is try to automate the process and ease the process is smart. Here in case again, we use the technology to say when we are sleeping, and in this way, we can have methods to alert the driver. It can be an alarm, a beep, or anything that can alert the driver. This was the last project that I was working in related to the healthcare domain. So sleep device, how you can measure your sleep. And it's not only about measuring your sleep, how you can improve your sleep. So what we use is, we have the brain sensors, we use the motion sensors and electrocardiogram sensors. I was working mainly on the smart intelligent sides of things, and this is a product that hopefully will be launched this year or next year. And idea is that you are using the brain's sensors, the heart sensors and other sensors to not only detect human sleep, but to improve that. How we can improve sleep? This is very important. About 10 to 15% of our sleep, as we know that our sleep, we have got different stages of sleep. We have got awake, stage 1, 2, deep sleep, and rapid eye movement. So deep sleep is something that is about 10 to 15% of our sleep. And this really reduces or diminishes as we get older. So after 50 or 60 years, our deep sleep is sort of reduced, or it will just go away. I mean, so the idea is that the more deep sleep we have, the more learning capabilities we have, the more we can learn. So imagine if you, I just give you some words to remember, and I ask you to, remember them again, or to answer me without sleeping after 8 hours. So if you are not sleeping and you are learning something, the idea is that you will learn less. And for example, if I give you some complex words to remember just before you go to the bed, and in the morning, I ask you again. So studies shows that the sleep, when you are sleeping, and because of the deep sleep, your memory skills as well as your learning skills, they are enhanced. It's just like when you are taking driving lessons to and you have taken a lesson in the morning, and in the instructor in the afternoon ask you to drive it again, and you are not having any sleep episode between that. So what the idea is that you will remember less in the afternoon, but on another day, when you have taken the lesson just before going to the sleep, or just before going to bed, and in the morning, if you are asked to provide more details of that, you will remember more, because your motor skills, how you are performing activities, as well as your mental capabilities, they are better utilized and they remember better when you sleep. So this was a project. Now I move to smart systems in environment. So how you can use smart systems in environmental applications. As we know that floods all around the globe, including UK, it's a major issue. So how we can predict changes in, so one of the study is that we know that one of the cause of the floods is that the river channels, they are modified. When we're talking about the river channel, the river bed, it means that the morphology of the river, it really changes. And what happens is, as a result, the capacity of such rivers become less. So it means that they have less capabilities to store the water. And eventually what happens is, as you see that the degradation of river bed, imagine this is, so this is a river and you have the river bed. As you can see, the degradation of river bed, it means that you have increased channel conveyance. Just giving you a brief insight. So it means that the more degradation you have, the more capacity the river will have to store the water, and it will have increased channel conveyance, which means that this is a positive sign. And while on the other hand, when you have aggregation of river bed, it means that the riverbed is aggregated and the channel conveyance is capacity is decreased, which means that it is narrowed down now. It's not widening, it's narrowing down, and the roughness is increased, and you have more chances. So you can see the water level, the same water is stored here in both, but here you can see on the picture D on the right side, the water levels are quite high, which is alarming, and then this can also cause flooding. So what we did was we used raw data from US Geology Survey, because they used to have different sensors. And what we do is they try to measure the river channel capacity. And then I've analyzed the data processing, and I've clustered the data, and eventually I've predicted the channel conveyance, because the ultimate goal is how you can predict the channel conveyance. If it is increasing, it means that you have more capacity to store the water, and you have less chances of flooding. And on the other hand, you have more chances of flooding. And this is the analysis that we have done. So this in fact shows you how your channel is changing. So for example, these blue lines that shows that these are the measurements that are taken on closer side of channel, while the other, they are the measurements that are taken on the wider side of channel. Another example of using smart technology in disasters or social analytics is how you can use Twitter-based data sets. So the idea is that whether you are affected by flooding or meteorological hazards, hydrological hazards, or geological. So it can be flooding, earthquakes, or anything. You can use, in addition to the communication infrastructure, because we know that mobile communications and other, they are quite essential. You can also use Twitter-based platforms to locate. And what this will help is, this will help the public organizations to take immediate actions. For example, if there are tweets about certain areas that there is flooding that has occurred. So while people are tweeting, you can use smart analytics, you can use to analyze those tweets, and you can then classify if there is a flooding or not. So what we did was, we take the Twitter data, we label the Twitter data if it is flooding or not, and we have used classification and cross validation method to predict if we have got flooding or not. So we have achieved about 95% of accuracies. These are just to give you the last example. Now we have is smart systems for IoT enabled industry 4.0. So how smart systems can be used in Internet of Things and smart industry. So as we know that you have a smart industry, you have very complex operations, mechanical, chemicals, and other operations. And what you can do is, you can control those processes using sensors. For example, you can have different sensors like pressure, temperature sensor, manufacturing sensors, a lot of other sensors. Those are deployed in the industry. And what you do is, you try to analyze those sensors data and extract patterns. This is kind of a new domain which is about cognitive intelligence. So the idea of cognitive intelligence is that you, in the industry, you try to model the system and perform a variety of analytics operations. For example, there is a manufacturing plant, and it has, you have got mechanical sensors and temperature sensors, a lot of other sensors. You try to monitor all the levels of how much strain or the pressure is applied, and you can also have other like temperature sensors, and then you are trying to analyze these continuously 24/7. And if there is any issue that happens, you can immediately perform actions and try to fix the fault. On the same way, this can be used as supply and change management. For example, in an industry where you need to, just giving you an example of medical industry, where which is providing, let's say, PPE, so personal protective equipments for COVID. So you have a lot of suppliers, and you try to track the supplies because you need that raw material in the industry, and in order to not to stop the production, you want them everything to be connected. And then of course in the production you try to connect yourself with the distributors or providers, so you can distribute your stuff and your warehouse is not overloaded. In this way you can also use smart technologies. Just last slide. So about smart technologies, that smart technologies, they are used everywhere, whether it is consumer, home electronics, smart infrastructures. You can have a lot of sensors which try to provide you the physical properties of a building or anything of the structure, how strong it is, how it can be used. Of course, security and surveillance, we are using it. Transportation, smart transportation, that is the future, and people are using it for that. A lot of other, for example, agriculture, you can use it for industry, retail, as I say, supply chain management. And for example, you can use it, giving you the example of Amazon, where you are giving reviews. So one can see how about the product, is it really liked by the people or is disliked? So you can use smart analytics. And of course, healthcare that I described in detail. So all these are the application of smart, but there are some limitations which I just would like to highlight before I end the presentation. So we need more processing power. Of course, this domain is really progressing fast, but we have ethical concerns as well. When we are using a lot of these sensors, so it's not only the technology that can bring you, because the humans are the center of all these technologies. We are going to develop these. We are going to train the model. We are giving to develop everything. So the idea is that now there is a lot of happening in research and development, but then there is a gap between the public authorities, how you can implement such methods in real life. So there are ethical concerns and others which need to be highlighted. Apart from others, for example, because a lot of people, they fear that technologies are going to overtake humans, which I believe is not true, because everything that we develop is humans are the focus of that, and they are the one who are creating everything. So it's still, I mean, everything is going to be in our hand and for our comfort, and all the smart technologies, they are for the betterment of society and to improve the quality of life. Thank you very much.
Thank you, Dr. Mohammed Awais from Edge University, UK. Really, the session is a very interesting session. You have done a very good presentation, excellent presentation. And the participants and the students who are available in this call are able to understand the technological advancements with the support of AI, artificial intelligence. So let me thank you very much, Mohammed Awais. Thank you for your wonderful presentation. And on behalf of our university, I would like to thank you so much, and please convey my regards to Dr. Nick Bessis, Head of the Department of Computer Science at Edge University.
Okay.
Yeah. Thank you.
Thank you very much. And if you have any questions, anyone, you can also email me. I've got my details. Thanks a lot for the invitation, and it was very nice.
As a principal of Marine Engineering Department, I would like to thank you, sir. I've been listening. I mean, it's a in-depth study, I should say. And the first thing is, you had an added advantage with electrical electronics and with the computer science combination. So that has helped you a lot in preparing these PPTs and giving examples, apt examples. What is before and what is after, when implementation. That was the excellent part, I should say. Definitely, we will look forward for your help, sir, in various aspects of our research and development in our university. And I hope we thank your head of the department also in giving you this opportunity to be in this, August gathering here. Yeah, thank you very much, sir.
Thank you very much, Dr. Bhupati and Dr. Cecilita. Thanks a lot for your time, and it was really a pleasure for me to present here. And I wish you best of luck for this conference. And thanks for the invitation again.
Thank you, sir. Thank you, sir.
Thank you.
Any questions, dear students? If you have, you can just post it to sir in email format if you're running short of time or so. So sir will definitely reply to us. Thank you, sir. Thank you. Madam, it's yours.
Aaron, sir?
Yes.
Sir, please take over the session.
Yeah, take over the session.
Yeah, thank you, ma'am. Aaron, sir?
Yes, ma'am.
If we can post the Google link in the chat box.
Yeah, sure.
The participants can join there.
Yeah.
Sangeeta ma'am,
Yes, sir.
I have posted the Google Meet link in the chat box for track 3 participants.
Okay, thank you, sir. Thank you. Ma'am, sir, then we will be joining in Google Meet now.
Okay.
For track 3, ma'am.
Okay, Dr. Iraq is available here.
Yes.
No, ma'am, he is not available.
No, ma'am, he is not available.
Okay, okay.
And call him.
Shall we continue? Shall I start the second session, ma'am?
Sure, sir. You can proceed, sir.
Okay,
Sir, ma'am, we are leaving, ma'am.
Sir, just a minute, Sir Suresh, sir. Just a minute. I would like to inform all the participants regarding the track 2 and track 3 presentation. Track 2 presentations will be held at Zoom, and track 3 presentations will be held at Google Meet. And the Google Meet link is posted in the chat box. Kindly refer with that and make use of that. Thank you.
Thank you, Harish. So, very good afternoon to one and all. So myself, Dr. Suresh, and my colleague, Mr. Aaron, will be the session chair for the second track, meteorology and weather forecasting. Right. So each presenter can take 10 minutes for their presentations, then 5 minutes for the questionnaire sessions. So the audience as well as the panelists can raise the queries if you have with the presentations. Okay, so Aaron sir, please call the first.
Yes, sir. So first paper, I would call paper ID ICD-TMS 0501, the amalgamation of technology, intro art and science of celestial navigation, authored by Commander Ramakrishnan Venkat from Naval Architecture. I request sir to give his technical presentation. Ramakrishnan Venkat, sir.
Yeah, very good afternoon to you. I'm just setting up. Yeah.
Sure.
Good afternoon, Captain. Good afternoon.
Very good afternoon to you, Principal sir.
Yes.
Very good afternoon. Just a minute. Am I audible?
Yes, sir. You're audible, sir.
Okay, fine. Respected, shall I commence the session, Dr. Suresh?
Yes, sir. Please proceed, sir.
Yeah,
Please proceed.
okay, fine. Respected chair of the conference session, Dr. Irek, Professor of Department of Information System, Maritime University from Poland. Respected co-chair, Dr. Suresh, faculty members of universities, participants, ladies and gentlemen. I am privileged to present my research paper, The Amalgamation of Technology into Art and Science of Celestial Navigation, Ways to Accurate Position Fixing at Sea. At the outset, I would like to thank the Dean and all faculty from Nautical Science Department, Ahmed University, and management from Ahmed University for their encouragement and overall support. You are all aware that navigating a ship at sea has been a challenging task for many seafarers since the time human ventured out into ocean. Many progress were made by our elder mariners, and since early 18th century till to date on ocean navigation aspect. Celestial navigation is primarily to find positions of ships at sea and using the celestial bodies of sun, planets during the day, stars during the night. During the late 20th century, we saw the development of satellite-based navigation system, and we are able to fix any position on the Earth with the help of global positioning system or its equivalent satellite system. With the proliferation of this satellite-based position fixing system from 1980s, the mariners' interest has gradually diminished in practicing the celestial navigation at sea, except for learning the basics and practicing it as a cross-check method or to keep the art alive amongst the mariners. When I analyzed in my research paper the primary cause of the neglect of the celestial navigation, main contributors are
Good afternoon, sir.
non-availability of real-time position fixing, and next is error of half a mile to 2 miles due to inaccurate inputs and computations. I just take a break. There is a disturbance in the system. I'll just come back, Dr. Suresh.
I changed from Zoom to here. I could not get.
For track 3, we are connecting in Zoom. Google Meet.
I was thinking whether I could not read that the chat box, the link you given. I could not copy paste that. So I thought I'd go back to yesterday's message and try that.
Sir, I posted it in my marine engineering group, sir.
Today, now
there is something.
Engineering group.
Okay, now, earlier I joined on, but it's the same link. Then
There is a disturbance from Google Meet. 1 second, and I was in the Google Meet also. That's why the disturbance is there.
Now it's fine, sir. We can go ahead.
Yeah.
Sorry, sir. Continue, sir. Thank you, sir.
Sir, you can continue, sir, now.
Yeah, right, sir. I had a disturbance from Google Meet. That's
Yes,
why.
sir. Now it's clear, sir. Now it's clear, sir.
Yes, yes. In-depth analysis of the issue of celestial navigation revealed two primary causes. Firstly, the manual observation of celestial bodies, along with environmental causes placing restrictions on windows of time of observation and its weather dependency on observation. Secondly, position inaccuracy due to error in computation and plotting of chart. It is very interesting to witness achievement of tremendous advancement in computation of position with the aid of advanced software programs after the proliferation of software and information technology during the last 2 decades. However, this position achieved through the celestial navigation method still suffer from accuracy owing to manual observation of celestial body. Observation of celestial body through manual method can be further divided into two different aspects. One is the instrument section, other one is the measure to overcome weather and environmental restriction. To revive the time-tested and proven celestial navigation at sea, I have been focusing on various factors during the last 3 years. I have explored in this paper of mine ways and means to reduce the limitation experienced owing to manual observation using sectant instrument with the aid of advanced technology and modern automated optical sensors. Another study will be, in fact, needed to overcome the environmental restriction. I can say with the confidence, after this work, we can overcome the dependency on manual observation by replacing the section instrument with electro-optical sensors to achieve automatic observation of celestial body. Thus, we can greatly extend and eliminate the induced human error causing the position inaccuracy at sea. Coming to dwell into my paper specifically, I'm going to highlight only few aspects during the limited time available to me. Today, with the availability of advanced technological tools, industries across the globe have automated with sensors and instruments to do many tasks which were done earlier by humans. Similarly, automation could be achieved in observation of celestial body using technology. Key points emerged from the research are exploration of ideal electro-optical system as a sensor to observe celestial bodies and exploration of making best use of image matching algorithm already available in various applications. Let us now glance into electro-optical system. Star tracker, or called star sensor camera, used in spacecraft to find the altitude of satellite using celestial body, especially stars. This process involves capturing image of the star field or star pattern, or we call constellations, with a high resolution camera and interpreting the image using advanced algorithm to find the altitude of satellite. The whole process is continuous when the satellite is in motion, and captured image is analyzed based on stored catalog of star images in the computer processor. The star sensor camera can be used for reverse benefit to estimate the local coordinates of the camera if fitted on a platform or ship on the Earth. This warrants suitable modification of technique used and algorithm to achieve desired end result. When further analyzed on the usage of star sensor camera on board a ship, it might encounter the problem of realignment of camera with a local direction of gravity and needs to have feed of accurate time and means to overcome atmospheric disturbance. There has been a study earlier in 2008 itself on the same principle, have named the device as Compass Star Tracker. And that is to estimate position coordinate of ship latitude and longitude from where the camera captures the star image. However, it suffered alignment of optical axis of star sensor camera to the local effective gravity field vector, which is one of the significant conditions to achieve the position of ship at sea. If this is achieved, then the picture of the star field contains all the needed information for position finding. The sky image captured by camera then could be processed using the star centroid principle and star identification algorithm using software-based processor. Let us see now a little bit into alignment of camera with a local gravity field vector and celestial reference frame. Several reference frames are used in position determination. The main one is inertial reference frame I, also called Earth centroid inertial frame, as the star catalog provides reference vectors for the stars in this I frame. As shown in the figure, I frame is aligned with x-axis, which is aligned with the vernal equinox, the ascending node of geocentric eclipse, and the xy plane with the equatorial plane. The Greenwich reference frame G is also known as Earth-centered Earth-fixed frame, describes the location of Greenwich meridian corresponding to longitude. Orientation of frame, both frames, I have shown it on the screen. Now let's come to the local frame. About the relationship between these three frames, that is the local, Greenwich, and compass frame, it is to be understood. Here, the latitude and longitudes are taken from the local frame between the Greenwich as well as the compass frame. The angle measurement from the inclinometers are used to find the altitude transformation from the compass to the body frame by matrix method. Aspect of spheroid. Next is we need to little inclinometer. I have already shown you. This is the correlation required to be done between the body frame and the local frame. And we need to know a little bit about the spheroid and spherical Earth. It is a well-known fact that Earth is not a true sphere. Star tracker camera, when we need to use it for aligning vertically towards the sky with a high precision to find the camera's current location on the Earth. Moreover, it achieved electronically today to get the vertical alignment of the star camera focal axis concerning the Earth's surface. Another point is that Earth's shape is oblate and not a sphere. And the equator bulges out to the planet rotation, and geographic term, the Earth is a geoid,
Yes,
not
madam.
a sphere. There is some disturbance, sir.
Start பண்ணுங்க program.
The difference is not much. It does affect our view of the stars by changing our latitude slightly. So geodetic latitude based on lines perpendicular to the tangent plane on the Earth's surface, and it does not lie at the center of the Earth owing to oblate shape of the Earth's surface, whereas the geocentric or geographic latitude report concerning the center of the Earth. Geocentric latitude needs to be computed which based on the center of the Earth, which can be achieved with a advanced algorithm further for the place. And we need to know a little bit about the gravity meters. For accurate output, the only condition required is that optical axis of star sensor aligned concerning the local effective gravity field vector, as I said earlier. When this occurs, we have all information. The terrestrial gravity meters measure the gravitational acceleration near the Earth's surface, and this instrument are called absolute gravity meters. Most common gravity meters called relative gravity meter, which do not measure the acceleration of freely falling fruit masses, but rather it measures the static force of gravity on fruit mass using elastic element. This optical instrument development can be effectively used for us. And let's go a little bit into the inertial navigation system, where this gravity vector field is nullified or errors are reduced to great extent with advancement technology. It is an instrument, INSS, that is the inertial navigation system, an instrument that can automatically determine the ship position coordinate and velocity component based on its self-contained gyroscope and accelerometer. And it is used widely for primary means of plotting and maintaining the track on board ship. And there are errors which can occur due to inertial sensor and gravity disturbance. However, we can overcome this with advanced application of technology. And if I show it on the screen here, the particular diagram, where the gravity vector is the perpendicular line of the equipotential surface of gravity. It is very complex, and the reference ellipsoid model WGS 84 is initially used in inertial navigation system to approximate the Earth equipotential surface of gravity. And G is the true gravity vector of point P, and Y is the normal gravity vector of the point P, and the gravity disturbance vector is the difference between the true gravity vector and the normal gravity vector. The difference in magnitude is the gravity disturbance, and the difference in the direction is the deflection of vertical. To reference coordinates from as shown on the screen now, to describe the deflection of verticals of true and normal gravity vector, the origin of coordinate frame is at the center, we can call it center of the Earth, whose z-axis is points in the direction of North Pole. And the x-axis points towards the Greenwich meridian, and y-axis complete the right-hand orthogonal frame. These frames indicate the direction of normal gravity vector, and this coordinate frame rotates with the Earth at an angular velocity as shown. And this angular velocity can be still computed with using the advanced software. And another feature which we would like to show about the true and normal gravity vector, where it is going to make a huge difference for finding the position of the camera or aligning the particular camera axis with the gravity vector, is on the screen. And the high precision long-term inertial navigation system, both the altitude damping and the horizontal velocity damping networks, the gravity disturbance vector induced errors exist almost exclusively on the horizontal channel and are caused mainly by deflection of the vertical, as I said. And it is being overcome by application of error components. And to compensate these errors, as we have discussed because of the DOV, The Earth gravitational model 2008 is presently used with a global set of area, mainly across the ocean. And the gravity anomaly can integrate with the INS. It is integrated with the INS. And with the integration, assessment of INS in various regions worldwide indicate it performs comparably with the contemporary detailed regional geoid model, and the position accuracy improved. Even now, with the high resolution Earth gravitation model are under development. The recent one, which is promulgated, is the Earth Gravity Model 2020, is determined with an international collaborative project led by National Geospatial Intelligence Agency. And software data on the Earth Gravitational Model 2008 as well as 2020 are almost similar, except that accuracy is improved here. Thus, it is reasonable to take advantage of the same 2008 or 2008 EGM model to ensure optical axis of star sensor aligned concerning the local effective gravity field vector for aligning the camera on board ship. Now, let's look at quickly into the optical system which I am recommending in my study. A section can be replaced with the advanced camera used in star trackers or spacecraft for auto observation of celestial body under a controlled environment, including computer guidance for using select celestial body. Using an advanced camera of star tracker need to meet ergonomic conditions for stabilized mounting to prevent the ship's roll, pitch, and yaw motions while housing it at a known height atop the ship bridge. Almost all spacecraft steer by stars and regularly update their course by checking the position of the star. A camera used to check the star position is also known as star tracker, is a celestial reference device that recognizes star pattern and constellation. There are two types of star camera presently used. That is a charged coupled device CCD sensor camera or active pixel sensor. As against the traditional CCD technology, APS is a new type of compact imaging device and with an array of photo sensors have higher dynamic range. In addition, APS uses the complementary metal oxide semiconductor CMOS, which can more accurately measure star intensity across more extensive range, unlike CCD star sensor. To recognize the star pattern, miniaturized camera with an active pixel sensor is used with a wide field of view. APS is a new type of compact imaging device with an array of photo sensors and uses lesser power, and it is more compact also. Now, when I look at the image matching algorithm which are used, which can be converted for ship positioning technique, and all image matching algorithm uses only two principles, that is the star brightness as well as star pattern. The existing one is the pyramid star identification technique and geometric vortex algorithm. However, there are advanced methods which are presently can be used, which is mainly on the projective camera method. An ideal projective camera is described by pinhole camera model, as I have shown you on the screen. The z-axis is along the optical axis and location of x-axis of the star image plane. Its coordinates found using the focal length normalized coordinate, that is homogeneous coordinates of projective space. Star pattern, also known as asterism in this case, is in a digital image, needs to be automatically recognized by the algorithm. And it is feasible with a projective camera image, it can be achieved. Invariant asterism descriptors are the main mathematical construct around this particular projective camera as well as algorithm connected with that for star identification. And it uses the attributes related to geometric or photometric properties of the asterism to recognize it. Let me say a little bit about that. The star directions are represented as a unit vector or a point on the celestial sphere. Here, the star observed as pixel location at the camera, that is U or V at the camera frame, find the same corresponding image plane coordinate x, y by the calibration matrix using the three-dimensional unique orthogonal group parameters. The matrix is further advantageous when a pair of stars is captured. When you have two stars are together and it is captured, that particular single variant of angular difference or the pixel difference can be better utilized for finding your camera location on the Earth. The InterStar angle, another method, is one of the most popular invariant used by the projective camera. And it has got advantages. There are 6 different methods can be used, or different input can be taken for identifying the star. The spherical triangle which is formed between these 3 stars can be used to find out the accurate angle, and also can be used using the cosine values of dihedral angles. And InterStar angles are explicitly, they are related to each other. It can be used for computation of position of camera exactly on the Earth. And this new star identification framework based on this projective camera can detect the altitude determination, as well as sensor self-calibration can be done. And it uses the wide field of view projective camera, and it gets the entire frame of the star image in a single field. And to summarize, star sensors have also advanced technology, as star-based application demanded refinement for a while during the last 2 decades. And its size, weight, and other parameters are very less compared to sophisticated other machineries on chip. And it is going to, if the further research is done, it will give better performance and in finding the accuracy of the position of ships using the celestial navigation technique. There are notable field of application apart from this finding the altitude. The same satellites are using the star sensor camera for finding the angular velocity of the spacecraft. And it can be used for space surveillance also. And idea is that the Earth-based autonomous celestial navigation sensor can be used by using this advanced algorithm based on the computer software, as well as nullifying the effect of gravitational vector, which is already experienced in the inertial navigation system, application of that on the star sensor camera, and using it to capture the image. An image-based algorithm interpretation can find the position of the ship using the same technique of. But only drawback is it is still depend on the weather, which I need to do some more research on this particular aspect. And we need to do more research and study. And I have planned it, and there are a method by which we can overcome this. That is very confident. And with this, I'm open for any questions. I've finished my presentation, sir.
So any questions? Any queries from the audience?
Sir, you can also take sir's email ID. Later stages, any questions comes up, we can post it to sir also and convey the answers.
Yeah, my email ID already there.
Yes.
Email ID. Yes.
Yes, sir. Sure, sir. Thank you very much, sir.
Thank you.
I think, very short, brief time, you have just poured in a lot of information in it. Okay. Sure, we will try to improve on this and do a lot of research on these activities, sir.
Thank you, sir.
Thank you, sir. Thank you.
Yes. Sir? Okay. Yeah, you can proceed. Now I would like to call upon paper number IC DTMS 303, naming plasma spray coating of aluminum silicon MWCNT composite, a case study on aluminium 6061 by Mr. Prabhu, MIT from Anna University. Dr. Prabhu?
Yes, sir. Good afternoon, sir.
You can present. Yes, sir. You can proceed, sir.
Yes, sir. Sir, I cannot share the screen while
you are in
already.
You are in. Yeah. Ramakrishnan sir.
Ramakrishnan sir,
can you please stop presenting? Please stop presenting, sir.
Yeah. Prabhu sir, you can proceed. Now you can
Yes, sir.
share.
Shanti ma'am, mute your mic.
Good afternoon, everyone. I'm Prabhu. I'm a research scholar in MIT. So today I'm going to present about this case study, which is the plasma spray coating of aluminum silicon multi-walled carbon nanotube composite on aluminum 6061 material. So these are the contents of my presentation. So overview. So in many applications, we can see carbon nanotubes are used to reinforce the composite materials. So such as in aerospace and automotive industries, we can find this kind of reinforced nanocomposite materials have many applications. So in this study, the thermal spraying technique is used to obtain a dispersion of nanotubes on a aluminum silicon alloy material. So this nanocomposite ceramic material, nanocomposite ceramic coating also provides improved properties like wear resistance and thermal barrier coating. So in this work, a 5%, 58% of CNT were mixed with aluminum silicon alloy, and which is sprayed onto a aluminum 6061 mantle. The result of the experiments demonstrate that there is a significant improvement in coating performance, and the hardness and other mechanical properties of the material is improved. So metal matrix composites have been proposed for many automobile and space applications due to their superior mechanical properties like higher specific strength and stiffness. The multi-walled carbon nanotubes possess unique properties like high stiffness, strength, thermal conductivity up to 3000 watts per meter per Kelvin. So there are several fabrication routes which are powder metallurgy, ball milling, extrusion, hot pressing, equal channel angular pressing, spark plasma sintering, electro deposition, electroless deposition, and thermal spraying have been used to synthesize metal matrix composite with CNT. The goal of this work is to improve the dispersion of CNT in aluminum mantle by employing plasma spraying method. The microstructure evolution of the coating and enhanced properties of the plasma spray is reported with the help of SEM analysis, EDX report, and the shear test report. The change in mechanical properties with the CNT is also investigated. The powder feedstock, aluminum and silicon hydritic alloy powder of composition aluminum 72% and silicon 23% by weight, both having a mean particle size of 45 micron, was obtained from Sigma Aldrich, India, and from Syram Enterprises, we have obtained the multi-walled carbon nanotube, which has 10 nanometer inner and 30 nanometer outer diameter, and the purity of 95%. This aluminum silicon powder and carbon nanotube were mixed to make fine alloy powder using mechanical alloying process named ball milling. And the composition of the carbon nanotube was 58%. So this is the plasma arc spraying process, where you can see there are a cathode and anode. So the plasma gas which consists of argon, helium, hydrogen, and nitrogen, which are then fed to this channel, which then ejected through this nozzle. So while applying a voltage across this cathode and anode, we are getting an arc that will make the gas into plasma. So that ionized plasma, then the powder feedstock is poured through this port. The powder feedstock we have made it through the ball milling process. We are going to feed it through these two ports, and that powder feedstock will get spread onto the our desired area. So this is the plasma spray arc spraying process. So when applying a high voltage, which initiate the plasma, that will give the ionization of these gases, and a conductive DC arc to form, which forms between this cathode and anode. That arc will causes a resistance heating and enables a gas to reach a extreme temperature to dissociate and ionize to form plasma. When this plasma exits the nozzle in a neutral element, the powder being used is so rapidly heated and which is accelerated that the spray distance can be from 25 to 150 millimeter. So these points are explained. So these are the parameters of the plasma spraying experiment. So the heat source is plasma arc, and the voltage we applied for voltage for this process is 35 volt and current is 800 ampere. Particle velocity is 352.
Your voice is not audible. Yeah.
Hello?
Yeah, now it's fine.
Okay. The particle velocity is 352, around 352 to 1000 meter per second. The temperature can reach up to 10,000 to 15,000 Kelvin. The gases used are primary gas is argon and the secondary gas is helium. So after coating, the mandrel will look like this. These are the coated areas. So after getting that coated mandrel, we have analyzed this using this SEM. These are the images that are taken from the images SEM analysis, where these are the bright field image of carbon 5% carbon nanotube reinforced aluminum silicon composite particle. So where you can see these tube-like structures can be seen are distributed uniformly. So based on the coating is thoroughly uniform and which is required for our purpose. And this EDX report shows the composition of the composition of the alloy, where the aluminum is 43.42%, the atomic weight percentage is 55.57%, whereas silicon 31.21%, 29.9%, oxygen 24.64%, and the atomic percentage of oxygen is 14.04%. Carbon is 0.73 and 0.4 for weight percentage and atomic percentage. So then the material is shear tested, mandrel is shear tested. The coated aluminum mandrel is subjected to shear testing, and these results are found. So the tensile strength we have got from the mandrel is 312.19 megapascal, and the yield stress is 266.58 megapascal. Elongation is 13.2%. Shear strength is 170.18%. The coating thickness is around 116 to 164 micron. The hardness we have obtained is 202.3. 207.1 HPW. So it is a conclusion. The thick aluminum alloy coating contains 5% were successfully fabricated by plasma spraying. Plasma spraying is an effective way of dispersing CNT at a scale of micrometer. The reinforcement of carbon nanotube composite on aluminum mandrel using plasma spray has shown increase in hardness. The results obtained from this work helps to know how to increase the properties of the material, and the application of the carbon nanotube is in wide range. So thank you.
Thank you. Any questions from participants? If you are having any queries, you can post it in chat box. Next, we move on to next paper. That paper, Mr. Dhanavaran, ICDTMS 2014, numerical prediction on aerodynamic induced drag reduction using slotted wing tips. Mr. Dhanavaran, sir, I request you to give your
Yes, sir.
presentation.
Yes.
Yeah.
Just a second. Sir, is my voice being audible, sir?
Yes, sir. Yes, sir. Very well audible.
Yes, sir.
Yeah, thank you.
Yeah, the paper which we are going to present is numerical prediction on aerodynamic induced drag reduction using slotted wingtips. Me, myself, Dhanavaran. The first author is Dr. S. Sendil Kumar, Associate Professor in Department of Aerospace Engineering, SRMIST, Katangalathur. The second author is Dr. Edison Chandraseelan, Professor in Marine Engineering, Hamlet University, Chennai. And the third author is myself, Mr. N. Dhanavaran. I'm working as a teaching fellow and also as a research scholar in Madras Institute of Technology, Anna University. And the fourth author is Mr. Prabhu. The fifth author is Mr. P. Mani. Yeah. So the contents which were presented in this paper are basically induced drag, non-planar wings in counteracting the drag forces, and the third one is aerodynamic of wings, and drag and energy loss in wake, drag and local flow near the wing, possible ways of drag reduction and its effects, and study of slotted winglet of birds, three-dimensional modeling of wing with slotted tips using CATIA, and three-dimensional view diagram with slotted wings. Then pressure distribution on wing and winglets, streamline patterns on the wings, then comparison of aerodynamic characteristics of straight wing with that of the wing with slotted tips. Then what are the advantages of slotted wingtips over conventional wingtips? Then conclusion and also references. So induced drag. Induced drag is an inevitable consequence of lift, and it is produced by the passage of aerofoil through a thin air. Airflow over the top of the wing tends to flow inwards because the decreased pressure over the top surface is lesser than the pressure outside the wingtip. And the angle between the relative wind and on the chord line is called as the angle of attack. And this is the basic aerofoil, which is being shown here, represented here. And non-planar wings. Non-planar wing system or optimally loaded wings with higher aerodynamic efficiency than planar wings, having the same aspect ratios. Methods for the analysis of such wings have evolved due to the requirements of minimum induced drag or drag due to the lift for powered aircraft, and later for endurance flight, flight altitude flight, and human powered flight. So the wing systems include wings with a span-wise chamber, C wings, ring wings, and also various combinations of basic lifting surfaces, wings with end plates and winglets and other tips, and that tip devices belong to the same category of non-planar system. So these are the wing system which come under non-planar wings. So basically in aerodynamics we are looking into four important things, which is weight, lift, thrust and drag, which is explained here. And any device designed to produce lift or thrust when passed through the air is an aerofoil, and airplane wings, propeller blades, and helicopter main and tail rotors blades are all airfoils in nature. Yeah. So this represents drag and energy loss in during weight. Like you can see an airplane. You can see wingtip vertices quantitatively illustrated during wake turbulence. This image is taken from NASA. So these are wake turbulence. Yes. So the free vertices in the wake of the wing cause the flow near the wing to have the downward velocity components, which is downlash between the wing tips, and the downlash causes the drag on the wing. Local flow in upward component may reduce drag or even generate thrust. Flapping wings and propellers produce thrust by this means. And Spillman describes how wings, which he call as wingtips, can have a reduced drag because they extend into the upward local flow at the end of the wings that produce that they extend into upward local flow at the ends of the wings. They produce a lift. So this local flow arises because the pressure beneath the wing is greater than the above, and airflow upwards around the end of the wings. So some of the possible solutions for drag reduction is basically induced drag may be easily reduced by increasing the span of the planar wing. Okay, and the effects are 10% increase in span reduces the drag by 17%, and higher structural weight and cost may result in such efforts counterproductive. Since the span is being increased, it requires an higher weight. It will cause higher weight, and also higher structural integrity is required. So implementation of non-planar wing concepts. So the effects are non-planar wings offer the possibility of reduced drag compared with planar wings of the same span and area. So winglets that are 20% of the semi-span in the height reduces the drag by 17%. Yes. So these are some of the induced drag variation for non-planar systems, and the graph is being shown, and overall height span is being compared to relative vortex drag. Yeah. So this the idea of slotted winglets is basically being derived from birds. So in comparison, birds which soar over the land and birds which soar over the sea, seagulls and albatross usually have longer, narrower wings with pointed tips. The reduced drag of slotted tips suggests why this difference has evolved, and the slotted tips allow short wings to have the same induced drag as longer wings without tip slots to have higher span factors. So short wings can be made lighter than longer wings that will produce the same amount of lift, because short wings have lower root bending moments. And short wings are also maneuverable easily, and they can perform row and yacht and higher angular velocity for a given tip speed. So in land and sea environments differ in that the land surface has more irregular relief and surface temperature and vary more in time and space. As a result, winds over land, including thermals, are less predictable than those over the sea. So land birds take off by flapping in the absence of wind, maneuverability in a spatially restricted environment, and soar in a unpredictable wind, and while circling slowly in small thermals. So short wings have definitely advantages for these activities in case of land birds, and seabirds would derive less advantage from short wings because they probably maneuver less than land birds, but in addition, seabirds fly at a average higher speed than land birds. So the tip feathers obviously produce lift because they bend towards when the bird is not flying. So biologists have speculated for years about the function other than lift. Production of slotted wingtips have been suggested by Graham 1932 and 1981. So reduction of sound, prevention of feather weight, and reduction of wing twisting, control and sublation of roll, so prevention of stall, and these are some of the advantages which are yet to be experimentally verified. And as you can see, the slotted slots formed by the separated primary feathers at the wing tips is being shown here, and the vertical separation between the feathers in the slotted wingtips of Harris hawk is being shown here. So coming to the experimental study, three-dimensional modeling of the wing using slotted tips using CATIA. So the normal aerofoil is taken, and the aerofoil which is chosen is NACA 632A015, and these are the dimensional parameters of the wing, which is being shown here, and also slotted wing tips which are having the angle of attack and dihedral and sweep back angle respectively of the slotted tips is being shown here. Anterior, middle, and posterior winglets is being shown here. So the model is being made. Have been made, and the model top view, front view, and side views is being shown here. So the CFD methodology is design, import, meshing. So the model is being made in CATIA, and the first step is that design, import, and meshing. The third is boundary conditions to be applied. The fourth is pressure distribution. The fifth is streamline pattern, and then different CD and CL are being generated. So importing, meshing, and applying of boundary conditions. So the boundary conditions which are applied here are inlet normal speed of 68 meters per second, and outlet average outlet static relative pressure equals 0 atm, and wall is wing surface, and the free slip condition is given on the walls. So upon applying this boundary condition, the pressure distribution we got is shown here for the normal winglet, and for a slotted winglet, the pressure distribution is is being shown here. For the three winglet tips is being shown here. Three slots of winglets is being shown here. And if we compare the lift coefficient with the angle of attack, so blue color basically indicates the normal wing, and CL red color indicates the slotted wing clip, and it is being compared over here. So the lift coefficient is basically similar, is almost similar, but somewhat lower. The slotted wingtips have a somewhat lower, and while comparing the drag coefficients, we can see that the slotted winglets have lesser coefficient of drag, which is good. And while comparing the angle of attack with the L/D ratio, which is coefficient of lift divided by the coefficient of drag, we are getting these results. So basically, to normal wing, the experiment simulation is being performed between a normal winglet and an slotted winglet, and these are the results which have been established. So CL versus CD is being shown here, and the angle of attack versus Oswald's efficiency factor is also being computed, and the angle of attack versus the Oswald's efficiency factor is also being shown here. So some of the advantages of slotted wingtips which have been confirmed is reduction of drag, prevention of wear, so reduction of wing twisting, control and stabilization of roll, reduction of sound, and prevention of stall. So increment in lift coefficient, a small improvement in lift coefficient. And while comparing the angle of attack with CD, we are getting which is the coefficient of drag. We can see the percentage, which is percentage of reduction between a normal winglet and an winglet with slotted tips is basically 20%. And it is evident from different angle of attacks that it almost produces 18% reduction in your drag coefficient. So the aerodynamic performance of the slotted wingtips is steady, and the lift drag and lift to drag ratio of the straight wings and the wing with the slotted wingtips of the same aspect ratio are being compared for different angle of attacks. So with the help of the numerical solution, we found the following. The induced drag for the wing with slotted winglets is much lesser than the straight wing at different angles, which in turn helps us to save fuel to a great extent. We also found L by D ratio is increased to a certain extent in the wing with the slotted tips, and the interference pattern is also steady. So these are the references which are being made. So with that, I conclude my presentation.
Yes, sir. Thank you. So participants, if you are having any queries, you can ask. If you are having queries, you can post it in chat box. We will go to next paper, fourth paper. I would like to call paper ID ICD TMS 0502, design of a low-cost underwater acoustic modem for ocean monitoring and control by Dr. Smiley Madhuram and N. Gomadi. I request Madam to give her presentation. Please, ma'am. Yes, sir, you can end your presentation, sir, so that Madam will
just a second.
Yeah. Yes, madam. Now you can present now.
Sir, able to see my screen, sir?
Yes, ma'am, it's visible.
Good afternoon to all. I'm Dr. Smiley Madhuram, Associate Professor.
But voice is little bit low. But anyhow, we will continue.
Voice is very low.
Is my voice very low, sir?
Yes, ma'am.
I'm audible now, sir?
Okay, ma'am. We will go on. Thank you.
Good afternoon to all. I'm Dr. Smiley Madhuram, Associate Professor in the Department of Marine Engineering, MS University. Today, I'm presenting my proposed work in my research area, design of low-cost acoustic modem for ocean monitoring and control after a careful and detailed study of the literature present. My paper focuses on the acoustic modem from the perspective of cost. The transducer proposed is to be made of inexpensive piezoceramic material. So by building the modem from inexpensive components, the design will be to produce an alternative for low-cost, low-power alternative to existing commercial modems for use in short-range networks. So this is actually the basic components of underwater acoustic modem design. It consists of a transducer, an analog transceiver, and a digital hardware platform. So the novelty of my research work lies in designing of a low-cost omnidirectional transceiver, a new design for analog transceiver, and a design of FPGA FSK-based digital transceiver.
So here I would like to show you the cost of the existing aquatic models which are used right now. They are very expensive and they cannot be deployed in a network where it contains many such transducers. So coming to my first part, the transducer design, it is made up of a piezo-ceramic material. So to tell about piezo-ceramic material, it was found in 1880 by Jacques and Periquery that certain naturally occurring crystalline substances exhibit unusual characteristics. That is, when they are subjected to a mechanical force, polarization of crystals take place, and when these polarized crystals are exposed to an electric field, the crystals either lengthened or shortened according to the polarity and in proportion to the strength of the field. These behaviors are called as piezoelectric effect and inverse piezoelectric effect. Certain synthetic polymers and polycrystalline ceramics exhibit the polarized piezoelectric effect. They are relatively inexpensive to manufacture, physically strong, and chemically inert. Common compositions include lead zirconate and titanate and barium titanate. The type of the ceramic chosen and its geometry greatly affects the piezoelectric properties. So piezo ceramics are popularly classified into 6 types. I will explain now only about type 1 here because in my research work, comparing with other types, I have chosen type 1 ceramics to be better suited for my research. It is a composition of lead zinconate and barium titanate and usually recommended for medium high power acoustic applications. It will not get easily depolarized at high electric and mechanical stress that makes it suitable for deep submersion acoustic applications. Usually, these 6 types fall under 2 broad categories. One is hard ceramics and one is soft ceramics. Hard ceramics have the property of low dielectric and mechanical loss. In addition, they have good electromechanical coupling efficiency, which makes it suitable to be used in both the transceiver and receiver side. The soft ceramics, though they are better in receiving a signal, have large dielectric loss, low mechanical quality factors, and poor linearity. So in my for my proposed work, after the literature survey, I have chosen hard type and type 1 ceramics for the transducer. Further, I would like to add some point upon type 1 ceramic over here. The composition of type 1 with lead zinconate and barium titanate exhibit greater sensitivity and higher operating temperature characteristics compared to other ceramic components. So the cost is greatly affected by the geometry and the potting of the ceramic used. So the geometry has direct effect on the radiated direction of the acoustic signals and the electrochemical properties of the ceramics like resonance frequency, capacitance, generated voltage under load, and displacement. Ceramics used for underwater communication are usually omnidirectional, and this property is exhibited if the height of the ring is small compared to the wavelength of the sound being transmitted. Usually, this piezoelectric transducer can be made of many ceramics cemented together with greater electromechanical coupling, power output, and electrical efficiency. If they are cemented with large amount of ceramics together, the piezoelectric constant as well as the coupling coefficients are double than one piece ceramic. But usually, they are very difficult to manufacture and more expensive. So for my research work, one piece modified hard type 1 ring transducer with radial resonance mode is chosen. So during the transducer construction, we need to give attention to the attaching electrical leads, ways of reducing unwanted acoustic radiation, as well as the potting of the ceramic. Cables usually must be shielded to enhance the transducer performance and also to avoid unwanted electromagnetic noise radiation. The transducer should also be encapsulated with a potting material in order to come in contact with any conductive fluid. For potting, we have a choice between the urethranes and the mineral oil due to its versatility. Then next comes the next part, the analog transceiver design. It consists of a power amplifier, power management circuit, an impedance matching circuit, and a preamplifier. Today, I will be discussing only about the power amplifier circuits. So the required characteristics for my proposed work is it should have a linear and it should also produce an undistorted output for a bandwidth of 10 to 100 kilohertz. So for my research work, I also need two specific characteristics, that is, it should also be linear and efficient. So After a literature survey among all the amplifier classes, after careful survey, I chose two particular amplifier types. One is class AB and one is class AC, class D amplifiers. In my proposed design, I designed the circuit in such a way that both of them work in parallel, meeting our design requirements of being linear as well as efficient. This is my proposed design of the transducer, and the primary amplifier here is a high linear class AB amplifier. The output of the class AB amplifier is connected to a current sensing circuitry that in turn controls the secondary amplifier, which is a class D switching amplifier. The class D amplifier is inherently nonlinear, but when works in tandem with class AB amplifier, produces a linear output. The class D amplifier provides high power efficiency, making it suitable for large power outputs. So next is to meet the design requirements of high sensitive, high gain, narrow bandwidth receiver. The architecture proposed consists of two stages. The first stage will consist of high pass filter, which consists of two cascaded filters with high gain. The second stage is a band pass filter used to further amplify the signals in the transducer's operating band. Care must be taken to amplify only the signals of required frequencies because we have to avoid the unwanted noise signals to be transmitted. Coming to the digital signal processing, the third component, because of its robustness, we have chosen to use a frequency shift keying as the modulation technique to be used in this particular design process. So still a lot more surveys and study has to be presented to make this particular project a full success. These are my references, and thank you.
Thank you, ma'am. So any questions from participant side? Okay. Next, I would call upon paper ID ICD PMS 0205, design modifications of heavy vehicle plastic component using molding process simulation by Mr. V. Ashok, Dr. R.E. Chandrasekhar. May I now request Ashok sir to give his technical presentation. I request the presenters to keep their presentation short and concise. Ashok sir, yeah, you can proceed. Ashok sir. Okay, he is facing some difficulties. Next, I would like to call paper ID ICD PMS 0415. Compensation on intelligent islanding microgrid with the UPQC by Mr. M. Vimalraj, Dr. M. Tamilarasi, Mrs. M. Revati, and Ms. L. Varalakshmi. May I now request Madam to give his technical presentation. Tamilarasi, ma'am.
Yes, sir. Yes,
Yeah,
sir. I'm sharing the screen. Good evening, one and all here, presented here. I'm Tamilarasi from Marine Engineering Department of Ahmedabad University. My co-author is Mr. M. Vimalraj, Assistant Professor of Civil Department at Audi-Parashakti College of Engineering. Today, I'm going to present the topic of about compensation on intelligent islanding microgrid with UPQC. The main objective of this paper is to, for the main purpose of the paper is for the voltage stabilization. This paper, the compensation on intelligent islanding microgrid, that is, compensation was achieved in 3 stages. That is, the first stage is by incorporating the UPQC microgrid. Without incorporating UPQC microgrid, second stage is incorporating UPQC microgrid, and third one is reconnection of the series and parallel filter. So this compensation, the compensation of the bus bar in power systems was achieved by using the intelligent islanding microgrid with UPQC. This paper mainly focuses on the integration technique of the UPQC microgrid reconnected technique by involving the reconnected technique. This is applicable for the bus bus two-line bus bus which was connected to the microgrid application. Microgrid is nothing but mainly grid is the main it represents the main power station. Microgrid is the substation. So here the advantages the proposed UPQC microgrid IR is nothing but the proposed UPQC microgrid reconnected system is nothing but unified power quality conditioner we are achieving for this two-line bus bar system. So this bus bar system is connected to microgrid and this bus bar is further extended to the two types of loads. The first one is the wind load and next one is the solar power panel. So the usually without UPQC arrangement of this bus bar to the power system will give lot of interruptions. That is we are receiving lot of ripples and the harmonics in the AC supply. So to avoid these ripples and harmonics and a lot of voltage stack variations, we are including UPQC microgrid in this concept. So the main advantages of the UPQC microgrid over the normal structure is it gives it avoids the interruptions and voltage stack, cell harmonics and reactive and it also provides a reactive power compensation also. So here we are including in the black diagram we are including two parts. That is first one is a active power filter series and next one is the active power filter shunt arrangement. So the active power filter series these both are initial in the separated stage, that is isolated stage. Then it is interconnected. After interconnecting these stages, we will again checking the harmonics and ripples in the third stage. So I am using this concept in three stages. First one is without UPQC, second one is by using UPQC, and third one is by interconnecting this both series and the parallel connections. What are the advantages we are receiving like that? So the interconnected part is mainly it mainly contains the interconnection of this microgrid with the storage system as well as the interconnection of series and parallel combination. So these two parts mainly known as the old UPQC MT microgrid interconnection. So here it is UPQC microgrid interconnection, so it's named like this. During the interconnected and islanded mode, here we are using DC converter with storage will supply active power only, and then that is here the shunt is used to this shunt filter is used for the to reduce the voltage variation. It is used to reduce the current variation, and the series filter is used to reduce the voltage variation. So by interconnecting these two things, we are achieving the benefits of the both. So this is the main concept or black diagram of my my work. So the active shunt filter is suitable for the current based compensation. Already I told the shunt is used for the current based compensation, and the series is used for the voltage based compensation technique. So here we are having two converters with one DC link. So it is known as the interconnected link. So this is a circle diagram without UPQC. Without connecting this UPQC arrangement, the simulation I have performed the simulation and I had received the output. These two outputs I had received from load 1 and load 2 side. Load 1 is the wind power, load 2 is the solar power. So the above simulation circuit is for two bus system transmission line bus system. It is connected to two loads. So if you are using these two loads means first you are connecting first load that is wind power, and secondly, we are connected to the solar load. During this transmission, it between the wind and the solar itself, it will take some lag, some time duration. So this interruption also creates some voltage variations. Mainly, these voltage variations are suppressed in my work. So the output voltage of load 1 and load 2, we are receiving like this. That is without UPQC. Without UPQC, I am receiving lot of voltage variations like this. And the simulation outputs of real power, reactive power, and the CHD I received like this. CHD is a total harmonic distortion. I am receiving the total harmonic distortion of about 25.37%. It's very high value. Then I am going to implement a UPQC. This is a simulation diagram of the previous block diagram. Then after implementing this UPQC, that is Unified Power Quality Conditioner, I received the output voltage of about in load 1 and load 2 is shown in this slide. So then the real power, reactive power, and frequency spectrum with UPQC are also shown in this slide. If you are referring this slide, the real power, reactive power also increases a lot, and the FFT in the FFT analysis and receiving the total harmonic distortion about 4.88% I received. While I am comparing the previous 25.37%, I'm it reduced a lot by using the UPQC arrangement. So this is the main advantage of a UPQC arrangement. So then UPQC with the island circuit. Island circuit means it is separately used in this simulation circuit. Means I am receiving the output voltage that is without interconnection. Without interconnection, I am simulating this. I simulated this circuit. Then I received the output voltage and current waveform like this. So the real power, reactive power by using UPQC island circuit, I received more or less without ripples and with the total harmonic distortion also reduced very much. So the UPQC, then the next stage of the UPQC is interconnected. That is the series and shunt, both of them interconnected, as well as the storage is connected to the DC link. The simulation circuit is shown in this slide. Then the output voltage and the current waveform I received like this. Then real power, reactive power I received in a perfect waveform without any ripples. So then I comparing the results obtained by the simulation. That is without UPQC, I received the total harmonic distortion of 25.37% I got. But with UPQC, the total harmonic distortion reduced of about 4.88% reduced. So nearly 21% amount of ripples, total distortion gets reduced by using the UPQC. Then comparison of real and reactive power. Then I'm comparing real and reactive power, that is with island mode and interconnected mode. Island mode is in separate series and shunt or in separate without interconnection mode. So in this, I received the output voltage of about 600 volts, and real power and reactive power of about 0.012 and 0.011 amount. But using the interconnected mode, I had received the output voltage of about 3200 voltage, and real power, reactive power also increased of about 0.024 and 0.356 like that. So I improved the voltage level as well as the real power and reactive power. So by using this paper, mainly focuses on the powerful control and integration techniques of the UPQC for microgrid reconnection technique in the microgrid reconnection technique condition. The current total harmonic distortion is reduced from 25.37 to 4.8 by using the UPQC, and real reactive power are higher, are also increased a lot. So the results show that the UPQC microgrid IR can compensate the voltage and the current disturbance. So the normal voltage compensation, mainly this scheme is used for voltage compensation. But by using the interconnected system, we are avoiding the voltage fluctuations or voltage disturbances. This is the main feature or main focus of my paper. So in islanded mode, we are improving, we are reducing ripples, we are improving the performance. But in interconnected mode, we are receiving all these advantages. That is, we are reducing ripples, reducing the total harmonic distortion, voltage is tagged well. So, the main benefit of this UPQC using microgrid interconnected is the voltage fluctuation. Voltage disturbances and voltage fluctuations are mainly reduced or mainly focused in my paper. Thank you, sir. So that's all my, thank you, sir, and over to.
Thank you, ma'am. Now the floor is open to question and answer session.
What type of DC converter you have been used?
Sir?
What type of converter do you have used here?
Here I am using the for compensation.
And the conclusion.
Here main here I'm connecting. I'm using for bus bar arrangement. For bus bar arrangements, I'm using the active power filter, series active power filter, and shunt active power filter with the isolated and integrated mode. Filters are connected in two series and parallel conditions.
What is the output of the solar panel?
Sir?
What is the output?
Output means the main focus is for reducing the harmonics as well as the ripples and the voltage variations. So the voltage fluctuations are avoided by using the UPQC microgrid IR connection.
So simply, if we are connecting UPFC, automatically the voltage compensation has been done, or any other parameter to be altered. So what are the parameters to be considered?
The main parameters I'm focusing here is output voltage and output current ripples. The main real power, reactive power and reactive power values also improved a lot. Real power, reactive powers are improved, and with reduced ripples and with a less amount of harmonics. Ripples reduction, harmonics reduction.
Okay, ma'am.
And
thank you.
Thank you.
So,
any other queries?
Hello?
Yeah.
Hello?
Yes.
This is for domestic application or industrial application?
It is for the UPQC microgrid application, means it's for a subsystem.
Substation.
Substation, yes, sir. Substation.
It's not home based.
Not home based. Home based means further you have to reduce the amount, further reduce the rating.
What is the expansion for PCC? Power control system? Power control? What is PCC?
PCC means point. It's a point coupling.
Power coupling.
Point of power coupling, sir. Between it links between the series and the shunt active filter. It connects the series and shunt active filter.
What is the S2 and S3 switches? Is it switches? Is it?
S1 and S3 switches are mainly used for open or close, or for isolating the circuit during an emergency or the emergency condition.
And what is this?
For open or close.
And what is this across the capacitor? What is this?
Which one, sir?
This one. Between S2 and S3, you have one.
S1, S2, and S3.
Across the parallel capacitor. What is that?
Across the parallel capacitor, sir, it is for filter arrangement, series filter and shunt filter, sir. Active power series filter, active power shunt filter.
The whole thing is okay. Thank you. Thank you.
Thank you.
Okay, thank you, ma'am.
Thank you.
I would like to call upon the last paper of the track, ID number ICD-TMS 0205, design modification of heavy vehicle plastic component using molding process simulation. It was given by Mr. V. Ashok and Dr. R. E. Chandraseelan, sir. May I now request sir to give his technical presentation. Ashok, sir.
Namlas, ma'am, kindly stop sharing of your screen.
Okay, sir. Okay, sir.
Ashok sir.
Okay. Sir, Ashok sir is not able to join as a panelist.
Anyhow, I also tried a lot,
but
couldn't connect. Anyhow, that's the end of today's session. Then tomorrow morning 10 o'clock we will have remaining sessions. Track 4, renewable energy system in onboard ship. Track 5, industry automation, and track 6, marine pollution. Thank you all. Have a nice day.
Mr. Aaron.
Yes,
Aaron?
ma'am. Yes, ma'am.
There are more papers to be presented in the other track, track 3. So I think 2-3 papers may be presented during your track. Is it possible?
Okay, ma'am. We can move. We can request.
Yes, ma'am. We will try, ma'am.
I came to understand from Dr. Sangeeta that 8 more papers to be presented. Please reorganize it.
Okay, we can move 2 more papers to our track.
Sure, ma'am. Sure, ma'am. We will have it here. We will try Ashok sir to get in. Right, sir?
Yeah,
he couldn't connect. Yeah.
We can start the presentation.
Can you distribute for tomorrow? Can you change it for tomorrow?
For what, sir?
This presentation, can you do it tomorrow?
Yeah, tomorrow also we are having presentation, sir. 3 more tracks.
Too heavy here.
Oh.
Too heavy.
Harry, sir.
Ashok sir has joined in the panelist since.
Is he there? Sorry, sir, that is the only pending paper in this track.
Okay, I will ask Sangeeta ma'am and get the DPD.
Yeah, sure. Sure,
Let me ask.
Sir, please organize it quickly.
Now make it come.
Aaron sir, what is happening?
No, sir. Actually, in other track, we are having more number of papers. That's why we are shifting some papers to this platform. That's what. In Google platform, 8 more papers are pending. It's very difficult to complete it there. That's why we are transferring.
Aaron sir, Ashok sir has joined Google Meet. There he was able to join. He said he will be presenting there.
There are already participants are more. Anyhow.
Yeah. Somehow we will be transferring them to here now.
Yeah. 2 more participants are going to join here.
Yes, sir. Bhupati Bhaskaran, sir. Principal, sir.
Yes, sir. What happened?
Yes, sir. Here in this track, we have finished all the papers. But in other Google Meet track, there are more than 8 papers there. So we are transferring some papers to this track. That's why we are seeing here.
Yeah, okay, sir. Speed up.
Yeah, sure, sir.
Actually, from here only you transferred it to Google. From now, Google again, it's coming to Zoom.
Sir, you can present here, no issues. So please add Muthu Bhaskaran sir in the panelist.
Sure. Yes, Muthu Bhaskaran sir.
Shall I proceed, sir?
Yes, please proceed.
Yes, sir.
Thank you, sir. Thank you. Thank you for this wonderful opportunity. So I am Dr. S. Muthu Bhaskaran presenting my paper for this international conference. Let me share this. Can you see my screen now?
Yes, sir. We can see, sir.
Thank you. So very good evening to present here again. So my paper title is TPM implementation in a manufacturing company. A case study. Hello.
Presentation mode.
Yeah, I will make it, sir. Okay. Can you see it, sir?
Yeah, can you able to
Yes,
see?
thank you, sir. Yeah, my paper title is TPM implementation in a manufacturing company, a case study. So in a case study company, we are planning to implement, implemented TPM to enhance the productivity as well as OEE, which is a major measure for implementing TPM. OEE is nothing but overall equipment effectiveness. So abstract. Effective functioning of any plant depends on maintenance. Even the companies are very much active in any production process, they are least bothered about the effective functioning of the machines. So it is the major part of productivity. So we have to pay much more attention to enhance the productivity. The maintenance, there are many maintenance strategies to improve productivity. One such method is TPM, which is total productive maintenance. So TPM is followed in many industries because it is a world-class maintenance technique as well as for increasing the productivity. TPM makes the cultural change in the shop floor. So under TPM, we can measure many metrics such as MTBF, MTTR. One such another metrics is OEE. OEE is the product of availability, performance, and the quality. So in this work, I implemented TPM to enhance OEE. Introduction part. So manufacturing systems as established over the period of time to be a global system and supply chains. Due to the growth of the manufacturing sector, it is the need of the hour to maintain the machines in a proper working conditions. It can be achieved by means of TPM, that is total productive maintenance. Literature review. I referred various journals for this work. Among this, I shortlisted the major contribution in implementing TPM as well as the metrics called OEE. Aguja and Kamba stated that globally Indian manufacturing companies intense competition in order to give the quality products at low cost and diverse products. They also need to achieve a world-class technique called TPM. Then Sharma and Trika presented the work on TPM in order to increase the productivity as well as OE in a piston manufacturing company. That is a case study company where it is got benefited by means of implementing TPM. Then Ravikant et al. Also implemented TPM in a thermal power plants to increase the productivity. They also identified the roadblocks to TPM in Indian manufacturing companies. Then Majumdar Manogar identified the failures of TPM. There are much more failures. It is not successfully implemented in those companies, which are very much essential in order to understand how to implement TPM in a manufacturing company. He also suggested TPM can be implemented as a tool of TQM, which is total quality management. Then Amit and Gaur show the effectiveness of TPM implementation in a thermal power plant. Then Nelson Raja et al. Proposed a metric called OLE, overall line effectiveness, instead of OEE, because the line effectiveness played a major role. Now, to understand the effective functioning of the line, we have to include each and every mission now to understand the productivity. So he coined a term called OLE. He also measured it and successfully determined the value of OEE. Then move on to TPM methodology. So in this work, how we proceed in implementing TPM in a case study company. Let me show this. We started with literature survey of TPM implementation. Then we move on to the case study company where we discuss with the management about this TPM culture, what kind of maintenance is carried out in that company. Then we study the current state of the plant where we are going to implement. Then we identify a shop floor within that plant, which is shop floor needed the TPM implementation. Then we conducted some brainstorming session with the employees and studied the historical records of maintenance carried out within the company. Everything were carried out. Then we also determined the OE, current OE of the line, that is the machining line. Then we identify the low performance machines, which is mainly responsible for poor productivity of the plant, especially the production line. Then we implement TPM. We gave the recommendations of implementing TPM, which can be carried out to improve the productivity as well as OEE. Whether OEE is improved. So it is very much visible that by implementing some of the tools of TPM, OEE can be improved. If it is not improved, again, we have to do such kind of brainstorming sessions and sort out the root causes. What are the setbacks for TPM implementation, roadblocks for TPM implementation? Then we can continue the TPM journey. So it is a continuous process. Once we achieve the benefits of TPM, we can carry out the TPM process in future also. So that is the TPM journey. So let me proceed here. Problem description. We know in the case study company where we implemented TPM. It is an automotive company where auto components are produced. So within that company, we found a shop floor where TPM implementation is very much needed. In that shop floor, we have 10 CNC machines, which is meant for producing steering knuckles. So each of these machines is specialized for different operations, which must be carried out in order to get a steering knuckle out of the production process. But due to the frequent failures on long time failures, and the productivity is very much disturbed, and it is necessary to identify those machines which are meant for the bottlenecks. So here we have the current data of the production line, starting from shift length, short breaks, meal breaks, downtime, idle run rate, total pieces, and rejections. So it is very much essential to go through all this data in order to determine the value called OEE, because OEE is the product of availability, performance, and quality. So we have 10 machines. So 480 minutes means 8 hours. In 8 hours period, we have 2 breaks, so short breaks, and one break, a 10 minutes break, and a major break, that is meal break, which is for 30 minutes. Then downtime. Machine undergoes several breakdowns. So it's the average downtime for a month is 45 minutes. The ideal run rate depends on the cycle time of the machines. So 140 per 8-hour period, we can produce 140 number of pieces of steering knuckle sets. Then we have the rejection rates. So in this way, we have to note at every machines, each and every machines of these values in order to determine the major metric called OEE, which is the product of availability, performance, and quality. So here we have this calculation part of OEE. So whatever the data given in the table, which are taken here, and we found each of these every terms related to the availability, performance, and quality, because availability is the calculation of operating time and the planned production time. Then performance is the calculation of total pieces by operation time by ideal run rate. And quality, good pieces by total number of pieces. So from these calculations, we can determine availability, performance, and quality, which gives the product of OEE, which is 67.64% in case of machine 5. This is before TPM implementation. There are huge opportunities in order to improve this OEE part. So because in the world class OEE value is 85%, so it is necessary to increase this OEE value. So before TPM implementation, for each and every machine is tabulated here. And this can also be successfully seen using these graphs. The OEE part is very much less than 70%, but the world class value is 85%. So we can increase the OEE by means of applying a technique called TPM. So you can easily see for each and every machine, it is less than 70%. The observations and recommendations. The major part of this production line is mission 6 and mission 7, because in these two missions, the downtime can be seen as 100 minutes for mission 6 and 50 minutes for mission 7. So these are the bottleneck missions, and we have to identify those problems which are frequently occurred in these missions by applying the technique called OEE, so that we can enhance the functions of these missions and in order to reduce the downtime and increase the productivity. So we apply this root cause analysis technique in order to bring back the missions to working conditions. So TPM implementation. So we found this missions which are very much problematic, and we implemented TPM. There are 8 pillars of TPM. Among the 8 pillars, we successfully implemented these 4 pillars called 5S: autonomous maintenance, focused maintenance, and preventive maintenance, in order to enhance the OEE of the machines. So first tool is first pillar is 5S. 5S is housekeeping. It is carried out by 5 different steps. Sorting, so remove the unwanted items. Then Satan, a place for everything in its place. Keep only whatever required, and remove the unwanted things and arrange the things properly in an orderly fashion. Then tidying, clean the workplace, which is very much needed. Clean and tidy is the mantra of 5S. Then standardize, whatever we done for S, sort, Satan, and shine, we have to standardize them. Then only we can continue the process, which can be achieved by means of training. Then Sitsuke is discipline. So this SS can be continued by means of training process. Training and rewarding. The employees are going to take this 5 years in their workplace. By means of training, continuous training and rewarding, then definitely they can do it. We have to maintain those discipline by means of Sitsuke. So these are the 5 years implemented now to bring back the workplace in a good condition. The next one is autonomous maintenance. This is another pillar of TPM. This autonomous maintenance can be carried out by means of training to the employees who are operating those machines. So they have to take full responsibility for running the machines in the good conditions. So they have this checklist having this part like cleaning of the radiators, drain the water in the FRL, fill the oil level, fill the FRL unit in the lubrication oil level, check the incoming voltage, clean the panel cooler, ensure panel temperature, and clean the cooling fan. This can be done by these operators who are operating the machines now to run the machine in the good working conditions. These are a checklist of the autonomous maintenance. Then next pillar is focused improvement. This focused improvement is otherwise called Kobatsu Kaizen. So this is nothing but we have to focus in those missions which are bottlenecks to achieve good working conditions. So we know the mission 6 and 7 are the bottlenecks or constrained missions, which can be seen by looking at the downtime value, where the root cause analysis carried out now to understand the mission failures, like frequency of failures, cause of the failures, etc. So here is a cause and effect diagram. It shows why the missions are failed to run properly. The cause of breakdowns. So mission breakdowns can be it is due to hydraulic failures, pneumatic failures, mechanical failures, electrical failures, and miscellaneous failures. Miscellaneous failures in the sense it is scrap accumulations, scrap in the conveyor belt. So this must be addressed. Otherwise, the mission can't function properly in the future. So these are the 5 different type of causes which having the effect of mission breakdown. So now we have the frequency of mission breakdown of 6 and 7. We have breakdown of mission 6 and 7. We know the types of failure, and breakdown frequency of mission 6 is due to these failures, like 12 for mechanical failures, 10 for mission 7 in mechanical failures, like tool and spindle failures. So we have to replace the tool periodically. Once the tool tip is getting damaged, it is not advisable to continuously use these tools. Then electric failures, drive problems, hydraulic failures, and the hydraulic oil leakage, pneumatic failures, air leakage, and miscellaneous failures, scrap accumulations. These are the common cause of failures, which are very much related to this type of failures. Then we have to do some corrective actions now to bring back these missions to the good working conditions. And we have done this kind of corrective actions on mission 6, which are having the common cause of failures, like tool comes out where arm crack absorbed, spare arm replaced, tool setup problem where drop bar disc spring replaced. These were carried out now to bring back the original conditions of the mission 6. Similarly, for mission 7, some corrective actions were carried out on all the 5 types of failures now to bring back the mission 7 to the good working conditions. Then preventive maintenance. Preventive maintenance in the sense we have to do some kind of maintenance work in order to avoid those failures which can be occurred in the future. Like we have to have this enough spare parts at any time. The replacement can be carried out. Check the electrical, hydraulic, pneumatic lines, cleaning the parts, remove the scraps or oil leakages, then having the enough tool spares which can be replaced once the maximum life of the tool is reached. Then scrap accumulations must be removed immediately. So this were carried out in order to do the preventive maintenance. So after TPM implementation, we can found that the machines were bring back to the good working conditions. So we know the mission 6 and 7 are the root cause of the major disruptions, and we found that the OEE value is enhanced after TPM implementation in each of these missions. For mission 6, it reached up to 68.72%. For mission 7, it reached up to 77.52%. We can see that up to 8% of OEE in terms of mission 6, and 12% of OEE for mission 6, and 17% of OEE for mission 7, which is the greatest achievement in terms of TPM implementation. Conclusion. So we implemented the world-class technique called TPM in the production line by undergo 4 different pillars of TPM called 5S: autonomous maintenance, focused maintenance, and preventive maintenance in order to enhance the OE of the production line. Thank you. Thank you very much.
Okay. Now the floor is open to question answer session. If you are having any questions, you can post your question. Okay, thank you. Next, we would like to call paper ID ICD TMS 0605, numerical heat transfer analysis of automobile radiator by KM Pradap and J. Aspen. This is the last paper in this track. Yeah. I request the presenters to keep their presentation short. 1 minute. 7 minutes. Yeah, you can share your presentation. Please unmute your mic, sir. Yeah.
Sir.
Yeah, now it's audible. You can go ahead.
Okay, sir. Good evening, sir. I'm Department of Mechanical Engineering, Amat University, and our ICT paper presented by K.M. Pradap and J. Ashwin, Department of Mechanical Engineering. Next page, Ra. Our project title, Numerical Heat Transfer Analysis of Automobile Radiator. The paper ID ICD-TM S0605. Dr. Madesh and K.M. Pradap J. Ashwin. Next page, Ra. Introduction. With the radiator or heat exchanger used to transfer thermal energy from one medium to another for the purpose of cooling and heating. The radiator is a device conducting of a large amount of cooling surface containing large amount of air so that I spread through the water to cool efficient. The radiator has wide range of application in automobile industry used to cool the internal combustion engine in the automobile. Radiators are usually made for copper and brass because of the high heat conductivity. The various sections of the radiator are almost completely joined by soldering. Type of radiator: tubular type, cellular type. Construction of radiator, it consists of an upper tank and lower tank and between their core in a spectrum. Radiator cooling system. In radiator cooling system, the upper tank is connected to water outlet or outlet from the engine jacked by hope pipe, and the lower tank is connected to jacket inlet through the water pump. The core is radiating element which cools the water. Radiator working principle. The radiator is pretty single device. Nowadays, most modern cars use aluminum radiator. The radiator usually have a tank on each side, and inside the tank is transmission cooler. Metallurgy. In our literacy survey, that find problem identification and objective. Through objective, we find modeling, meshing, and analysis. After result and discussing to find a conclusion. Next one. This is my design of radiator. The radiator specification: pipe diameter inlet and outer 25 mm, thickness of pin 3 mm, width of the pin 15 mm, diameter of cooling pipe 7 mm. The radiator core height 360 mm, radiator core width 30 mm. Number of fin columns 6 mm, total number of fins 6, and total number of pipes 10. Distance between two fins 15 mm, distance between two pipes 19 mm. Literacy survey. Problem identity. Radiator plays a vital role to improve the performance of an engine. The radiator performs entirely depends on the properties of coolant use. In general, the water was used as coolant for moderate speed vehicle engine. The if-speed application, the water heat transfer coefficient not sufficient to meet our requirements. Hence, I have chosen nanofluid as coolant to get the improved heat transfer coefficient fluid. Objective: to conduct the heat transfer study in the radiator to develop the radiator model in SolidWorks. To do analysis using ANSYS CFD software. to compare the result with conventional fluid, optimize the performance of radiator. So our modeling radiator, assembly view, front view, detailed view, and SolidWorks stepped next. Boundary condition. In boundary condition, we have used water liquid, air liquid, and aluminum liquid in extra. Next. On the previous paper. பின்னாடி வாடா நெக்ஸ்ட் அதுதான் and inlet temperature 385 Kelvin and outlet temperature 323 Kelvin. The next page. And result, I have to find heat from upper is in the next border. Conclusion. Efficiency of the radiator design from the above analysis report clearly show that the first fin to second fin drastically fall down the temperature of the inlet. Hot water, since fourth conversion pad nearly 50% hot water inlet temperature come down. The initial hot water temperature of 385 Kelvin to 323 Kelvin reduced in the aluminum tube length of 360 mm. Hence, this design is most efficient when compare the conversion pad distance of 15 mm, nearly 10K reduced. When change the material of the radiator, efficiency may get changed. Yes, sir.
Any queries from the audience? Okay. So, Madam, shall we wind up this session today?
Sir.
Any more papers?
Yes, sir.
No. Dean, ma'am?
Sure, sir. Thank you, sir. Thank you very
Okay.
much. Thank you all
Okay.
participants.
So, thank you all the presenters, those who have participated in our conference. So then today's sessions ends with this paper presentations. So tomorrow sessions will be resumed in the same Zoom platform by 10 p.m. Now we can exit the meeting.